Hi, I'm Aaron F. Ross, and I'd like to welcome you to 3ds Max 2013 Essential Training. 3ds Max is a top-tier application for digital content creation. Here are topics we'll be covering in this course: modeling with polygons, curves, and division surfaces, defining shading properties with materials and maps, setting lights such as spot and lights, adjusting camera position and field of view, adding objects with keyframes and controllers, keyframe editing in the curve editor, cutting and animating hierarchies, and final output rendering to an image sequence. I've been using 3ds Max and its predecessor 3D Studio since the early 90s, and I'm happy to share my experience with you. So let's dive into 3ds Max 2013 Essential Training. I'm Aaron F. Ross, and I'd like to welcome you to 3ds Max 2013 Essential Training. 3ds Max is a top-tier application for digital content creation. Here are the topics we'll be covering in this course: modeling with polygons, curves, and division surfaces, doing shading properties with materials and maps, lights such as spot and on lights, adjusting camera position and field of view, painting objects with keyframes and controllers, keyframe editing in the curve editor, constructing and animating hierarchies, and final output rendering to an image sequence. I'm using 3ds Max and its predecessor 3D Studio since the early 90s, and I'm happy to share my experience with you. Dive into 3ds Max 2013 Essential Training.
Subscriber to lynda.com, then you can download and install the exercise files for the course. I've got them here on my desktop, as you can see. If you're not a premium subscriber, then you can create your own exercise files folder, as we'll see later in the course. In that exercise files folder, you will see numerous subfolders, and these are created by 3ds Max. This is a 3ds Max project folder structure. All different types of files are kept in specific locations. For example, in the Scenes folder, we got a bunch of 3ds Max.max files organized by chapter. Again, if you're a premium subscriber, then you can download these. If you're not, you can create them as you go through the course. I'd like to take a moment to show you how to change the color scheme of the 3ds Max user interface. This can be helpful. We all have our own preferences. I prefer a lighter interface because I find that the white text on a black background is harder for me to read. I'm just going to go into the Customize menu and choose Custom UI and Defaults Switcher. In this dialog, we've got two sections. On the left are the tool settings. This lets you choose the default behavior of the tools in 3ds Max. And as you click through these different options, it'll actually tell you what those options are. Usually, you'll just choose Max, which will be the default 3ds Max tool settings. At the moment, I'm more interested in the other section here, which is the UI schemes. And I'm going to choose AME Light, which stands for Autodesk Media and Entertainment. Click that button. Don't be alarmed when the screen flashes. 3ds Max is just loading up all the icons, and you will see a message that says the default settings will take effect the next time you restart 3ds Max. I do recommend that you shut down 3ds Max and reopen the program before continuing. That's how you change the user interface color scheme in Max. Let's in 3ds Max and simplify the interface a little bit for teaching. First of all, you'll see that you may have this big area of the interface here called the graphite ribbon. I'm going to shut that off because we won't be using that until later in the course. So click this icon on the main toolbar, and that will take the graphite ribbon away. I'm also going to hide this thing here, which is called the view cube. If you click on that accidentally, it kind of does things to the interface here. So I'm going to choose to disable that by going Use, View Cube, Show View Cube, and that'll turn it off. Go into the 3ds Max Preferences. In the Customize menu, I'll choose Preferences. Most important thing I want to point out to you right away is the Help tab. Click on that. And see that the help files for 3ds Max are by default hosted on the Autodesk website. It can be problematic if you're not connected to the internet, or if you're on a slow connection, or if there's a server load on that day. So I don't recommend that you use the website. I actually recommend that you click local computer/network and then click the download button. That will take you to the 3ds Max website where you can actually download a full copy of the help. Then once you've placed it in the appropriate location, you can go back into this preference settings and click Browse to point at where you've installed that help documentation. Or here in the preference settings, I also want to go to the Files tab, and there's a very important setting in here that I want you to enable. As file handling, convert local file paths to relative. And we enable that. And what that's going to do is ensure that when we add assets to our 3ds Max project, the location of those assets will be recorded relative to the current project folder, and not an absolute path that is recorded relative to a particular computer or drive letter or volume name. This will become a little bit clearer as we go forward in the course. But the reason I'm doing this is to ensure that when I create a project folder in 3ds Max, that folder will be portable, and I will be able to move my assets to a different machine or a different folder on the same machine, and the links to all of the files will not get broken. So I've enabled Convert Local File Paths to Relative. And those are just a couple of the most essential preferences that we need to set in 3ds Max before we begin. Before we can really begin, we set 3ds Max to a project folder. Project folder is a way of tracking assets, of managing the links between multiple files. 3D programs are different from 2D programs like Photoshop. Photoshop, you open a document and everything that you need is right there in that one file. But in a 3D program like 3ds Max, you're dealing with lots of different files. Load a scene file which has your geometry and animation, but that's linked to, for example, texture files or images on disk. And in order for all of those links to be preserved, you need to have some system for doing that, and that's called a project folder. Up in the upper left-hand corner of the 3ds Max interface is the caption bar, and this button over here on the far right is called the project folder button. And I hover my mouse over that, you will see it says my current project is in the Documents folder. That's the default project. What we're going to do now is going to either create a new project or set to an existing project. If you are a lynda.com premium subscriber, then you can download the exercise files and then use this command to point at that folder, and then all links for the exercise files will be preserved. If you're not a premium subscriber, then you create a new project folder using this same button. It is in fact a 2-in-1 command. I'll click that, and on my desktop I've placed exercise files for the course. Open that up so you can see that there are a bunch of curiously named folders inside that. It's very important at this stage that you make sure you're clicking the root level or the top level of the project folder structure. If these curiously named folders are inside the currently selected folder, then 3ds Max will simply set to that project. Notice that will be the new home base for all assets. But if there isn't a project folder inside, for example, if I click on this Archives, there's nothing inside that now. If I click the OK button now, what would happen is 3ds Max would create an entirely new set of project folders inside this existing project folder. I'd have nested project folders, one inside the other, and I'd go right down the rabbit hole, and that wouldn't be a good outcome. So make sure that you're selecting the root level or the top level of the project folder. And again, if you don't already have an existing project folder, then you can just create one wherever you like. Okay, and if I go back and hover my mouse over that button, you'll see that the current project folder is now the exercise files for the course. And now you set a project folder in 3ds Max. The essential components of the 3ds Max user interface. Previously, I mentioned the caption bar up here, which you'll find the most common file commands like open and save. There's also an application menu here, and that gives us access to some of the deeper file commands like importing a foreign file format, for example, from AutoCAD. The menu in 3ds Max is kind of a limited menu. It doesn't have all of the commands that you will need. A lot of these commands are actually redundant to other places in the interface. And there are, in fact, quite a number of commands that don't show up in the menus at all. They'll be familiar to most of us, and it's a cascading set of menus. Below the menu bar is called the main toolbar. And it gives us commands such as moving objects. There are many toolbars in 3ds Max, and most of them are hidden. I right-click on an empty spot on the main toolbar. I'll get a list of all the possible toolbars. For example, the axe constraints. That's one that we'll be using later. The toolbars are dockable, and I just drag them around and drop them wherever I want. So that's convenient. I've got one here on the left-hand side. It's called the Viewport Panel Layout Toolbar, and it's kind of actually empty. It's taking up a bit of space. So I'm going to right-click and hide the viewport layouts. You don't really need that. The main area of the interface is taken up by the so-called viewports. And we've got a perspective view, which is like a camera. And we've got front, top, and left views, which are called orthographic views. And those are like engineering design documents. They're just 2D representations of objects. Right-hand side is something called the command panel. And this is really the heart of the program. And the command panel has subpanels within it. We'll be looking at all these. Command panel is also resizable. You can drag in order to get larger, and be undocked as well. You can just right-click and choose float. It helps sometimes if you have two monitors. And drag it back over there and it'll dock back to the interface. At the bottom of the interface, we've got animation controls. We've got a timeline that's listed in frames. There are a bunch of buttons for doing things like creating animation. There are transport controls. And also, most importantly, at the extreme lower right-hand corner are controls for the viewports themselves, so that you can navigate within your scenes. We'll be covering all of these in greater detail later in the course. For now, that's a quick introduction to the main components of the 3ds Max interface, what they're called, where they are, and how they work. Creating objects in 3ds Max is quite simple and interactive. All you need to do is go to the Create panel. It's open by default. In that Create panel are a bunch of subpanels for creating different types of objects, and the default one is Geometry. Language of 3D, geometry refers to models or objects. So for example, I can create a box. I can click on that button, and to create the box, I'll go over to this perspective viewport and click and hold the mouse and drag it out. Continuing to hold the mouse as I do this. And you see in the Create panel that I'm getting numbers that are indicating the length and width of the box. When I release the mouse, then I can drag upward to set the height of the box. Finish with that box, I can click again to complete that box. If I haven't clicked off of anything, then I can still go over here to these parameters and adjust the length, width, and height of the box. If I click again in the viewports, I can click another box. Let's click and hold, and release, and then drag up to set the height. Finish making boxes, I can choose a different tool, such as the Select Object tool up here. I will turn the Box Creation tool off. I could just right-click in the viewport, and I will exit out of Box Creation. Once I have made objects, then I can adjust their parameters by going to another panel called the Modify panel. If I select an object, once again I have access to its parameters, such as length, width, and height. Select a different object and adjust its parameters as well. These are primitive objects, just building blocks. I can go back to the Create panel and make other primitives, like a sphere. Sphere is easier because it only has a radius. I'll just click and drag and release. Finish making objects of that type, I can right-click. If you're comfortable with a menu interface, 3ds Max does provide that functionality. You can also go into the Create menu, choose your object type, such as a standard primitive cone. And for each one of these primitive types, you'll have slightly different creation methods. With cone, I'll click and drag to set the radius, release mouse and drag up, set the height of the cone, click again, and drag to set the radius. Finally, click yet again to finish that cone, and right-click to edit the tool. So primitive has slightly different creation methods. When created an object, you can go into its Modify panel, adjust its parameters. A quick introduction to creation and modification of objects in 3ds Max. Scene. You'll want to use the 3ds Max viewport navigation controls to view the objects from different points of view. It can be done from the icons at the extreme lower right-hand corner of the interface. For example, the hand, that you move left and right and down in viewport, either perspective or in these orthographic 2D viewports. You also got a magnifying glass, which will let you move forward and back. Most helpfully, an orbit tool, which is this one here. So I'll click on orbit and activate a viewport. And make sure that I click in the center of the circle here. The reason for that is that as long as I click in the center of that circle, then my horizon line will remain level. And the outside here, I'll get what's known as a Dutch tilt or a canted angle. And that's almost never a desirable outcome. So how do we get back to where we were? Well, of course, I could try to tilt it back, but I'll never really be sure if I get it exactly right on the money. There's numerical input for this. This leads to a discussion of undo for viewport controls. 3ds Max, like many 3D programs, had actually two separate undos. There's an undo buffer for scene commands, like moving an object, and there's a separate undo buffer for viewport commands, like orbit. So if I hit Control-Z, or if I use the undo button up here, that will actually not undo the viewport move. And in fact, I might undo something that I didn't intend to, like creating a box or whatnot. To undo a viewport command, you can go to the name of the viewport, in case perspective. Click that, and then you've got an undo command here. And you notice that it's got a shortcut here, which is Shift-Z. So I hit Shift-Z, and that would do the same thing. So that you can use the viewport navigation icons in 3ds Max. What you find, though, is that these will tend to slow you down. And it's better and easier to use the hotkeys. We'll cover that in the following movie. Hotkeys are incredibly useful in any 3D program. It'll free you up from having to worry about clicking on icons just in order to be able to move through the scene. So really, we'll want to memorize the viewport navigation hotkeys. Luckily, 3ds Max is quite a simple matter. All about the middle mouse button. Choose the Select Object tool, so that you can see I do not have any viewport navigation tools active. And on the middle mouse button, it lets me navigate left and right and up and down in any viewport, moving my point of view left and up and down. If down the Alt key, middle mouse button in an active viewport, then lets me tumble. This is preferable to using the icon because I'll never get a Dutch tilt or get a canted angle this way. The horizon line will always stay level. Move forward and back in your scene, it's Control and Alt and middle mouse button all at once. And that'll dolly forward or back in any viewport. A little easier way to do this is just to turn the mouse wheel if you got one. And that also dolly forward and back, but as you see, it's doing it in increments. You need finer control. It's Control, Alt, and middle mouse. Another really useful hotkey is to minimize or maximize a viewport. There's a button for that in the extreme lower right-hand corner of the interface. Minimize viewport toggle. Click on that and maximize the current viewport. But that's going to slow you down. The hotkey is much faster, and it's Alt-W. That'll maximize a viewport. I want to warn you about something that could be problematic, and is orbiting in an orthographic viewport. If you click on one of these ortho views, like a 2D front view, and tumble in it or orbit in it with Alt and middle mouse, be converted to something called a user view. And this might be useful to you if you're an engineer and you're used to working with isometric drawings and so on. For us, it's going to be confusing. We change the behavior of 3ds Max so that this will not happen. I'll go ahead and undo those rotations a couple times. And back to a standard 2D orthographic view. I'm going to set a 3ds Max preference so that that will not happen again. Customize user interface. And I'll go to the section that says mouse. And I'll activate this switch that says lock orbit in orthographic. And that way I don't need to worry about that happening accidentally. When I try to orbit in here, I get a little do not enter sign. Make sure that those 2D views are always locked to the grid. Those most essential keyboard shortcuts for navigation viewports in 3ds Max. Objects in 3ds Max. Moving and rotating objects is called transformations or transforms. And the tools are found on the main toolbar. And move. So click on that. Now I've got the move tool active. And if I choose an object, the tripod, which is called the transform gizmo or the move gizmo, and it'll let me move an object any one of the 3 directions of 3D space. I've got X, Y, and Z. I'll do that in any viewport. Pretty simple, pretty basic. Most 3D programs have a similar method of manipulating objects. It's the move tool. The for that, by the way, is W. And very common in most 3D programs. So I've got the select object tool active. Just press the W key on my keyboard to activate the move tool. Next to the move tool is the rotate tool. Get in a little bit closer on this. I'll right-click in my perspective view, and that way I'll preserve the current selection and maximize that view with Alt-W. Get a little bit closer. I can use the Z key as one way to get in closer to a selected object. Z or zoom. The rotate tool has 3 axes as well. I can rotate around X. I can undo that. I can rotate around Y. Can rotate around Z. You can see as I do this, I'm getting numerical feedback in these. Very straightforward. Shortcut rotate is E. So W is move, and E is rotate. Undo that rotation. I hit Control Z back to a neutral rotation. You'll also notice that there are numerical values at the bottom of the screen here. If I wanted to restore that rotation back to 0, I could just type in a 0 down here. Move and rotate. There's scale on the main toolbar. It's the third in the holy trinity of transforms in 3D. Move, rotate, and scale, or position, rotation, scale. That'll become clearer when we talk about hierarchies. I want to discourage the use of the scale tool at this point. Go ahead and stretch this box in various ways using this scale manipulator or scale gizmo, but actually cause unforeseen consequences later on. Control Z to undo that. Mention at this stage that since we have a procedural primitive or a primitive box here, I could just go to the Modify panel, change its height directly by clicking on one of these little arrows, which is called a spinner, down the mouse and just dragging that up and down. That's a better way of adjusting the shape of a primitive instead of scaling. For reasons that will become clearer when we talk about hierarchies or linkages between objects. When we have linked objects, scaling can become a problem, and we'll be covering that later. Basics of how to transform objects in 3ds Max in the move and rotate tools. Into the transforms in 3ds Max to talk about axis constraints. You've seen you can use the move tool or the transform gizmo, to position objects in the scene. The transform gizmo is actually just a shortcut toolbar called Axis Constraints. I'll open that up for you. I'll right-click on an empty spot on the main toolbar and choose Axis Constraints. See, as I choose X, Y, or Z on Move gizmo, the Axis Constraints toolbar is updating. Sometimes the Transform gizmo will actually get in your way, and we will see this later when we get into spline curve editing. And that you know, you can turn the Transform gizmo off as needed. That you could use the X key on the keyboard. Press X. The Transform gizmo is not displayed, but I can still see which axis I'm constrained to. You'll see that red line indicating the X axis. I can use the Axis Constraints toolbar to switch to the Y axis, which is elevation. I need to undo that. Additionally, I've got the ability to choose two axis constraint, like X, Y, for example. Now I click anywhere on my object, I can move it in X and Y, but Z. I'll press X key again to turn the Transform gizmo back on. See, you can actually do the same thing with Transform gizmo itself by clicking on one of these brackets here. That'll pin two axes at once. Basic introduction to axis constraints in 3ds Max, and it's important that you know this because sometimes you'll need to turn the Transform gizmo off. In them, you have a choice as to how you can see objects in the viewports. Well, do you want to see the surface of the object or just its wires? To it's a little bit better, let me create a ground plane. Create panel. Standard plane. Drag that out. Release mouse. So that you can see, in fact, that there are shadows. 3ds Max viewport. Right-click to end plane creation. So if you move an object up and around, you can see it's actually casting a shadow. If you're working on more modest hardware, you have a fancy video card, and if your scene is running a little bit sluggish or for whatever reason, you can choose different shading modes from the item on the far right of the viewport panel menu. Currently says realistic. Click on that, I can choose different modes, such as shaded. An simpler display mode will run faster on more modest hardware. Also choose wireframe. And in fact, there are a lot of really cool things you can do in here. For example, there's stylized modes. And what that looks like in a colored pencil. Interesting. And in fact, you could actually render it this way. Back to shaded. We do that in any viewport. Use a wireframe or a shaded mode in any view through the menu. However, you're probably going to want to use the shortcut keys. It's going to be faster and easier. B on your keyboard will switch between a wireframe and a shaded mode. Toggles the state of the shading. Click on a viewport and press F3. Times when you're modeling, you will find that you need to see not just the shading but also the wireframes at the same time. Optimize this perspective view with Alt-W. Select an object and go to its Modify panel, like this here. You notice that we've got settings for example, level of detail, the number of segments to a sphere. See, as I click and hold this spinner and drag it up and down, I don't really see much change in the viewport because I can't see the wires. If you F4 on your keyboard, you'll be able to see wires and shading at the same time, and this is very helpful. It's important that you know what the level of detail of your model is. You can't see the wires, they really know what the structure of that model is. And when you're modeling, it's a good idea to view it in this mode, which is called edged faces. And you'll set up here, it says shaded plus edged faces. When F3 toggles between wireframe and shaded, and F4 enables and disables faces. You're probably going to want to lay out the viewports in different ways. So far, we've only seen two possible viewport layouts, the standard 4 viewports and single viewport maximized with the Alt-W keys. There are different ways for you to customize the viewport layout so that, for example, you can have one big viewport and 3 smaller ones. Right now, I've hidden the toolbar to do that, but let's re-enable it. I'm going to right-click on the main toolbar and choose Viewport Layout tabs. And now that toolbar over here that has only one option in it currently. But click on the arrow, I can use different layouts. So for example, as I said, I can do one large viewport and 3 smaller ones. When I click on that, it's now added just of possible layouts here. That's useful because I can click to a quad layout, click to that 2-column layout, just by clicking on that button. If you add more of these here, it'll sort of back to the standard 4 viewport layout. There's a way to do this as well. I can turn that View Layout tab off. I go into the configuration for viewports. On the plus sign in any viewport, configure. And there's a lot going on in here. We can completely customize everything in the viewports from within this dialog box. So for example, I could go to the layout, do things like use a different view. And say, instead of seeing the front, I want to see the back, for example. Again, store it back to the front. The 2 different ways that you can change the panel layout in 3ds Max. To modeling in 3ds Max, let's take a look at 3 different ways of modeling an object in a 3D program. If you know about the different types of models and how they work, then you can better make decisions about which tool to choose for the particular job. On the left is a polygon model. The hallmark of a polygon model is that it's built out of all straight lines. And select an object within that model. It's made of only straight lines. I'll press F4 key so we can see that a little bit better. Polygon models excel at shapes that don't deform and that have a kind of a rigid appearance. Simplest of modeling types. Center here, we have a curve-based model.
The Modify panel is active. Select the base of this cocktail table. See this little panel opening up that says NURBS.
That's an acronym that stands for Non-Uniform Rational Basis Spline. This is a curve-based modeling technique. So for example, if I go over to this panel, I can click on Curve, and I select one of these curves. There now. Click on that. And if I move it, you see that I can change the shape of the curve-based model. I can maybe scale it or do different things to it to change it. And the surface is derived from those curves. It's the primary characteristic of a NURBS model. It's a surface based upon curves. On the far right, I've got something called a subdivision surface model. This is the best choice for character and creature modeling. You need to model an organic living thing. The subdivision surfaces is the best way to go. There's going on over here in this panel, but I just want to show to you that if I go into a vertex mode here and turn on options so I can see the end result. What we're looking at here is the structure of a subdivision surface model. And the key to sub-Ds, as they're called, is you have a rough polygon approximation of that surface that's called the control cage. Underneath that, you've got the actual finished model, which is surface here. In a subdivision surface model, raw polygons are used to generate a more highly detailed surface. Those 3 main types of models, and those are the 3 that we'll be looking at in 3ds Max. Add the basics of modeling in 3ds Max. And this is our first exercise. It's this interesting twisty archway that's going to be a good illustration of two basic concepts in 3D modeling. The first is procedural modeling, a very high-level approach in which you're performing very large adjustments and based upon deformers and other types of effects that you can add to change the shape of the model. For example, the number of twists in this model. I do that just by adding a twist deformer and adjusting the number of twists. And that's a very high-level approach. We'll be looking at a low-level approach, which is a sub-object modeling or component modeling. And we actually go down into the individual parts of the model and select them and manipulate them directly. And that's why I've created the base of this archway. Fresh, by resetting 3ds Max, I'll go to the application menu and choose Reset. This is an important command because what it does is actually flush everything out of memory and restore 3ds Max back to default settings, as if you had closed the program and reopened it. Click Reset. Before I build anything, I need to get my units set up. In 3D, there actually is a sort of fake virtual world that has a real size. And when you build something, you want to build it to scale convention. In other words, if it were a human being, for example, it would be something like 5 or 6 feet tall. Important that you get your scale sorted out before you construct anything. Otherwise, you may have problems later down the line when you have objects modeled to different scales and you need to try to put them all into the same scene, and it's a mess. I'll customize menu, choose Units Setup. Dialog, you'll see a section that says Display Unit Scale. Indicator that what you're changing here is just the display. In other words, what is the unit of measurement that you want to choose to measure objects in your scene? Use the metric system, perhaps the US standard imperial units. I'm going to choose feet with decimal inches. Below that, you will see default units, feet or inches. It just determines how 3ds Max will interpret a keystroke. I type in a 12, in this case, it would interpret that as 12 feet. If I inches and typed in a 12, it would interpret that as 12 inches. Feet. And click OK. Now construct an object like a box. In the Create panel or the Modify panel, I'm seeing values in feet and inches. I'll go to my panel and seize to 3, press the Tab key, 3, and 3. Now a cube that's exactly 3 feet in all directions. I have options about how I enter these values in. For example, if I choose the height field, type in 18 inches, and press Enter, 3D Max will interpret that as 1 foot and 6 inches. Likewise, if I typed in 2.5, 3D Max interprets that as 2 feet and 6 inches. Back into my unit setup and change my unit of measurement, and that does not affect the actual size of the object in the scene. In other words, objects have an absolute size, and the units does not change their size. Customize menu, choose Unit Setup. I could swap this over to metric. And when OK, now immediately all the values are reading out in metric values, 0.14 meters instead of 3 feet. And that's back and forth at will. It won't break my scene and won't cause any problems. Because people in different countries can work on the same scenes and choose whatever unit of measurement is convenient to them. Let's quickly take a look at this sub-dialog called the System Unit Setup. I'm going to click on that. System Unit Setup controls the internal accuracy of 3ds Max. Usually you won't want to change this, and you only wouldn't change it after you've started modeling. You would change this value before you begin modeling, because if you change it later on, bad things can happen. If you the accuracy of the program, it might cause models to crumple or things to not render when you try to output them to an image and so on. This should usually be set at 1 inches, which is the default. The only time you would want to change this is if you needed to model something very large. And by that, I mean something larger than a city. The other time that you might need to change this is if you are working with a game engine or some real-time simulation that requires a particular system unit scale. However, 99% of the time, you want to just leave it at inches. appropriate for scenes that are modeled smaller than, let's say, a square mile or so. Setup. And the thing that we'll want to do is set up the grid, because grid is in fact an independent consideration. We'll look at that next. The grid in the viewports in 3ds Max is a very important consideration. To be able to tell from a glance how large something is just by looking at the grid. Separate consideration from the units of measurement. A little bit here in the front viewport by just turning the mouse wheel. And position this cube a little bit. What I see here is that this cube, although it is 3 feet by 3 feet, the lines are not lining up with that. What you see is a grid line every 1 foot. Not the default in 3ds Max. If you start a new scene, you'll need to check in on the grid settings. They can be adjusted from the Tools menu, Grid and Snaps, Grid Snap Settings. There's an easier way to get to that dialog. Really just to right-click on any one of these magnet icons on the main toolbar. All right, and it opens the Grid and Snap Settings dialog. What we're in with here at the moment is grid. I'll click on that and see what's going on here. The grid spacing is not every 1 foot, every 10 inches. And I have a grid line every 1 foot. I'll type in a 1 here. Press the Tab key. There we go. That's much better. And the next thing down here is how often do we want to see a darker grid line? So I have 2 different colors of grid lines. We've got lighter grid lines and darker ones. This line as it is now, I'm getting a minor grid line every 1 foot and a grid line every 1 times 10 or every 10 feet. From here is the perspective view grid extent. How far does the perspective grid extend from the origin or the center of the world? And currently it's a 7 feet to 20 feet, and press the Tab key. My grid up, I can see the Grid and Snap Settings. I'm ready to begin modeling. We're up our archway. And the way we're going to learn a little bit about level of detail. Box in this scene already, I'm going to keep that box as a reference, human-sized object. Height to be 5.5 feet. Width 5. And the length 2 feet. Now a box that's approximately the size and shape of a human. And I'll keep that as a reference. Just move out of the way a little bit. Now arch proper. Go to the Create panel. Click Box. Complete box creation mode. And rename it and change its color. Like that from the Create panel or from any of the other panels, like the Modify panel. On this swatch. Its color by clicking on the swatch here. Not the material of the object, this is merely the wireframe color or the object color. At the top, we can choose between a 3ds Max palette and an AutoCAD palette. The AutoCAD palette because it gives me more options. And I'll set this to be a neutral gray. By the way, I'm also going to switch off the switch that says Assign Random Colors. That way, the next time I make an object, it'll also be assigned this neutral gray color. I'll try setting the dimensions of the box. The width I'll make 2 feet. 2 Tab key. It'll be a box that's going to eventually be bent and twisted into shape in order to make the archway. Or it'll need to be pretty tall. A height of about 30 feet. Optimize that view with Alt-W. Talk about level of detail. Level of detail refers to how heavy the model is or how much detail is present in the model. And this is a very low level of detail currently. Press the F4 key so we can see the edged faces. This cube is constructed out of 6 flat faces. What I'll do eventually is bend it and twist it, and in order to make that happen, I need more detail on the model. Increase the height segments here. I can hold the mouse button and drag upward, and those height segments to, let's say, about 30. Now I have enough detail that if I want to bend this thing, it will actually bend. something called a modifier. That would form the shape of the current model. In the Modify panel, you'll see Modifier List. And click the arrow, I'll get a list of many different modifiers. And one is actually near the top, Bend. And I've got a bend angle and direction. Once again, if I click and hold my mouse on one of these spinners and drag it, I can adjust the bend angle. And working just fine. In fact, this has lots of detail to it. It's a segmentation that's able to bend. But if I were to change the level of detail, then it wouldn't necessarily bend so well. Modify panel, I've got something called the modifier stack. And this layers-based interface. I've got a box, and above that, a bend. If I click on box, I've descended down in that level of the modifier stack. And I can do things like change the height and the number of segments. If I reduce the number of height segments, then you'll start to see the effect of a lower level of detail. Down low enough, it starts getting pretty blocky. If I go down to only one segment, then it's not even a bend anymore. It just becomes this weird skewed box. Polygon models are only built out of all straight lines. And we make a primitive here in 3ds Max. It's a polygon model. In order to get the illusion of curvature, you need lots of short straight lines. Segments back up to 30. Level scale is very important. We're lucky here because this is a procedural model and we can change the level of detail adaptively. And we've added a bend modifier to it. Look at what we can do with that bend modifier. Along the way, we'll learn about the modifier stack itself. You might notice is that there's a little light bulb icon next to the modifier. For that icon, I can turn the modifier off or back on again. I delete modifiers. If I don't want it, I can select it and press the trash can, and that'll remove it. I'll add with the undo button. And obviously control different parameters such as the angle. What happened here with this arch is I want it to be straight and then bend at the top and straight back down again. And I can do that using a combination of the limits shown here, so the position of so-called modifier gizmo. At this gizmo, press the plus sign on the modifier. Click on that and you will see gizmo. Gizmo, it hides in bright yellow. An important indicator. We've now entered into a special mode called sub-object mode. Sub-object mode, you can't select any other objects. You're down inside the structure of this model and not select a different object. You can click on this other object all day long and nothing will happen as you're in sub-object mode. Gizmo sub-object mode lets me change the position of the bend effect. I'll go on the Z-axis of my move tool and drag that up. See the effect of moving the bend gizmo. Yellow outline here is the bend modifier itself. What I do is I want to have the bend effect start up here. This part to be straight. To accomplish that, I can limits on the modifier. When you turn on limit effect, it looks like there's no modifier at all. And that's because the limits are set to 0 and 0. But as these values by dragging, adjust the limits. I can pin a value as well. I set that upper limit to, let's say, 10 feet. That's that the modifier is affecting the box up to 10 feet away in linear units. There's a limit here as well. I'm just going to leave that at 0 for the moment. This to be symmetrical, I just need to do a little bit of simple math here. I'll set bend angle to exactly 180. That the upper limit is set to 10 feet. If I wanted, let's say, 10 feet of straight and then 10 feet of bent and then 10 feet down, I can do that. My box is exactly 30 feet tall. It's gizmo down. Get down to exactly 10 feet at a symmetrical structure here. As I move it up and down, numbers are changing at the bottom of my screen. So it's the Z position of the gizmo. And I want it to be exactly 10 feet. I'll just go down here to Z and type in 10. Let's enter. When I'm finished, I can exit out of gizmo subobject mode. The basics of working with the modifier stack, enabling and disabling modifiers, changing the gizmo position in subobject mode, and playing around with the limits. The 3ds Max allows you to, as the name implies, stack as many modifiers as you need to. However, understand that the order in which they are stacked is important. Structure flows from the bottom up. The chronological order that you add them is not important, but the final result of which is stacked on top of which is very important. I'm going to add a twist modifier. Click Fire List and scroll down looking for twist. Add that. And see, I've got a new orange box around when I have the twist modifier selected. At the twist angle. And this is not really what I was going for. It was the box to be twisted around and then bent. That means that the twist would need to be lower in the stack than end. Easy enough to do because in fact I can just select that and drag it. And you see that blue line when I release the mouse. Boom. Now I've changed the order of operations in the stack. This is referred to as a dependency. The dependent upon the twist because it's later in the stack. Notice that this twist modifier looks kind of funny. And the byproduct of the way that I did. There's a do this in fact, which would be clearer and less confusing. Delete that twist by just selecting it and then clicking the trash can. If I twist at the appropriate location in the stack of where I want it to be, then I will see that funny icon. If I select the box in the stack and then add the twist, it'll be added above the box but below the bend. This is going to be a lot easier for us to figure out and understand. As I adjust the twist angle now, you can see this orange box is showing us the effect of the twist. Also, enable and disable modifiers to check each one in turn. For example, I can turn the bend off and sort of isolate this and see what the twist is doing by itself. Or I could isolate only the bend by turning the twist off. So I can do it too, which is this very important button here, Show End Result. On, then you will see the end result of everything in the stack. All modifiers will be processed and displayed on the screen. If Show End Result is turned off, you'll only see the result at the currently selected modifier level. If I go down to box, I'll only see the effects of the box. Click twist, I'll see only that. Bend, and I will see everything below the bend. That's the end result, and it's usually on. Now, some adjustments here. Because I have all these modifiers and it started its life out as a procedural primitive, I go down and do things like select the box and reduce its thickness. Maybe I only want a length and a width of 1 foot. Press Tab key, type in a 1. Or I go to the twist modifier and adjust its angle. I could say I want an angle of exactly 720 degrees. I limit the effect just as I did with the bend. Perhaps at the bottom I want it to be not twisted. That means I could go into the twist sub-object mode and add up. At this for a second, maybe I'll want to have, let's say, 2 feet of non-twisted shape down here, and then twist it all the way through, and then the bottom 2 feet here also not twisted. Let's put the gizmo at a height of 2 feet. Type in a 2 here. Limits, and the upper limit to 30 feet minus 2 minus 2. And of course would be 26 feet. Upper of 26. Turn off gizmo sub-object mode. And I've got a fully procedural model. Adjust at will. For example, I can go back down to the box and number of segments. Maybe I want, let's say, 50 segments instead. That's a bit about working with dependencies in the modifier stack. Procedural model. that gives a lot of flexibility to change the model on a very large scale. In other words, change global parameters like the amount of bend very easily. And purely non-destructive workflow. Pretty cool because that means I can change any of these things and there are no negative consequences from that. Level of detail, I could change parameters like bend and twist and nothing's going to break because it's all purely procedural. And 3ds Max saves and loads a procedural model. It's actually following instructions. In other words, it's not recording the exact position of every point on this model. Rather, it's recording very simple instructions like make a box, give it this number of segments, twist it this amount, and bend it around this amount. That workflow is very useful in some cases, but eventually you'll find that it's limiting because you need to select individual parts of the model and move them around and manipulate them independently. To that in 3ds Max, you can collapse the modifier stack. An instructive act, when you collapse the modifier stack, you remove all modifiers. What you're left with is a raw shape. Items have similar processes. In Maya, for example, it's called deleting the construction history. It's an idea. Taking basic instructions and then converting it down to something a lot simpler. And that then gives you the ability in 3ds Max to emulate independent components. To collapse the modifier stack, the easiest way is to simply select the object and then right-click in the viewport and get the pop-up quad menu. This context-sensitive menu, what you see here will depend upon what you're currently doing. Down the lower right-hand corner is Convert to. And one that you'll usually choose here is Convert to Editable Poly. Editable Poly is an object type that gives you a lot of advanced tools for adjusting the shape of a polygon object. Release the mouse, and I do that. Now you'll see something very different has happened in the modifier stack. No longer do I have a box, no longer do I have a twist or a bend. That's all been erased, and what I'm left with is an editable poly object. It has tools, and we'll be covering some of these later in the course. We've converted it to an editable poly, and now we're ready to go in and select sub-objects and move them around in the next movie. Object to editable poly, I can go in and select individual parts and manipulate them and sculpt the object with a little bit more finesse. There's actually lots of different ways of doing that. In any event, I need to enter a sub-object mode. If I click on the plus sign over here, you will see the sub-object modes listed in text form. The important ones are vertex, edge, and polygon. Those correspond to a point, line, and plane in geometry. Just a fancy word for point. And go into vertex sub-object mode, you'll see all the points on the object are shown in blue. And if I drag a selection rectangle, they'll be highlighted. And then manipulate them. Control to undo that. Just that when I selected vertex up here, the icon lit up down here. I use a sub-object mode either from these text labels or from the icons. For example, I can click on polygon and make a selection, and now same as if I clicked up here to enter polygon sub-object mode. Sub-object modes can be entered from the graphite ribbon. I previously closed just to streamline the interface a bit. I'm going to open that back up again. Graphite modeling tools. Tools only work with editable poly. If any other type of object, when you click graphite up here, you won't see any of this stuff. See that we can enter various sub-object modes as well. Let's do here. Well, I just want to select a couple of these at the bottom, get in a little bit closer. And make a selection rectangle around all these near the bottom. I'm going to scale those up a little bit. Use the scale tool to do that. And just exactly in the center of that scale gizmo. And change the size of that. I mentioned earlier that scaling can be problematic. This from scaling is not problematic. And in fact, this is the way that we need to do a scale. We'll talk that more in the chapter on hierarchies. I'll Z to undo that. Close the graphite ribbon to give myself a little bit more space. Back out to the 4 viewport layout by hitting Alt-W on my keyboard. And what I want to show to you is that if I scale from the center of the scale manipulator here, you're scaling in all 3 axes. What I like to do here is to scale only in X and Y in the world coordinates. Control Z to undo that. I don't want to scale vertically. A bit closer here. You'll see that as I move my mouse over the gizmo, if I go to the edge of the gizmo, I can select just 2 axes and scale in only those 2 axes. Click on that with the mouse. Once I want to exit polygon subobject mode, I can go back out a little bit and admire my work. There's more to modeling, obviously, in 3ds Max. This chapter has been a basic introduction to setting up a scene, setting units, and basic operation of the modifier stack and sub-object editing. We'll be looking at constructing objects from shapes or from curves. Be working with these curves here, for example, these primitives and also freeform lines, and then we'll use those to construct something called a loft. And that's what you see here. This art glass piece has been created as a loft from these 3 shapes. I'm going to go ahead and reset 3ds Max and start from scratch. And more 3ds Max back to default settings, as if you had closed the program and reopened it. And not a blank scene. I'll add that view cube too while I'm at it. Again, I want to set up my units of measurement. Customize unit setup. Because the object is going to be pretty small to fit on a tabletop, I can go ahead and use inches as my default units. Okay. I set up the grid, run any one of the magnet icons on the main toolbar, and go grid. Have a minor grid line every 1 inch by setting the grid spacing to 1. Press Tab key. A major grid line every 12 inches or every 1 foot. I'll set your lines every nth grid line to 12. Perspective view, I'll set to 24 inches. Now I've got a stage in the perspective view that's 24 inches from center to edge. That's how I can set it up for imperial units in inches. Create some shapes. For the art glass vase, I need a circle, a star. The shapes are found in the Create panel in their own subpanel labeled Shapes. Considers a shape to be a spline or a curve. We've got shape primitives, such as a circle. I'll create this in the top view just because that's the most convenient. It doesn't matter where I create it. It's cleaner and neater in the scene if I create it in the top viewport. I'll click to exit creation and then immediately go to Modify panel. And look at this. I've got a radius of 1 foot 5 inches. And it's not even anywhere close to my perspective view grid. It's part of the byproduct of working in 3ds Max because the grid is adaptive. If you move forward or back with the wheel, you'll notice that the lines of the grid adapt to the distance that I'm at. So as I go further out, eventually those minor lines disappear. That's kind of difficult for you to figure out how large things are. Make sure you're checking the numeric values, and if you need to, you can make a reference box that's 1 foot on a side or something like that. I'm going to set this to 2 inches in radius. Spin a 2 and press Enter, and move it nearer to the center of the world just by grabbing the Move tool. Type some zeros down here in this transform type in area. X of 0, tab, and 5, 0. Now it's centered on the world. Move it a bit. Enough circle. Nothing like that. I'll go up to the Create panel and also make a star primitive. Star. That out in the and release the mouse. 3ds Max is also expecting me to set other parameters, not just 1 radius, but also a second radius. I'll click again to set that second radius. Now I did the star. If I'll right-click to exit star creation. You might need to right-click twice. Go to the Modify panel, the star parameters. For example, the number of points, maybe on 5 points. It'd all be nice if these weren't so hard-edged. I want a rounded corner on these. I'm adjusting these fillet radius values. Fillet radius 1 is the outer corners. Fillet radius 2 is the inner corners. That you don't push this too far because you'll get interesting results. In other words, the shape is now self-intersecting. That's not going to work in this case, so I want to have a very small fillet radius for both radius 1 and radius 2. Let's do it to create shapes in 3ds Max. We've created line primitives, also known as shapes, in 3ds Max. Also want to create a free-form line that I can edit and make any shape that I want. Before I do that, zoom all viewports to enclose all geometry. I'm not sure where I am in the front view or left view. I want to zoom all the viewports so that all of the objects are visible. I hold down Shift-Control and press the Z key. Shift-Z zooms all viewports to enclose all geometry. Now I know in the front view that I'm more or less in the right zone, even if I can't see the object selected. And I'm going to make my object about a foot tall. So I zoom back a little bit, and remember I set the grid earlier to show inches and feet. 1 foot in height here. And over to the Create panel, and Shapes, I'll click Line. At the bottom and click once to create a point. I'll just go up here about a foot up in the air and click again to create a second point. Making points, therefore I'll right click and that will edit that particular object. And click again, complete line creation. Mostly on this, it's not perfect. I try level best to click on the center here, but I didn't quite make it. This will be an opportunity to show you how to use snaps. I'll try again by deleting that. Press the delete key on the keyboard to delete that object. And on snaps, click on the 3D magnet icon. That'll allow me to snap to grid intersections. However, I want to right-click on that just to make sure that grid points is the only item chosen in the snaps. Now click Line. And as I move my mouse around, you'll see that I get a nice big yellow snap icon. Click Create the first point, click it to create the second point, and right-click to finish the line. I click again to exit the line tool. You may notice that you see some funny business here with the line, and it may not display well because the selection bracket is kind of hiding it. Don't be alarmed by that. And you also might notice that the grid and the snaps sometimes don't play well together. But if I turn the snaps off, everything should be fine. I'll dolly back in my perspective view. And I've got a line. Perfect. Because I clicked and did not drag the mouse when I created the line. Just great. If I click on line and hold down the mouse as I create, you'll see I'm getting curved lines. This time, we just want a straight line. So I'll delete that. That there is to creating a line in 3ds Max. Next, we'll work with it and change its shape. We've seen 3 of those are still primitives. For example, the star. I'll reduce the radius a little bit. I'll convert it to editable spline. We'll elapse its modifier stack, delete all parameters, and allow me to select individual points. As the view with Alt-W, and press the Z key to zoom in on that star. I can right-click anywhere in the viewport and choose Convert to View Editable Spline. Release the mouse, you'll see that it's no longer a star primitive. It's now a type of object, editable spline. Very similar to what we saw in the last chapter with converting a 3D primitive into editable poly. It's the same idea here. And actually go in and select individual points. Click Vertex Sub-Object mode, either in the selection rollout here or in the sub-object modes in the stack. and then select individual points and move them around using the Move tool. I do this in the top viewport, and that's because if I move these points in the front or left viewports, it wouldn't be flat anymore. I mean flat. An asymmetrical shape. I'll out of subobject mode. And I'd like to show to you the fact that the line that we created previously is the same object type as converted editable spline. W to go back to my 4 viewport layout. And click on the line and you'll notice that the modify panel here looks the same. Make this a little bit bigger by pulling this out. And you'll see these two have all of the same tools. This started its life out as a free-form line. This started out as a shape that was converted, but ended up being the same thing, which is an editable spline. Don't be thrown off by the fact that this one says line up here, and then says editable spline, because in fact, they're just 2 different names for the same thing. And then we'll look in a little bit more detail at controlling the shape of an editable spline. To get for the shape of an editable spline, you'll also need to work with vertex types. There are different types of vertices on an editable spline. The vertex subobject mode for my star, and some of these, you'll see that they're all Bezier points. Grab the Move tool and move little green handles around. That indicates that it's a Bezier curve or Bezier vertex. You're familiar with that from a program like Illustrator or Photoshop. All computer graphic programs have some implementation of the classic Bezier spline, which has incoming and outgoing handles to adjust the shape of the curve on either side of the vertex. Next, we have other types of vertices as well. To convert between vertex types, select one or more vertices, and right-click in the viewport. You'll get the quad menu. In the left quadrant, you can choose a different vertex type. For example, corner. If I corner point, the sharp corner. 1, 2, right corner. Segment between 2 points will be a straight line if both of those points are corner points. So if there are straight lines, you can just select all the points and convert them to corner. A really useful vertex type is smooth. I'll click and choose smooth. And smooth point implies is smooth. It's a nice soft curve, and it doesn't have any tangent handles for you to worry about. So in some regards, it's simpler. However, notice with a smooth point that it does affect other segments. In other words, I'm moving that point, and it's not just affecting this segment and this one, but it's also affecting segments farther away than you might expect. The vertex is a Bezier corner. Special case of a Bezier in which the incoming and outgoing tangents are not locked, and I can move them independently. With a spline, the transform gizmo does not appear at the location of the tangent handle. Now, as I move this, you'll notice that it's only moving in X. If I needed to move in X and Y, I'll just click in the center of the Move gizmo. I'm back to moving in X and Y. I'll come back to Bezier. Notice that sometimes the curves become asymmetrical. The handles are different lengths on either side. If you restore the handles to be the same length, then you can right-click and convert to smooth, and then click and convert back to Bezier, and now the 2 handles are equally the same length. Click on that. What I need to mention to you is it may be necessary for you to get rid of the transform gizmo in order to work. Here's an example. I want to get at this green tangent handle here, and I want to move it left and right. Because it's underneath the transform gizmo, I actually cannot move it in X, because as soon as I click there with my mouse, I'm telling 3ds Max that I want to constrain the movement to Y. So I cannot move it in X. A transform gizmo is directly positioned over the top of it. And then I need to hide the transform gizmo and use the axis constraints toolbar. To hide the gizmo, I'll press the X key on the keyboard. The axis constraints toolbar, click on the main toolbar, and choose Axis Constraints. Axis Constraints toolbar, I can choose X and Y as my constraints. Now I can edit this as I did before. One point about hiding the transform gizmo, the separate command in the Views menu that says Show Transform Gizmo, and turn that off, then the transform gizmo and the little axis tripod will also disappear and you'll be left with nothing. I don't recommend that. Turn that on again. Just use the X key, which will hide the gizmo but still show you this red axis tripod so you'll know what constraints you're currently in. Of subobject mode, a little introduction to using different vertex types in an editable spline. In this art glass vase, using the loft compound object. In 3ds Max, a loft is slightly different than it is in some other programs. If you're used to Maya or more traditional NURBS modeling, a loft is usually just a surface that's drawn between two curves. With 3ds Max, a loft has one additional requirement, which is that it must have a path. This line here is the path of the 3ds Max loft. The loft must have exactly one path. It must have one or more shapes, which are the profile curves. I'll open up the scene that just has only the splines in it. Here's a scene that just has only the shapes in it, and I'm ready to create a loft. To do this, I'll select the path. I'll make this bigger by hitting Alt-W so we can see a little bit better. So that path selected, and now I want to go to the Create panel, go to a new category that you haven't seen before. On Geometry, pull-down list, go to Compound Objects. The name indicates a compound object is made out of two or more other objects. Activated that panel, now you'll see these are lighting up and some of them are grayed out. I have the path selected at this point, or I will not be able to create the loft. Then if I click off of that path, now loft is grayed out. I have it selected first. Click the loft button. At this point now, you have to select the profile curves or the shapes. You'll see down here in the Create panel, Shape. Click the Get Shape button, and then click on one of the profile curves, like the circle. And as I've done that now, you'll see I've got a circle. Now, my object color is currently black. I'll just change that. We can see better now. Very simple. I've got a loft now. It's a compound object made out of a line and a circle. Let's get more interesting by adding another profile curve. To do this, I'm going to get in a little bit closer. I'm going to go into wireframe mode so we can see this a little bit more clearly. So I'll press F3 on my keyboard. Notice that there's a very small yellow X down here. Our current position along the path. I can do that position by adjusting this value here. This is a percentage of distance along the path. If I set that value to 50 and press Enter, it's moved up to halfway along the path. I've set it up so that if I choose another shape, it'll be positioned at that location. I'll click Get Shape, click on my bar, and now I've got two shapes along the path. I'll F3 again so we can see that better. I got two shapes on one path. Right-click to exit that creation, and go into the Modify panel, and I can, in fact, do those same things. Again, I can choose a location along the path. I'll need in wireframe mode to see it, and I'll probably have to get in very close. But I can do all those same things from within the Modify panel. I can choose a position along the path and get a new shape. But I've got the shapes that I need now. Free to go back to shaded mode. In the movie, we'll work on the aesthetics of this and moving the shapes around along the path and changing their parameters. I've got a loft. Let's play around with some of the parameters of that loft and make it more beautiful and aesthetic. I'll select it And before I even change its level of detail or any of its loft parameters over here, I want to show you that there's still a live dependency back to the original shapes. The original profile curves are still connected to this loft. For example, if I select the circle and adjust its radius, you can see immediately it's connected to the loft. Very cool. Note that if I move the circle, that doesn't affect the loft, and that's different than a traditional loft in other programs. 3ds Max, the object transforms, the shapes and the path do not affect the shape of the loft. The sub-object transforms do affect the shape of the loft. In other words, if I were to move points around on my star, that would change the shape of the lofted vase. To the top view to do that, select my star and go into vertex mode, select some points on that and move them. You can see that there is a live connection back to the loft object. As long as I haven't deleted the shapes in the path, the dependency will still be in effect. Get out of sub-object mode, to the loft, match that view with W, and play around with some of the loft parameters. This basic one is capping. I get a cap at the start and the end of the loft. Because this is supposed to be a vase, I don't want to have a cap at the top here. That, in fact, is the end of the loft. The point that I created was at the bottom, so that's the start. The second point on the path is the top, which is the end. I'll cap end off, and now I've got a hollow shape. Cap at the bottom, but not the top. I want to work with level of detail. Just better, I want to be in a wireframe mode, or at the very least have edged faces visible. Press F4 so I can see the wires. A little bit closer on that. The detail for a loft is controlled through these shape steps and path steps in the options. Steps is how many divisions between 2 points on the original shape. If I reduce that down, we'll get a much lower level of detail. Path steps is the level of detail running along the path. Adaptive is turned on by default. What that's going to do is try to fill in a certain number of polygons to make it look good. Doesn't work out that way. If I increase the path steps quite a lot, something like 50, you'll notice that the density of edges is much greater here at the bottom than it is up here. If I wanted a consistent sizing to these polygons or a consistent length to those edges, I can adaptive path steps off. A little bit more predictable result. Basic introduction to editing loft parameters, the level of detail, and also adjusting dependent splines. Parameters for the loft. Let's dive into making it more beautiful. The thing I want to do here is to change the shape of the path so that I have a curved path rather than this straight line. It's difficult to select things in the viewport, especially if things are hiding behind other things. There's an alternate method of selection called the Scene Explorer. Let's look at that. It's a Tools, New Scene Explorer. An outline of all of the objects in the scene. And if I click on something in the Scene Explorer, it will be selected in the viewports. Now I've got line selected. And I grab the Move tool, move that line out of the way. The loft where it was at the origin, which is the center of the world. And by convention, that's where we want the model to end up. Was the Scene Explorer. I'm ready to edit that line. What I want is a curve. To the front viewport, Alt W. And that line selected, I'll choose Vertex Sub-Object Mode. These are both corner points. If I select it and move it, you will see a straight line between those 2 points. Control-Z to undo that. I recommend that you have corner points at either end of a loft path. If those points are anything other than a corner, you get unpleasant results with your loft crumpling in on itself or twisting around and doing weird things. Keys as corner points. To curvature, I'll need to add more points along the path. I'm done with the Refine tool. With the line selected, in object mode, I'll do the geometry rollout and refine. Just click anywhere to create a point. Make 2 points. When finished refining, I'll right-click to exit that tool. You create it as corner points as well, so if I move that around, you'll see I'm getting an angular result. I'll convert those two to bezier, a more softer, rounder shape. So those 2 points. Click in the viewport to get the quad menu. Convert those points to Bezier. Add a much softer, rounded shape. F4 key to turn off those edge faces for a moment so we can see that a little bit better. These points around, you'll see it's changing the shape of the loft. Be careful with this because if the path is too curved, then the loft will actually self-intersect or crash through itself. Also notice that the bottom of the vase is not flat with the world. Over here as well. To make that it is flat, we just want to make sure that we have 2 points in a row here and basically a straight line segment. Down a little bit. Very good. We've edited the shape of the path, and I'll exit out of sub-object mode now. Next, we will control the positions of along the path. Positions of shapes along a loft path. In this case is I have a circle at 0% along the path. I've got a star up here at 50% along the path. Position these at different locations along the path very easily. Maximize that with Alt-W. I'll go to the Modify panel and open up the Loft sub-objects, and you will see Shape and Path. The only really care about now is Shape. And click on Shape, then select a shape path. And this is easiest to see if you don't have wireframes turned on. If I had frames on, it'd be kind of hard to see. Before you do this, I want to warn you that this is one of the very few things in 3ds Max that is not undoable. Once you select that shape and move it, you cannot undo the operation. The critical operation, I recommend that you save before you do this. So I'll just move that. Boom. What I've done now is I've positioned that star at 100% along the path, as shown here. And in fact, I could also adjust this directly. That were my... I can select the circle too. Pull that up, giving me more of the result I was trying to get, which is this floral design. Cool. What I want to mention here is that sometimes you may get twisted lofts, and you'll need to adjust the rotation of shape. If I select that star, go to the Rotate tool, I can rotate it. And sometimes this will happen whether you want it or not, and it'll kind of turn around inside out. This is to correct that problem. Also, just to fine-tune the structure, if I go to Wireframe or Edge Faces by pressing F4, I rotate that shape, you can see how it's affecting the polygon structure. Good, that's a very simple introduction to manipulating loft shapes along a path. I want to remind you once again with a big warning that that is a non-undoable operation. And then we'll add a scale deformation, which will allow us to change the size of a shape as it travels down the path. We've got, but it doesn't have very much finesse to it. It's not very aesthetic. What I really want to have is a really elegant taper to the thickness here, and I want it to be larger at the bottom so that it won't be top-heavy. You might think that a good way to do that would be to add more circles as shapes along the path. However, that would not be an efficient way. Instead, I'm going to use something called a scale deformation, which is built right into the loft. I'll select that loft and go over to the Modify panel very bottom, you'll see deformations. What we care about right now is the scale deformation, and it's far the most intuitive of all of them. To add deformation, I'll click the scale button. And got a window opening up. Let me size that window. What we're at here is a graph. On the left is the beginning of the path, and on the right is the end of the path. The vertical dimension up and down is the scale of shapes as they travel down the path. I'll use the zoom region tool here just to zoom in on this area from 0 to 100%. Grab this move control point tool up here. Grab one of these points and move it down. And you see very clearly what it's doing. The very beginning of the path, we have a very small scale. A scale of, in this case, only about 6 or 7%, as shown by this numeric readout here. If I restore it back to 100%, I could just type in 100. Dashed lines here that you see indicate the positions of shapes along the path, and also of vertices along the path. What we need to do is add more control points to this red curve. To that, I can go up here to Insert Points. Default, I'll get a corner point, but what I really want are Bezier points. If there's a little triangle down here at the bottom of that icon, that means it's a flyout. If I put that down, I can choose a different option. Here we go. Insert Bezier point. That's what I really want. And when I click anywhere here, I'm creating a new Bezier point. A couple of those. Go back to the Move Control Point tool and move these around to start shaping my model. Very cool. Let's say I want it to sort of bubble out at the bottom here. This is a corner point here, but what I really need then is a Bezier corner because I'm going to have a handle that I can adjust. And right-click on one of these control points and convert it. Corner. Move that up. There we go. That's what I was trying to go for. I was trying to get this sort of larger base at the bottom. Easy, pretty straightforward stuff. You'll notice, by the way, that the handles are not of equal length. If that's a problem, then you can convert it to corner and then convert it back to Bezier. That'll equalize the lengths of the handles. At the end, I don't want it to be 100% in size, and maybe I'll bring this down. And this is all non-destructive, and I can go back and change this at any time. That from different points of view. Okay, good. There's to that. I can zoom here so I can see the entire curve, and I can use this hand to move around. But that's all there is to it, to creating a scale deformation to modulate the size of a shape as it travels down a loft path. I have more to give it a slightly better shape. Last thing I really need to do in terms of the structure of this loft is to give it some thickness. I'm closer here so you can see what I'm talking about. Close enough, you will see that this is an infinitely thin surface. It has no thickness at all. It's just a shell of polygons. It needs to have an interior and an exterior surface. 3ds Max makes it very easy for you to do that. There's a modifier designed just for that purpose called shell. Go to Fire List. So I'm looking for shell. Boom. All right, got the shell, but you can see that it's looking pretty thick. All I do is adjust these inner and outer amounts to get the result that I want. Maybe I want it to be an outer amount of 0 and an inner amount of maybe 1/4 of an inch or something like that. As long as the surface is not self-intersecting or passing through itself, then everything's fine. Wow, it was easy. And you do this for any object in 3ds Max. You can turn a plane into a box by just adding a shell modifier, or any complex shape. If you need to, you can even go in and play around with some of the fancy stuff in here, like the number of segments and so on. But in fact, this is fine just as it is. That shell modifier is a very easy way for us to add realism, because if this were, for example, a real piece of glass, it would need to refract light, and that means it would need to have some thickness. It makes it very easy for you to do that. Our art glass vase, just a couple of finishing touches to put on this. If you look really closely, you might see some kind of interesting modeling effects. That's the desirable outcome. All I need to do is adjust the level of detail on the model to clean that up. Go back to the Modify panel, back to the loft. Even with the shell on there, I can still see the end result because I've got Show End Result turned on. I can turn on and off as needed. What I need to do is increase the number of shape steps here to get a softer, more pleasing result here. And it's going to vary. It's going to be different for every model. Just find the sweet spot here. If I'm too high, then it's too heavy. If I go down too low, then I start to see these weird artifacts. Can't really tell where the edges are in a shaded view, so you may need to have more than one view open at a time. I'll hit Alt-W, go a little bit closer in on the front viewport in a wireframe view so I can get a sense of the density or level of detail of that model. And I'll increase those shape steps up until the model looks clean and no further. I want to increase it beyond where it looks good, because then I'm just unnecessarily burdening my computer with too much data. Like a shape steps of about 7 work for me. Make any final adjustments to the model and then save it in state. As call this one for loft. Putting the word loft in there for a reason, because I'm going to convert this to an editable mesh as my final output. And once I've done that, that'll delete the loft and the shell and all of that stuff. Won't be able to make changes very easily. Or I'm going to version my work. I'll make a version that's a loft. I'll convert it to a raw mesh object, either editable poly or editable mesh. If to editable poly, then I'll have a lot of advanced tools available to me. If I get to editable mesh, it'll be a very simplified structure. In other words, it's an older and dumber object format that's very universal. For output, it doesn't really matter which I do. Editable mesh is a little bit better performance, so I'll choose that. Now I've erased the loft and erased the shell, and all I'm left with is raw mesh. I don't need any of these editable splines any longer. They're not connected to the mesh anymore. So go ahead and delete those with the delete key and save out as a new version. I'll call this one Vase Mesh. That's what I would use in my master scene if I were to bring this into an architectural rendering or something like that. I want to use the mesh object rather than the loft because it's more efficient. There's nothing to calculate, just a raw shape. In this, we'll learn about building objects using simple primitives. Bookshelf is a good example because it has a modular structure. We just use these parts and repeat them to build the whole piece. And then at the end, we'll group it together so that it's a single unit. To begin, I'll go ahead and reset 3ds Max. And always I'll start by setting my units and grid. Customize unit setup. I'll use feet and decimal inches with inches as the default units. Right-click on any one of the magnets up here to get the Grid and Snaps dialog. Go to the Home Grid. I'll set this up for imperial units. A grid line every 1 inch. Hit the Tab key. Major grid line every 12 inches. Hit the key again. And for the perspective view, let's give it 24 inches from center to edge. Very good. Now I've got that set up. We'll be basing our 3D model on a bookshelf from the real world. And in fact, I already got the dimensions for that. That'll be helpful when we're building this piece. Here are the dimensions of the bookshelf. The information is included with the exercise files as a text file in the Chapter 6 folder. Now that we've got our scene set up, we're ready to start constructing the model in 3ds Max. We're constructing our bookshelf. I could use standard box to do this, but we'll see if you get in really close on a box, edges are razor sharp. This corner is an exact 90-degree angle, and objects in the real world really have a slight rounded corner, also known as a fillet or a chamfer. I could add that to my primitive box using a modifier. However, there's an easier way because 3ds Max provides an extended primitive called a chamfer box. That standard box, with the Create panel, the Geometry section, and I'll click here on this arrow to get the pull-down list and choose Extended Primitives. And here we'll see Chamfer Box. Click on it. And in perspective view, I'll click and hold the mouse to set a footprint for the chamfer box. Release the mouse and drag upward to set its height. Click and then drag left to right to set the fillet amount. No matter what that fillet value is right now, it just has to have some non-zero value. I'll click to create the chamfer box that finishes the box, and then right-click to exit the tool. Since I know the dimensions of this piece already, I'm going to go directly to the Modify panel and plug the values in. For the we'll have a value of 1 foot and 2 inches, and I'll just type in a 1, a single quote, and then 2, press Enter. Press Tab key. For the width, it's going to be 3 inches. I'll just enter a value of 3. And the default units are inches. Just press Enter, and that's interpreted as 3 inches. Hit the Tab key for the height, and that's going to be only 1 inch, because it's just the very base of the bookshelf. Okay, let's get in really close on this and to adjust this fillet value. I'll maximize the view with Alt-W so we can see that better. F4 so we can see edged faces. Additionally, brackets here can be a little bit distracting, so I can turn those off using the J key, and that toggles selection brackets on and off. Oh, so now if I adjust this fillet value, we can see what we're doing. We want a very small value here. Let it about 1/8 of an inch. So I'll give that a value of 0.125 inches. So that's my first piece. Back out to the 4 viewport layout with Alt-W. Get a bit closer in the top view, and I'll position this where it is going to eventually end up. I know what that value is already, too. As well, just type it directly into the transform type in values down here. The Move tool active, I'll set the X value to -2 feet and 2 inches, and press Tab key. And then the Y and Z values will just be zeros. And got a single piece that's positioned in the correct location. Getting a little bit closer in here once again. See that the edges are kind of rounded and smoothed. And in fact, I just want to turn that off, smoothing off, because in fact I want to have sharp angled edges in my final rendering. Oh, so there we go. We've got one little piece there, a single chamfer box. And then we'll make some copies of it and build the rest of the pieces of our bookshelf. Box, the bottom of our bookshelf. Let's make some copies of this. I'll select it, and I can make a clone. 3ds Max makes it very easy for you to do this. All you do is hold down Shift as you move or rotate an object, and you'll be making a copy. Hold down Shift and the object. Here I've got a copy. When I release the mouse, I get a dialog box asking me what type of copy do I want. Standard copy is, as the name implies, it's a copy and there's no relationship between the two objects. What I want here actually is an instance, which is very useful because if I change one of the instances, all of the instances will change. It's almost like having an object in 2 places at once. Okay, to create that. Illustrate, I'll show you that if I change the value of the length of one of these, they both change. Very cool. All right, Control-C to undo that. I just want to position this symmetrically at 2 feet and 2 inches in the X axis. Let's rename these as well. And I'll call this one Shelf Base 01. And all this Book Base 002. It's a really good idea to name everything as you go along, because if you don't, then you'll end up with lots of objects that are all called Chamfer Box 01 to Chamfer Box 200. It makes it very hard for you to navigate your scene and figure out what you're doing. Okay, so that's a standard instance. Now I make the next piece. I can make more than one copy at a time. To do this, let's get in closer in the front view and maximize that front view with Alt-W. And I'll make another clone. Hold down Shift with both of them selected. This time I don't want an instance because this part will be taller. I'll need to choose Copy instead. And I'll just adjust them independently. Know that the height of this is going to be 9 inches. Just type 9. And since I had them both selected, they both changed. Very good. Hit Alt-W to go back out to the 4 viewport layout. That's the essentials of creating clones in 3ds Max. Copies are not connected, and instances are always identical to other instances. To construct parts of the bookshelf, let's go ahead and make the shelf proper. Go to the Create panel, Chamfer Box, drag it out in the top viewport, and drag upward to set the height. Drag left to right to set a fillet amount. Click again to complete the box, and then right-click to exit the tool. Move up in the front viewport, and go into the Modify panel, and set the dimensions. Width to be 1 foot and 2 inches. Tab key. The width is going to be 4 feet 7 inches. Hit the Tab key. The height is going to be only 0.5 inches. Fillet amount, once again, will be 1/8 of an inch or 0.125 inches. All right, let's get in closer on that. Alt-W. Just center it. I'll give it an X value of 0, a Y value of 0. The height will just eyeball the position. And now sides here, I'm going to clone these guys again. Select those. I can use the Control key to select them both. And then down Shift and drag. And they're going to be copies once again. We name them here too. I'll call that shelf side 01. And the height of these is going to be 1 foot and 3.5 inches. Then a quote and 3.5. Okay, I'll get in a little bit closer here to make sure that things lined up. Have any overlap if I can avoid it. I have to turn off smoothing on this bookshelf piece, so I'll do that now. All right, and then I can take these 3 and, in fact, clone them. And this too, we'll call that shelf 001. Just select these 3 with the Control key and clone them in a clever way using the Array tool. Your tools, Array. And what this allows me to do is to make multiple copies of selected objects and create 1-dimensional, 2-dimensional, or 3-dimensional arrays. I've got a number of copies that I want to make here. I'm really only going to need 4. And I'll also want to position them. I want to move them up in Z. Now, it's very useful to see a preview of what I'm doing. I'll click the Preview button over here, and then adjust the Z value. See, I'm getting 4 copies. Pretty cool. And in fact, it looks like a value of 1 foot and 4 inches was right. Get in really close on this to make sure it's clean. Good to me. And by the way, the Array tool is now non-modal, which means that I can make adjustments in the main window while I'm previewing the array. Excellent. And the instances by default. Click OK. So I just need 1 more of these. I'll hold down Shift and drag that up. I can make that an instance too. And I'm almost finished with the structure of this. I just need a little bit more up at the top here. All these guys, Control select those, hold down Shift and drag it up. And it'll be copies. I'll need a different height to those. And I'll call this one bookshelf side. And right here is just going to be 3.5 inches. 3.5. And finally, I've got these two little bits down here. Control select those. If you only select the wrong thing like I just did, you can use Alt to unselect. Go, hold down Shift, bring that up, and I'll call those bookshelf top. All right, so I've constructed my bookshelf out of chamfer boxes. 3D tool that lets you measure your scene. It's called the tape helper. I'll hit W, go out to my front view because I want to measure the height of the shelf. To make it a little bit easier to make sure that my tape helper is only measuring vertically, I'll use the snaps on 3D snaps up here. I get to right-click on the 3D snap button too and make sure that grid points is the only thing active. And on my tape helper, go to Create Panel, and there's a new category of objects you haven't seen before, and that's over here. Here it is, Helpers. Looks like a tape measurer. And click on Tape. Click and drag to set the position of the tape head and the end of the tape helper. And then release the mouse. I'll right-click to complete that creation, and I'll also turn off snaps now that I've got it lined up. Okay, so how does the tape helper work? Let's look at this. Alt-W to get in closer on that. Modify panel. And what this is showing me is the current length. And if I select the end of the tape, or its target, I can change the length. But that, I get to see the value as I do that. Or select the head, and I can see the value. Control to undo that. Well, there's a handy way that I can pin the stack. In other words, click this little button here, and now whatever I currently have in the Modify panel will be sticky. Will stay displayed if I select a different object. That means I can select this target and move it around. A much better way of measuring. So you can see here that it's 6 feet 7 inches tall. And I'll specify the length, which is pretty helpful. I can click here and type in a value, 6 feet 7. And now the line here of the tape helper is exactly 6 feet and 7 inches. Excellent. So that's how you use the tape helper to measure your scene. And also how to use the pin stack command to display a specific Modify panel as you work on other objects. Chapter is simply placing objects into a group. That's a handy way of collecting all these pieces into a single unit, and that I can easily move that around or easily import it into another scene. Simply select all the objects, up to the Group menu, choose Group. I recommend that you use the word group in the name of the group. Call this bookshelf group. And now when I select any member of the group is selected. You'll notice in the Modify panel that the name is listed in bold. It's an indicator that I've selected the group and not any individual object. I can move that around or place it wherever I need. It's also quite easy for me to select individual group members. Simply go to the Group menu and choose Open. Now if you select an individual object, you can work with that object independently. Notice that there are pink selection brackets around the group. If you click on that bracket, then you can transform the entire group. Very good. When you're finished, you can close it back up again. Group Close. Only if you need to get rid of the group, you can just choose Group Ungroup, and then you back to where you originally. I'll do that. Keep that group. Just Control Z a few times until I see Bookshelf Group again. Close it. Work with groups in 3ds Max. We'll be modeling this fancy sofa using two techniques. First, for the base, we will use a rectangle shape primitive and a sweep modifier to create the frame. And for the cushions, we'll start with chamfer boxes that have been rounded, but we'll add a bunch of bells and whistles to them to shape them up and give them a little bit of a lived-in feeling. And also, we'll optimize it by deleting some of the unnecessary stuff. As you see in this cushion, it has no bottom. We'll be doing this using stuff in the Modify panel, specifically selecting based upon volume. Okay, that's what we'll be learning. Let's go ahead and reset the scene. And I want to set this up with my grid and snaps. This is European design, so it's in metric units. I'll go to Customize Unit Setup. Use metric. And I'll also choose centimeters as the units so that if I type in a value of 100, that'll be interpreted as 100 centimeters. Whenever you change the unit setup, you also need to check in on your grid settings. I'll right-click on any one of these magnets up here and go to the home grid. I would grid line every 10 centimeters in this case, and a major grid line every 10 times 10, or 100 centimeters. And for the perspective view, I want to have a stage that's 2 meters from center to edge. At that, I would take the grid spacing value and then multiply that. I want 200 centimeters. It's 10 times 20. The perspective view grid extent would be 20. All right, so there I've got my stage set up, and next I'll make some rectangle primitives for the frame. To my fancy European sofa, I'll use rectangle primitives. Just a sanity check, I'll make a reference box so I'll know ultimately how large things are in my scene. And I'll that box to be 1 cubic meter, 100 centimeters on the side. Pressing the tab key and adding a value of 100 for each of those. Right-click to complete the box. Move over to the side. That's a sanity check to make sure that when I build things that they're approximately the right size. To make a rectangle, I'll go to panel and choose rectangle. Draw on the top viewport. Click to complete the rectangle. I'll center it. I've got Move Tool active already. Type in zeros. The position, I actually want it to be slightly above the ground. I'll give that a height of 2 centimeters. Okay, I'll go into the Modify panel and set the dimensions of the rectangle. Length, which is the depth in this case, set to 100 centimeters. And width, I'll set to 235 centimeters. You'll also see that there's a corner radius parameter here. Let me get in closer on the corner so you can see it. We have rounded corners if we wanted. But in this case, I want to have sharp corners, so I'll set that corner radius back down to 0. As my rectangle primitive, I'll need a second one for the frame. Get closer in the front viewport. Make a clone by holding down the Shift key. And drag that up. You can see at the bottom of the screen, got the Y offset value. That's how far away it is in screen space. I'll set that up to a value of 8. In this, it doesn't really matter whether I make it a copy or an instance because I won't be making any changes. So I've got 2 rectangle primitives now. Just them a little bit easier to see in the view. I'm going to select them both. Set their object color to black because wireframes. And I'll join them up using editable spline. Rectangle primitives for the frame of the sofa. I want to use a sweep modifier later so I can give them some thickness. To do that most effectively, I want to make them editable splines, attach them together, and join them up with a couple other pieces of lines. First thing I'll do is select either one of them and convert it to editable spline. Simply select it, right-click anywhere in the viewport, and choose Convert to Editable Spline. Once done that, of course, I get lots of cool tools in the Modify panel. Most importantly is the attach tool. I want these two objects to be one object. I'll use attach. Click that. Click on the other object, and it'll be converted to editable spline and attached to the current editable spline. I can right-click to exit that. I'll run this now, and I'll call it. I'm going to have a few pieces of metal that join at the corners and also at the center here. I can use snapping to build a new line exactly where I need it. Do the snaps tools. Back to 3D snap. So right-click. I don't want to snap to grid points. I want to turn that off. I want to snap to vertex or snap to points. Click that. And create new parts of this line directly in place here. As you see, as I move my cursor around, I get a snap icon that appears at those vertices. Distracted by the selection rectangle, you can turn that off if you want. It's the J key. I'm going to create a new line here at this corner. Where inside the editable spline object, I'll click Create Line. Click that corner, and in here, and then click to complete it. Do that on all four corners. Getting so here. Once, twice, and right-click. Middle mouse to navigate, and the wheel to get in closer. Be careful that when you do this, you're not holding the mouse button as you create the line. You just want to click. If you hold the mouse down, you'll get a curved line. You want straight lines here. All right, I've got those lines made. Like a box, but it's actually not. We go out here, you can see I've got an actual box here. It's in a shaded mode. This frame made out of lines. Click to stop making lines. Snaps back off again. A couple of pieces of metal bar here and back. These lines that already exist here and clone them. In fact, I can clone sub-objects in the exact same way that I clone objects. I'll go into that editable spline sub-object mode segment. Segment is a piece of a line between two points. I choose it also from the text here, tab button, or from the icon. I'll control-click to select these pieces of line that I just made. I'm getting closer to do that. And I can make duplicates of all four of these. In a clever way, use Scale tool. Scale tool. And hold down Shift key. Click on the X-axis of the Scale tool. Now you can duplicates. See? And sometimes you won't be able to drag all the way to where you want to go. You use the Shift key, and you just scale it. And finished. You just exit out of sub-object mode. And that's the structure of our frame. And now to give it some thickness, in the next movie, we'll add a sweep modifier. To finish, we can sweep modifier to this editable spline. This is kind of like a loft, except it's much simpler. I'll select that. The modify panel. Modifier list, I'll just simply choose sweep. Black object now. Let me use the color so we can see that better. I'll change my display mode to shaded. Now look like what we wanted. We want just a standard instead of this interesting angle. You can change the behavior of the sweep modifier very easily. Going into this section type here. Instead of an angled sweep, I'll just bar. And to change the dimensions of the bar. Length and width are up here. I get that to 1 centimeter, 1 centimeter. Well, it was easy. What we had with the editable spline was an infinitely thin line that won't render. By adding the sweep modifier, now I've got a 3D mesh. Other built-in sections, by the way, cylinders and so on. Get the radius of that cylinder. That's useful for things like chrome tubing. Even put your own section in there too. You can make an editable spline and select it using these tools here. If you needed to do crown molding. I'll back to bar. Frame with a sweep. In this, select part of an object based upon a volume gizmo. That's the ability to apply effects selectively and non-destructively. Very useful technique. I've constructed half of the sofa here out of chamfer boxes. Get a little bit closer there, and I've pressed the F4 key. You can see the edged faces. See, I've got a fair number of segments here because I'm going to want this to be soft and rounded. Also got fillet segments here on the chamfer box so that the sides are round well. Focus just on the one object at a time. And to do that, all I have to do is select the object and go down to the bottom of the screen and click this red light bulb, and we'll isolate the object, essentially hiding everything else. What to do here is add volume select modifiers, then push modifiers that will cause the cushion to bubble outward. I'll go to the Modify panel, the list, and you'll see selection modifiers here up at the top. The one I want here is volume select because that gives me a convenient way of selecting a region or an area on the model. And that's an absolute selection. In other words, I can change parameters like the level of detail, and that won't affect the volume selection. Select by vertex. I'll go here and click in stack selection level vertex. To do that now, all the vertices highlight in red. That indicates that they are actually selected. If I move the gizmo around, I can select different areas on the model. I'll go to the volume select modifier and open up its sub-object modes and choose gizmo. Move that gizmo around, and anywhere that the gizmo intersects with the model, I'll select those points. I can scale the gizmo in various axes to control the selection. That's hard selection. Those vertices are actually selected. What we want here is a soft selection. The influence of this selection to diminish over distance. To do then is turn on soft selection. Just such as the fall off. And to do that, you can see color coding. Red means the vertex is selected. And as these colors fade into cooler colors, we're getting less and less selection. So here on the edges here, very little selection. And out here beyond that dark blue, these light blue vertices are not selected at all. But I've got my volume select. I go ahead and add a push modifier to bubble the cushion outward. List. And the push value. Push is only being applied within the volume selection. Additionally, that selection is a soft selection, so it's sort of fading out. I can go back down to the volume select modifier, gizmo, and change the shape of the gizmo, add different effects to the push. Back up to the push, change its value. This is completely non-destructive. In fact, go back down to the chamfer box if I wanted to, change the number of segments, for example, greater or less level of detail. That's the real advantage of using volume select. This model by deleting any parts that the audience is not going to see. For example, the bottom of the cushion. Open that scene file up to say to you that when you open it, you will get this dialog that pops up and says one or more objects are currently isolated. That means that the file was saved with an object isolated. Click OK. All right, so I want to delete the bottom of the cushion. All I do is add another volume select modifier. Go to the My panel, add another volume select. this to vertex mode, and I need soft selection this time. I'll leave that off because we're just deleting parts of the model. Open up this top volume select, enter gizmo subobject mode, and move the gizmo around. Move it down in Z, and I go scale it because I want to select the very bottom of the section. And I'll leave it in that state, object mode, and then add a modifier called delete mesh. Very simple, very straightforward. And this is non-destructive. You can go back at any time and do things like change the chamfer box, let detail, and it won't have any negative implications for my volume selection. I'm going to use a noise modifier to randomize the shape of the cushion. I want that to affect the entire object, not just part of the object. And if I apply a modifier now in this state, actually nothing will happen because we still have a sub-object selection in effect. Let me illustrate that to you. Let's say, for example, I add another push or something like a bend. Let's do a bend. And I set that angle and I do all sorts of stuff, and apparently nothing's happening here. The reason is that I'm applying this modifier to volume selection that has been deleted. The selection is being made, being deleted, and trying to apply a bend to it after the deletion. And obviously that's not going to work. Indicator here that I'm still in sub-object mode. That's what these three little dots are. That's telling me that this modifier is only being applied to certain vertices. Okay, trash that. What I need to do here is I need to apply a selection modifier to clear out this sub-object selection. Go to the modifier list and just mesh select. And all that's doing is just wiping out the sub-object selection. So any subsequent modifiers that I apply will apply to the entire object. And I can tell that that's the case because there are no little dots over here. There's no sub-object icon applied. Just illustrate that to you. If I add a bend and change the angle, you'll see that it is in fact affecting the entire object. I'll trash that. And now we're ready to apply a noise modifier to randomize the shape in the next movie. A little bit more lived in. We'll randomize the shape using a noise modifier. I cleared out my sub-object selection so that the noise modifier will be applied to the entire object. In the modifier list, I'll scroll down looking for noise. In the modifier, I'll need to change several parameters. For the strength, currently it's set to 0. This is the maximum amount of deviation that a vertex will make. If I set these to 5 centimeters in each axis, that's a pretty good value. In fact, that's probably kind of a high value. But as I do that, you see that not much has happened. The thing is, I also need to adjust the scale of the noise, essentially the wavelength. A scale of 100 is a very long wavelength. It's not seeing much of an effect here because it's being spread out over a very large area. All I have to do is click and drag and reduce this scale, and you can see, oh, there we go, we're getting some noise. If I take that scale down too low, we'll get some very strange results. They turn into sort of abstract art piece. That's too low wavelength. I just in the sweet spot there, and it was somewhere in the order of 10 centimeters or so. And you can see now, we probably don't need that much of strength, so I can reduce the strength down to maybe like 2 centimeters in each dimension. Adjust the pattern of the noise. All I need to do is transform the noise gizmo. Open the noise subobjects and gizmo. Grab the tool and gizmo around to change the placement of the noise. Different looks. A basic introduction to using a noise modifier. You could do quite a lot with noise. In fact, you could create mountains and all sorts of cool stuff with it. The real basic introduction. Have a lot of fun with noise. We're going to add some more noise modifiers. I've done it on this one cushion, as you can see. But we'll learn about how to copy-paste modifiers and also how to instance them. What I want to do is create a noise that spreads across more than one object. For example, I can select these two armrests. Control select both of those. Mesh select modifier. So clear out any sub-object selection that may be there. And to do that, you'll notice that mesh select is in italics up here. And if I select one of the arms, you'll see at the top of that stack, select in italics. That means the modifier is applied to more than one object. Both with the control key. And I'll also add a noise modifier. And some values here, I've got a scale of 10 centimeters and strength of, let's say, only 1 centimeter in each dimension. Added a little bit of randomness. I'll just up just for a moment so you can see that it is, in fact, affecting both of those armrests. It's down to 1 centimeter. We want that to be a pretty subtle effect. And again, select either one of them. See the instanced modifiers in italics. I'll copy and paste modifiers from one object to another. Got a noise and a mesh select on this one, and I can just copy those onto the next cushion. Those and right-click and choose copy. Go to the other object and right-click at the top of the stack, and it's either paste or paste instanced. I'll just paste this time. Choose paste instead of paste instanced. Then I have independent control over the objects. As you can see here, as I adjust the strength on this cushion, it's not affecting the other one. Continue to undo that. But I also have the option of instancing the modifiers through the copy-paste menu. All those and trash them. Click and paste instance this time. Both affected by the same modifier. And if I change the strength here, it's affecting them both. If I wanted to, I could go down and select the gizmo. Notice that that gizmo is affecting both of them. The options for copying and pasting modifiers can select more than one object and apply a modifier, can copy paste without instancing, or can copy paste with an instance. That's a quick introduction to this non-destructive workflow for building a polygon model. In this, look at some of the advanced polygon modeling tools in the graphite ribbon. I'll just one or two pieces from this robot arm assembly, and then we'll animate it later in the course. Fresh, new scene by 3ds Max. What I mentioned to you is that the object must be an editable poly in order to access the graphite ribbon. If I make any primitive, such as a teapot, and up the graphite modeling tools from the main toolbar, most of the ribbon is actually blank. The tools aren't showing up because this is not an editable poly. All I do is convert it. So the object, right-click, and choose Convert to Editable Poly. And if I've got an editable poly object selected, I've got the graphite ribbon tools visible. We'll look at customizing the interface so that we can optimize the display of the ribbon and the graphite tools. It's part of the robot arm. I'm going to make the turntable part of that robot arm. And so that will start from a cylinder. Create panel, standard primitives, cylinder. Take that out, release the mouse, site. Again, to finish the cylinder, I click to exit the tool. The modify panel, and work with the level of detail on this. In order to see what I'm doing, I'll need to press the F4 key so I can see edged faces. Quite so many height segments here. Let me set that to just 2. The cap segments, let me set that to 2 as well, so I'll get a little bit more detail up there. Sides, I'll set to 36. Set the radius down a little bit to 1.5 feet. Now that the primitive set up, I can go ahead and right-click on it, convert to editable poly. To do that now, you can see I've got all tools available. Graphite ribbon. My panel will need to be activated in order to see all of these tools. If you go back to the Create panel, for example, most of those icons will be grayed out. We turn Modify Mode from the graphite ribbon. And that button up here toggle command panel. What that's going to do when I click it is activate the modify panel and hide the entire command panel, including create and all of the others. And actually helpful because editable poly is redundant to graphite ribbon. In other words, the graphite ribbon includes all of the tools in the editable poly modify panel and more. No real reason for us to have that modify panel visible if all we're working on is graphite tools. I can also customize the graphite interface a little bit. For example, you'll notice that as you move your mouse around onto these different buttons, you get these extended tooltips that sometimes even show you illustrations on how to use the tool. Helpful when you're first learning all the tools, but once you've learned them, then these can definitely be a distraction. All you do to turn them off is right-click on an empty spot on the ribbon, choose Ribbon Configuration, and disable the tooltips. You won't be distracted by all of that. I'd also like to move the graphite ribbon around on the screen because, especially on a widescreen monitor, it's really optimal to have it placed at the top of the screen like this. All to do to move the graphite ribbon is to click on this selection bar on the left-hand side, hold down and drag it out. You'll notice that the cursor has changed to a little dialog box icon. If I release the mouse in the middle of the screen, then I'll get a floating graphite tools panel. That's full if you've got two monitors. You can just put that over on the other monitor and leave it there. In this case, I want to dock it to one side of the screen. Select it and drag it over to the right here until my cursor changes to another icon, and then release the mouse. And that's docked over there. You may need to turn some of these panels off. Limited screen real estate, then all of these panels may not actually fit on the screen at once. Just right-click on an empty spot, choose Show Panels, and activate or deactivate the panels as needed. For this subdivision panel, I won't be using that, so I can turn that back off again. Finally, if you need to get your command panel back, one way to do that is just from the Customize menu. Customize Show UI, and turn the command panel and other screen interface elements on and off at will. For introduction to optimizing the graphite ribbon for polygon modeling. Let's look at sub-objects using graphite. You've got the same types of sub-objects that you do in the ordinary editable poly, specifically vertex, edge, and base. All you do is click to create one sub-object modes. And graphite ribbon will show you tools that are specific to that particular subject type. Just click on a point to select it. Pretty straightforward. I'll point out to you that if you drag a selection rectangle, then you'll by default be selecting sub-objects on the opposite side, or the back face of the object. If you orbit around to the back side, you'll see that those points have been selected. You have the option to turn Ignore Backfacing on. Here, Ignore Backfacing. Turn on, and then make a selection. Any sub-objects that are facing away from you will not be selected. Helpful. The helpful thing is selecting by edge loop. Go to Edge sub-object mode, and if I select one edge, just click on it. But it's common that you'll want to select an entire loop of edges, all of these connected end to end. All you have to do is double-click and select the entire edge loop. It doesn't always work in all cases. For example, is at the rim of the cylinder. If I double-click on that, it may or may not actually select all of those. It takes time. An edge loop selected, we can do things to it, like scale it or move it or whatever. Go to the Scale tool, scale that edge loop up or down. I can go select by face, go up here, select by polygon, and I click on faces. I've still got my Scale tool active. I'll go back to the Select tool. And I can hold down the Control key to add to my selection. I want to select all of the faces here in the center of my cylinder. The convenient trick to this. I convert sub-object selection to a different sub-object type. In this case, if I go into vertex mode and select just that center vertex, Then select all of the faces or all of the polygons that are touching that vertex. Hold down the Control key, click on Polygon Mode, and then all of those faces are now selected, and I can manipulate it. It's a basic introduction to sub-object selection in Graphite. Other cool ways of selecting things in 3ds Max. On the main toolbar, you've got Selection Regions, and you've got something called Window Crossing. Control how you can select objects and sub-objects, not just in Graphite, but across the board throughout the program. I'll go into Polygon Face Selection Mode, and hold my mouse down on this Selection Region icon. I can choose a different shape for the selection region, such as circle. I click in the center and drag outward to define that circle shape, and when I release the mouse, then everything that circle touched will be selected. I do have Ignore Backfacing enabled. That means I won't select anything on the other side of the model. There are selection region types. For example, there's a rubber band. I can just drag my cursor across and select everything that rubber band touches. My favorite is actually the paint selection mode. And just drag my cursor across and select just by dragging. With the Alt key, I can subtract from that selection. Control will add to the selection. Cool. I'll go back to the standard, let's use the circle selection mode. A button that's also quite useful. It's called Window Crossing. Default behavior is that when you drag a selection, any that selection window touches will be selected. If I want to choose the other mode, I can just click here. Now, in order to make a selection, it has to be completely enclosed within that window. I release the mouse now, nothing's selected. Drag my cursor out a little bit more, then any polygon that is completely within that selection region will be selected. There we go. Those are different methods for selection in 3ds Max. Now I've done that, I'm going to actually disable Ignore Backfacing for the next few movies. And Graphite have many advanced tools for altering the topology of the model. That may change its structure, to add and remove edges and polygons. What I'd like to do now is show you the Extrude tool. This is one of the most common and one of the most basic tools. I can polygons and then brush that out to a set of new polygons. Essentially, I can make a tower coming up here. I want to be in Polygon Selection Mode and select those top polygons. I just want to make sure I don't have anything else selected. Extrude tool is found in the Polygons panel. Hover mouse over that, it will pop up there, and you'll extrude. On that, then you'll need to click on selected polygons to extrude them upward interactively. Mouse to complete the operation. Okay, we can get a little bit more control over this. We get numeric values for the height of the extrude. Go back to the Polygons panel. Yet some of these tools have pull-down menus next to them. Click on that pull-down arrow, then you can click on Extrude Settings. What it'll do is open up something called the caddy. It's an interface element that can be moved around on the screen. And it's going to show you a preview of an extrusion that has not yet been made. Back to this height parameter, I hold down the mouse and drag to see the height of the extrusion. Keyboard modifiers for that. If you hold down Control and drag, you'll get a faster adjustment or a gross adjustment. If you down Alt and click drag, you'll get a fine adjustment. This operation has not yet been made. If complete it, I'll click checkbox and close the dialog. Back in there again and go Extrude Settings. To show you that, we're seeing a preview here now. And if I lose my selection, I won't see any extrusion being made. If I click anywhere out here, there are no polygons selected, or there's no extrusion. I'll need to have something selected in order to see that extrude. I can go on Control, select those, get my selection back. Or I could use Paint Selection, hold Control. You'll notice that I've selected things on the back of the model. You'll need to be careful when you're doing this. I can Alt and unselect all of that till back where I was. And this is just a preview. If I click the checkbox, the operation will be completed. So press the plus sign, complete the current operation, and then show me another preview. If I don't want to apply the operation, I can just press the X, and that will cancel out. There are tools that use the caddy. The caddy will be slightly different for each tool because there'll be different parameters, but the interface is the same in each case. One of the polygon modeling is the ability to interactively add and remove detail. And what I'd like to do is flatten out one side of this cylinder here. That by removing edges. I'll go edge subobject mode and click on some of these edges with the Control key held down. Once I've made my selection, I'll tumble around or orbit around to the other side of the model to make sure I haven't accidentally selected any of the back edges. There, we've got those edges selected. Press the Delete key on the keyboard. I'll actually punch a hole in the model. Delete an edge, you'll delete the associated polygons that are touching that edge that I want here. I'll use Control Z to undo that. I want to remove the edges and leave the polygons there. You can do that from the Edges panel here. Remove. Click that, and the edges are all deleted, and the polygons are left. However, if you orbit around and look carefully, you'll notice that the curvature there hasn't changed. The reason is, although the edges have been removed, the vertices are still there. Vertex subobject mode, you'll see that those vertices are still there. Now I can select them and delete them in a second pass, but that's too much work. Really, I can do this in one step. 3ds Max will allow me to remove edges and their connected vertices in command. Do that. Go back to edge selection mode, back to edges. If I hold down Control when I click on remove, I'll remove those edges and their associated vertices. The keyboard shortcut for that is Control Backspace. Very useful one that you'll use quite a lot. Okay, that's been cleaned up, but the tops and bottoms here still have curvature. What I'll do here is remove these vertices. I'll go to Vertex subobject mode and select these vertices with the Control key held down. Press the Backspace key, and now those vertices have been removed. However, the surface isn't flat. See, if you orbit around, what you want here is a flat polygon here and a flat triangular polygon up here. What to do here is use the Cut tool to cut a new edge. The Cut tool is found in the Edit panel. You can be in any subobject or even object mode to access the Cut tool. And a little scissor. I'll hit that. And as I move my cursor around, you'll see that the cursor icon will change. Because the Cut tool actually has snaps built into it. I'll move my cursor over to one of these vertices until my cursor changes to a small crosshair. I'll click on that once. As I move my mouse around, you'll see I'm getting a preview. Over to this other vertex and make sure that it's snapped. Click again to complete that operation and exit the Cut tool. I'll right-click in the viewport. There it is. I've created a nice flat surface there. And I'll repeat that process down here if I need to. Right-click to exit the Cut tool completely. These vertices with the Control key held down. Press Backspace to remove them. And back to the Cut tool. Drop a new edge through there. And I click a couple of times. Go, I've used Remove and Cut to change the structure of the model. The common graphite tool for topology modification is Swift Loop. It's a very, very useful tool that allows you to add a new edge loop anywhere on your model. And it works in any mode. It's found in the Edit panel. Here it is, Swift Loop. Click on that to activate it. Just hover my mouse over anywhere on the model, and that green line is a preview of an edge loop that has not yet been created. If I want to create an edge loop at that location, I'll just click. Got one there. That was so easy. I'll add another one here. 3 edge loops in that area. And if I want to create a little bit of a rounded, fitted corner there, I go into sub-object mode, double-click, select that edge, and I'll use the scale tool, give a little bit of a rounded, filleted corner. That's so easy. Swift Loop is one of the most useful tools you're going to find. It gives us the ability to constrain transforms. This is useful because we can, for example, move edges and keep them stuck to the surface of their polygons. I can constrain from the Edit panel here. This one is highlighted, indicates that constraints are currently disabled. If I go to a sub-object mode, such as Edge, the panel might get collapsed down and it might be harder for you to see what constraints are currently in effect. It is really actually a good idea to see what constraints are currently on at all times. You need to hide some of these other panels just so that the Edit panel will be shown and displayed. And right-click and go to Show Panels and turn some of these others off. There's a lot here that I will not actually be using. The Edit panel is fully visible. Okay. I'm in Edge Subobject mode, and I'll double-click to select that whole edge loop. As constraints disabled, then I have the ability to move those edges around in a free-form manner. Control to undo that. Then I've got different constraint modes here. Constraint Edge is quite useful. But when I move, you see that edges are staying stuck to the surface. That's useful. We've got constraint to polygon or face. That's useful because it only allows you to constrain to one of these 2 faces here. I tend to use that very much. We've got constraint to normal. And normal is an imaginary line that sticks out from the edge. And constraint to normal, it's similar to scale, but it serves the shape better than scale would. Remember when you're finished to disable constraints. A simple introduction to using sub-object constraints with editable poly. Is how to attach 2 polygon meshes together. I'm going to create a ball joint up here with a perfect sphere. I could really do that very effectively by just simply extruding the existing model. I'll create a separate sphere, attach the 2 together, and then bridge the gap. I just want to center the model in the world. Remove tool, select the model, and type in some zeros down here in X, Y, and Z. And that's perfectly centered on the origin. Make some adjustments to the sphere. That means you need to have the Modify panel to do that. Go back over to the graphite ribbon and click the button to show the panel once again. Go to the menu. Before I create my sphere, I want to turn on snaps because I want to snap to this vertex right here. So I want to right-click and make sure that I'm snapping only to vertex. And as I move my cursor around, you'll see it snapping to all the intersection points. Click here. See that center vertex and drag it out. Release and the sphere has been created. I'll right-click to complete the sphere. And turn snaps back off again. Then over the Modify panel, I want to change the number of segments here. Let's get in a little bit closer. Move the sphere up a bit. Important thing here is that I want to have the same number of edges on both of these objects. If you use the bridge tool later, it can kind of compensate for that, but it won't be pretty. It's if they have the same number of vertices and edges. When I created a cylinder, I set it to 36 segments. Therefore, I'll set my sphere to be 36 as well. And you can see that those edges line up. And then clean. Good. The radius. And then I can just attach the sphere to the existing polygon model. I'll set that editable poly and the attach button. I guess the attach button from the Modify panel. Here, attach. Click on that and click on the sphere. And click to edit. Now one object. Select and move, you'll see they move together. You also find the attach button in the graphite ribbon. I've got it hidden, but if I go over here to Show Panels, Geometry All, you'll see the attach button is here as well, and it works exactly the same. We've got a polygon object that was originally two objects. In this case now, there are actually two sub-object elements. To illustrate to you what an element is, select it from the graphite ribbon or from the standard modify panel. An element is part of the mesh that used to be a separate object. In fact, I can still manipulate the sphere separately. Element mode. What we want to do here is create a surface that bridges these two pieces. To do that is to just delete all these polygons. I'm in vertex mode and select this center vertex here and delete it, and that'll punch a big hole there. Go to face mode or polygon mode, and I want to select the bottom parts of the sphere. Keep that neat and clean. I want to do that in one of the ortho views. I'll hit Alt-W, go to the front view, Z key to zoom in, and select the bottom third of the sphere, and delete. To my perspective view, and Alt-W to make that big again. Now I've got two adjacent borders. A border is a series of edges around an open hole. And I can border sub-object mode, and you'll see we selected that entire border. To bridge, I want to select both of the borders. I'll hold down Control, and now both of those open borders selected. You can activate the bridge tool either from the traditional modify panel or from the graphite ribbon border panel. And I can go to bridge, but I really want to get the caddy open so I can control the bridge parameters. Another way to open the caddy is to hold down the Shift key and click on the button. I've got the bridge open. This is really cool because I can do all sorts of fun things here. I can increase the number of segments. Or I can play around with the taper effect. Here we go. A bit finer control over that. I can hold down Alt as I do it. I can all play around with some of this other stuff like bias, that does. So you might need to use the twist control here if vertices and edges are not quite lining up. This is fine as it is, so I'll leave that twist at 0. Well, that's my bridge. With that, I'll just click the checkbox to finish that command. And I can get out of sub-object modes. And say I've got my bridge and I've got my model. The thing I'll need to do is just clean up the edge smoothing. The model. The last thing I need to check in on is the edge smoothing. A polygon edge can be drawn as smooth or as hard. In order to see this, I have to turn off edged faces. I'll press J key so we can see the selection brackets, and then the F4 key to turn off the edged faces. Getting closer here, you can see that some of the edges are drawn as hard or faceted edges, and some are drawn as soft or smooth edges. Max is a little bit different than most programs. Edge smoothing is defined by polygons and not by edges. So I'll select polygons in order to affect the edges. I've got the standard command panel open here. I don't really need that now, so I'll click to turn that off. Right panel, near the bottom you'll see Properties. And we have 3 buttons here. Hard, Smooth, and Smooth 30. This will operate on the entire model. If I click the Hard button, then every edge is made hard, and we get faceted appearance here. Click Smooth, and all of the edges are made smooth or soft. And that works fine up here in this area where there's a lot of curvature. Here where we've got a sharp angle here, that doesn't look right. We want this to be a hard edge. The button is Smooth 30, and that's a very useful one. If I click that now, we get more or less what we want here in this case. Smooth 30 tests the angle between adjacent polygon faces. If that angle is greater than 30 degrees, we get a hard edge between those two faces. This area, that's a nearly 90-degree angle. That's greater than 30 degrees, we get a hard edge. Here, it's a much shallower angle. It's 30 degrees. We get a soft edge. And this actually looks okay. But usually you'll need to go in on a finer level and control individual edges. To do, you'll need to go into polygon subobject mode, not edge subobject mode. can select the polygons and then control their smoothing individually. If I select all these here now, I've got those polygons selected. I can go to the Properties panel and see Hard, Smooth, and Smooth 30 once again. This is a little bit deceptive though, because these buttons will actually operate on the entire model. It will not operate on selected polygons by default. I'll need to go over here to this pull-down list and change the state of this button to Hard Selected. And now I click on that, the edges have all been made hard. However, we're still not where we want to be. We cannot smooth based upon edge selections. We have to make multiple polygon selections to get what we want. They've all been made hard. I want these ones to be hard. What I'll do is I'll need to select all these polygons once again. Then back to Properties, and we want to choose Smooth Selected. And those have all been smoothed. Smooth all of these down here. Those. Properties panel. And Smooth Selected. That's the process for seeing edges in 3ds Max. If you're used to Maya or other programs where you can select by edges, this is much more difficult. You've got to go through multiple steps to make it happen. And is that all the edge smoothing was based upon something called smoothing groups. This has been around since the early days in the early 90s with 3D Studio DOS. We get at the smoothing groups from the Properties panel in Polygon Subobject mode. I can click on this button and open this up. This little panel actually how we can control the smoothing groups. Basically, if two polygons are in the same smoothing group, then the edge between those polygons will be smoothed. Go in here, for example, and I can select all the smoothing groups. Group 1. Click on Select by SG. Click on 1. OK. And all the polygons in Group 1 are currently selected. This dialog is also helpful because it has an auto smooth control that gives me a numeric field that I can enter in a value other than 30 degrees. I select all of these and set the auto smooth value to something like 15 degrees and click auto smooth. And any polygons that have an angle of greater than 15 degrees will have a hard edge. And less than 15 degrees, such as here, will have a soft edge. This is a useful tool here. So I can select all of those, set the auto smooth value to something like 45, and click auto smooth. And now I'm back where I want it to be. That control edge smoothing in 3ds Max. That's a basic introduction to graphite modeling. Are a polygon modeling technique that allows you to easily achieve flowing, curved surfaces. And the bar stool here is from subdivision surfaces. Let's take a look at this and we'll deconstruct it a little bit before we go into the lesson. A 4 key so we can see edged faces, and I'll press the J key to turn off selection brackets. And here on the right-hand side, we will see the Modify panel. And we've got several things going on here. Let me go down to the bottom level, which is editable poly. And show end result is currently turned off, so we can just see that polygon cage only. It's a very simple model. It does a lot of detail to it. But the Turbo Smooth modifier that you see here is subdividing it and smoothing it and giving it a greater level of detail. I've got a symmetry modifier in here, which is just mirroring the editable poly. I'll turn off end result here, so you can see just the symmetry in effect. After it's been mirrored with a symmetry modifier, that's smoothed with Turbo Smooth, and that's creating all of the polygon detail here. Turn that up or down using this iterations right here. At the top of the stack, you'll see I got a smooth modifier, and that's just smoothing the edges and making it prettier. Division surfaces are the ideal choice for character and creature modeling. You have to have a huge number of points on your control cage or on your original polygon mesh. You can have a limited number of points, a limited number of polygons, and then be smoothed and made beautiful. Also, subdivision surfaces allow you to leverage all the tools within polygon modeling. All the graphite tools are available. As opposed to other modeling techniques such as NURBS, which we'll look at later, NURBS did not have as much of a free-form methodology. So they used to be used for character and creature work, but not so much anymore. Before we launch into this, I just want to mention that there are a couple other parts of this bar stool that were not modeled with subdivision surfaces or sub-Ds. Sub-Ds are not necessarily the best choice in all cases. Pull the base of the bar stool here. It would have been a waste for me to use subdivision surfaces on this. All I really needed was a line, profile, lathe modifier, which produces a surface of revolution. If I adjust this degrees parameter, how it works. Sweeping that curve around an axis to create that surface. Likewise, with this footrest here, ellipse primitive, the sweep modifier applied to it with a cylinder section. We won't be covering those specific techniques in this chapter because it's all about subdivision surfaces, but it was important to point out to you that you should choose the best tool for the job. The first subdivision surface model is to make a box. In fact, we're always starting from a box or a cube. For this is that on a cube or a box, all of the polygons are quadrilateral, and you have more than 4 edges meeting at a single point. Objectives such as cylinders and spheres are problematic for subdivision surfaces. To illustrate this, I'll make a cylinder and then drop a modifier on it called Turbo Smooth, and that'll convert it to a subdivision surface model. See, that doesn't look so nice. And there's not a lot we can do about this. I mean, I can increase the number of iterations, which will make it rounder, but we're always going to have this ugly structure to it. You can see it's even got these weird bubbling artifacts and things going on. Not a good outcome. It's because all of these lines or edges are meeting at a single point up here, which is called a pole. And you'll all start from a box. Delete that. I'll build a box out a little bit larger than the object needs to be. Right-click to end box creation. Center it. So move and type in zeros in the type in area at the bottom of the screen. Just position that up. I need to set a base level of detail before I go any further. Modify panel. Set the length, width, and height all to a value of 4. That's a good starting value. If you take up past 4 or so, in this case, it'd be a problem because you'll have too much detail. The whole idea of subdivision surfaces is you've got a very limited amount of detail in the original polygon mesh, or what we're calling the control cage. Control cage should be very simple. Where you'll have a limited number of points, you won't get bogged down in trying to move around a million points. Important at this stage is that I want to have an even number of divisions in the x-axis here. That my number of width segments needs to be even number. The reason is this is going to be a symmetrical model. To do that, I'm going to use the symmetry modifier. That'll save me a lot of time because I'll only need to model half of the object. For that to work correctly, I need to have an edge that runs right down the middle of the object. Therefore, I'll need to have an even number of segments in the x-axis here. 4 and 4 works fine for me. So I've got a box, and I'll just go ahead and convert that to editable poly. Right to editable poly. To continue onward to create my subdivision surface model. The symmetry modifier. That way I can just model 1/2 of the model and the other half will be mirrored automatically. It works best if I delete half of the model. Go into polygon subobject mode. I'll delete the half of the model that's in the negative x-axis. Delete key. And now I've got half of a box. Out of subobject mode, add the symmetry modifier. One called mirror, that's not what you want. You want symmetry. And the reason for using symmetry rather than mirror is that symmetry will actually join the two halves together and weld all the vertices, or join the seams. If you deleted the half on the negative x-axis, then you will get exactly what you see here. Symmetry assumes that you've deleted 1/2 on the negative x side. If I deleted the positive x side, then I would see something like this. Mine would kind of disappear. If that were the case, then I could just enable this switch to flip the symmetry. You'll see that there is an option here to weld the seam. That should be on. Therefore, we will get a continuous surface here. It's join the two parts together and weld all of those points. So now, if I go back down to my editable poly and turn on Show End Result, I select sub-objects such as vertex and move those around, and see that now we're getting symmetry for free. Save us a whole lot of time. Out of sub-object mode, and there we go, I've got a symmetrical model. Now the model, let's add the smooth modifier. We'll then subdivide each one of these polygons into smaller polygons and average the angles to round out the surface. 3ds Max has several different methods for doing this. You might see other tutorials that talk about mesh smooth or HSDS, and this will work as well. But what you really want is turbo smooth because that's very fast and very efficient. It'll update really quick in the viewports. That's turbo smooth. And turbo smooth is now added at the top of the modifier stack. The most significant aspect of the turbo smooth modifier is the number of iterations. It's the number of times that the subdivision algorithm is being applied. What this does a little bit more clearly, I display the polygon count in the viewport. Click the 7 key on the keyboard. And now what you'll see in the upper left-hand corner are statistics. These statistics display the polygon count for the entire scene by default. And no matter what I have selected, it's showing me that I have about 4,000 polygons in the scene in total. What I want to do is I want to know how many polygons I've got on this one object. That I'll need to go into the viewport configuration and change up the statistics options. Click on the little plus sign up here. Figure viewports. Statistics. The one I want to choose here is total plus selection. Then I'll be able to see the total number of polygons, the number of polygons on the currently selected object. See, currently with iterations set to 1, I've got about 700, 800 polygons. If I increase the iterations to 2, the value suddenly jumps. Now I've got over 3,000 polygons. Each time you increase the iteration value by 1, you're actually multiplying the number of polygons by 4. I said all the polygons are quadrilaterals to begin with. If that iteration's up to 3, now I've got over 12,000 polygons. 3 is not the maximum that you would ever want to go up to. If you push iterations past 3, it might look nice and smooth, but in fact, it's overkill. You'll see here I've got all 50,000 polygons here. We won't need 50,000 polygons unless we're getting up super, super close to the object. I mean, literally, we'd have to be sitting on top of the object in order to be able to see all those. Iterations is usually too much. In fact, 2 iterations is usually the optimal sweet spot. If you need to get up past 3, that's that you've probably got not enough detail on your original editable poly or your original control cage. An value of 2 is usually optimal. Now part of subdivision surface modeling in Max. I go down to the editable poly level of the stack. I now go into a sub-object mode such as vertex and make adjustments, like moving a point around, and you'll see that that's affecting the underlying subdivision surface. Wow, that's really cool. A little bit easier to see by turning the edged faces off with F4. And also, all of the tools within Editable Poly or Graphite are available at my tips, and any command that I perform will flow upward through the stack. I do an extrusion here. I'll expand that command panel a little bit. Select by polygon, and I'll put a couple of polygons up here at the top. Select 2 polygons here. And I can extrude. Here we go. Extrude. Snap. Click and drag. In this case, I'm dragging downward. Extrude down. And mouse. And they're good, actually. But technically, there's something that I need to look at here. If you look closely, you'll see that there's a line here. There's extra polygons here in the center that I can't really see. Clean those up. Right-click to exit out of Extrude. And turn Show End Result off for a moment so we can see the issue. You see these polygons here. Those got created during the Extrude. And although Symmetry Modifier is kind of cleaning up that mess for me, it's probably better to not have the mess in the first place. I'll Control select those two polygons and press the Delete key on the keyboard. Now I've got a nice clean open border here. That's important because later on I might need to select that border, and if those two polygons had been there, I wouldn't be able to. Any of the tools within Editable Poly or Graphite, and they will flow upward to my Turbo Smooth. Now pass at sculpting the subdivision surface model. As you see, it looks quite boxy here. I'm just laying it without the edged faces. I've got the selection brackets around it. That it's really, quite square. In fact, that's the sort of Achilles heel of this whole technique. Because starting from a box, you need to do some extra work to make it not be a box. Especially if you're doing character or creature work. Really boxy shape, it's not convincing at all. You'll need to look in all the ortho views to make sure you're not getting a boxy shape. In this, I want to go to the top view. Alt-W. The top view, click in there so I don't lose my selection. Alt-View again to maximize the top viewport. Go down to the Editable Poly. Turn Show End Result on. And go into Vertex mode. And what I want to do is move these points around to make a cylinder out of this cube. This is just one point here. There are 5 points in that location. They're all stacked vertically. It's all of them. Drag selection rectangle there. Grab Move tool. Move that around. Do that for all of these. I also use the Scale tool too while I'm at it. I can down Control and select these just to save a little bit of time. I'll use Scale tool. Scale only in the Y-axis in the viewport here. You think for these, Control select them. That down. What I'm trying to achieve here is a round shape. Can select. Get the tool too. And trying to push these around until I get a more or less round shape. And luckily, I've got a circular object as a reference point. The bar tool base I can use as a point of reference to achieve a round shape. It'll never be exactly round. Important, you need to know this about subdivision surfaces. It's actually completely impossible to get a perfect sphere or a perfect circle. Skeletons in the closet. Okay, because you can usually get it close enough that the average viewer will not notice the difference. Select all of these points here, maybe move that in a little bit. Just take a few minutes here to shape this up. Use Scale and Move. I'll try to make them as equidistant as possible. At this stage, I want to have a sort of uniform shape. And that means that the polygons will be about the same size. All right, see what that looks like in the perspective view. Go back to Alt-W. And see what I've done. I converted that box into a cylinder. Now shape of the subdivision surface model to get that bar tool that has that elegant shape to it. What I do actually first is to delete the bottom polygons, and that'll give me a much cleaner edge at the bottom here. The grid's kind of in my way, so I'll turn it off by pressing the G key on the keyboard. Then down into the Editable Poly and turn on Show End Results so I can see this as it happens. I'll enter into Polygon Subobject mode. hold down Control and select all the bottom polygons. Once those are selected, I can press the Delete key on the keyboard. Now you'll see I've got a nice clean edge at the bottom there. What I want to do here is to scale these edges so that they will move towards the center. I'll go to Edge Subobject Mode. And like that whole edge loop just by double-clicking on any one of these. If I use the standard Scale tool, notice that the Scale gizmo is not really at the center here where I need it to be. And if I try to use the Scale tool at this point, split my model apart. Control Z to undo that. It will happen no matter which axes I scale in. If I'm in the center here, I'm scaling in all three axes. I try to scale only in X and Y by clicking on this bracket, but that doesn't actually solve the problem either. Like that. What I do is to move the transform gizmo to the center of the world. I'll go up to the main toolbar. I've got Scale tool active to use the world coordinate system. What this pull-down list is here is a reference coordinate system, and the default is View. Click on that and choose World. And what it does is it chooses the world axes as the reference for the scale transform. Now, I don't see any change on my screen just yet. There's one more thing I need to do here. And this third button over here, a mysterious one, and called Use Transform Center. If I click on that and hold it down, I get a flyout. And I have the options here. Use Pivot Point Center, Use Action Center, and Reference Coordinate Center. The one I want is the third one. What that'll do is it will use the current reference coordinate system as the position for the transform gizmo. And release the mouse on that. Now, my Scale tool is positioned exactly at the world origin. Turn it on just for a second with the G key. So you can see that the scale gizmo is now positioned at world coordinates of 0, 0, 0. So far, so good. Now try scaling this. If in the center of the scale gizmo, all points on that edge loop will move down towards the scale gizmo, or towards the origin, scaling in all three X, Y, and Z axes. But what we want is to scale only in X and Y. I do that by clicking on this little bracket here. And those edges are not moving closer in this axis. Okay, so that's cool. That basically does what I want it to do. However, it's not really convenient to have the transform gizmo here down at the origin. It would be a lot easier if I could just click on those edges and scale them around world X and Y just directly without worrying about the transform gizmo. I can make that happen by the axis constraints. I'll click on any empty spot on the main toolbar and open up the axis constraints toolbar. You remember this from an earlier chapter. We can bypass the transform gizmo entirely and choose the axes that we want to, in this case, scale around. X, Y is currently active. I think that that means that I'm scaling in X and Y, but it's actually not quite that simple. By double-clicking on another edge loop up here, and I try to scale this now, it's actually going to scale in all three axes, despite the fact that only X and Y are apparently active here. Another little mysterious thing I need to do here. I need to change the behavior of the scale tool itself. The tool is a flyout. If I hold that button down, I have three options. Select and uniform scale, select and non-uniform scale, and select and squash. The one that I want is select and non-uniform scale. If that's active, then the axis constraints will be in full effect. I can just click on that edge loop and drag and go. Exactly the behavior we needed. We need to set these options correctly up here. In review, we want to be in non-uniform scale. Our reference is world. And the transform center is on the third icon here, which is use transform coordinate center. So I can double click on any one of these edge loops and scale it. You notice as I do that sometimes the edges actually go inside the model. That's a problem. That's normal. With that, you can just go to wireframe mode 3. And then double click on one of these edges here. And that'll be an edge loop. And I continue to scale this and shape it up a little bit. So that's how we use transform coordinate centers in 3ds Max. Let's removing detail with edge loops and shaping up our model by positioning those edge loops. Back down into editable poly and selection mode. And I might need to turn show end result on and off as I work. And I need to hit F4 to make those edges visible or invisible. What I'd like to see here is a sharper transition at this location, which means that I need another edge loop here to define that curvature. I saw earlier we could use the Swift Loop tool to insert an edge loop. We can also do it from the traditional editable poly tools here. Use Connect. To use Connect tool, I want to select edges. I want to then split in half. So I selected all those edges and got the Connect tool here. All I need to do really is just click on it and got a new edge loop there. Currently selected. I'll show end result back on again so I can see the results and move it and scale it. I'm moving it up or down in Z. If I scale it, I'll go back to my select a non-uniform scale tool, just as we had in the last movie. I haven't changed those settings. I scale that edge loop as well by activating the select a non-uniform scale tool. And still got the world coordinate system as my reference, and I still have use transform coordinate center active. But I can't see the edge loop because it's inside the model. It means I'll need to show end result back off again. And I can scale. And turn show end result on again. If loops are close together, then we'll get a sharper curvature at that location. I can straighten that up here at the top once again. Select all these edges. Click Connect button to create a new edge loop. And there's the Move tool to position them. The closer those edges are together, the sharper the curvature will be at that location. If they're far apart, we'll get a soft curve. If they're together, we'll get a sharper curve. Top of the model here. What I want to do is select it and go down into the editable poly and select just the top polygons. I'll select this second row of polygons too. That's easily done by just clicking the Grow button here, and that just extends the selection out. Move tool goes down. Grab a tool and tilt it. All right, looks pretty good. Looks like with show end result turned back on again, and with edged faces off, F4. All right, that's pretty good. Now I'll move some of these points around here to shape it up a little bit better. I'll go to Vertex Subobject mode, click these guys, and use the Move tool. And notice that if I move this point back, that it's not remaining flat. This polygon up here is now getting skewed. I'll undo that. I want to make sure that this vertex only moves along that edge. Easily done either from the graphite toolbar or on the traditional editable poly panel by using constraints. Here are constraints now. I just constrain to edge. And now when I drag this, move along that edge, which means that the top here will remain flat. Right. Bring down. And also constrain to face if I need to. We'll try that. That worked just fine. Bring a lot of these in. A little bit of a display glitch there, but seems okay. trouble with face constraints, I can switch back to edge constraints. Continue working on this for a while until I get what I want. I'm not going to do that now. I'll let you do that on your own time, but I will mention that it's very common that you'll accidentally move these points away from the center. This is a really common issue that you might experience. If those points are not exactly at an x value of 0, then you're going to have issues. Turn my constraints off. And it doesn't matter if it goes over in the negative axis or in the positive, you're still going to have problems with the model. What can we do about this? I'll demonstrate to you this trick that we can do to restore the integrity of open border here. All of the vertices here will be at an x value of 0. I'll show end result off. I'll turn edge faces back on again with F4. What I need to do here is I need to move each one of these points back to an x value of 0. I can do that for individual points one at a time by just using the Move tool, selecting the point, and setting the x position down here to 0. And fine. But what you find is as you work, not just one point, but many of these points are going to kind of drift away from the center. And some way of restoring them all back to an x value of 0. The problem is that in 3ds Max, you cannot move multiple points at the same time using the transform type in down here. There is a trick to this. Up, I want to be in select and non-uniform scale mode. I have the world coordinate system, my current reference. Have used transform coordinates as my coordinate center. And select the entire border in border subobject mode. Click any one of these edges, and I've got that entire open border activated, selected. And the trick here is I'm going to convert that selection to a vertex selection. The control key, click on vertex subobject mode. Now selected all of the points as seam. Now to open up the transform type in dialog, I'll right click on the scale tool. Now I've got scale transform type in. And I'll put this x value up here to 0. Type in 0, enter. And all of those points have been scaled in x to have a value of 0. That's a little bit of a cumbersome method in order to restore all those back to a value of 0. It would be much easier if we could just select them all and type in a 0 with the Move tool, but we can't. This is the workaround. I've worked it more and sculpted it a bit more. I'm almost ready to complete it. The other little things I want to show you first. First is creasing. Maybe I want a little bit sharper edge around here. Now I do that by adding more edge loops, but that would increase the level of detail of the model and it would make it unnecessarily heavy. I'm going to go back down to the editable poly edit mode and you see in the edit edges section there's a crease value. I'll double click on edge loop and increase the crease value. And that's sharpening up that edge without increasing the level of detail. If I go the edged faces with F4, we can see that it's not increasing the number of polygons and edges. It's pushing those closer to the original control cage. Do that actually for both of these edge loops here. So I'll hold down Control and click here. Increase that up a little bit. The value of, let's say, 0.3. Now, in that process, it has also sharpened up the edging. In other words, these are now rendering as hard edges. If I turn F4 back off again, you see that we're getting this hard edge. We want the structure to have this sharp corner here, but we don't actually want it to be rendered as a hard edge. I'll go out of subobject mode, go to the top level of the stack, and add an edge smoothing modifier, which is called Smooth. Not be confused with Turbo Smooth or Mesh Smooth. It's straight up ordinary smooth. Add it, it's actually disabled by default. I'll auto smooth on the threshold up here to, let's say, 45 degrees. I helped with this edge here. I have a greater value if I want. Maybe I want a threshold of even higher, like 90 degrees. And now that really softened this up quite a lot. Okay. To finish this model, then I want to save it in this state. I want to convert it to an editable mesh to make all of that permanent. Just want to double check on my turbo smooth iterations. I'll hit F4 to look at edged faces. I want to ensure that I have the right number of iterations here before I convert to editable mesh, because that's a destructive act. Default iterations of 2 seems fine. Object selected, I'll right-click in the viewport and choose Convert to Editable Mesh or Editable Poly. If really finished, then I would use Editable Mesh because that's a more efficient format. However, I do have a little bit of detail work to finish up here. So to convert to Editable Poly instead. What I want to do here finally is to remove some of these edges here. These loops here, not really necessary. Really want this to be a straight line here. And I reduce the overall level of detail a little bit. Turn on my statistics again with the 7 key. And we go back into my viewport configuration and turn on total plus selection so we can see that the total number of polygons for this model is now about 1,700 polygons. I'll go to edge selection mode, a little bit closer here, and double click on one of these. Selects the entire edge loop. And I'm going to delete that and all the vertices. And the shortcut for that is Control Backspace. I've done that. I've had a net loss of about 100 polygons. A couple more times here. Double click on those. Hold down Control. Click on that. And then hold down Control and the Backspace key. I further reduced the level of detail for this model. I've only got about 1,500 polygons on it. There's no need for me to have all of those there if this is just going to be a straight line. And completed this subdivision surface model. I'm doing no more work on it, then I can convert it to an editable mesh, which will be a little bit more efficient version. Convert to editable mesh. Helpful sometimes if I've got lots and lots of these in a scene. Let's say I got a bar that's got, 20 or 30 of these. Editable mesh will be a little bit more efficient. That's a real basic introduction. You can extend this to model lots of stuff, include characters and creatures. And look at NURBS modeling, curve-based form of modeling. The example we'll be using here is this artistic-looking cocktail table. Advantages of NURBS is that the level of detail can be set separately for the viewports and the renderer. As you can see, this is looking a little bit blocky, a little bit chunky and angular. However, if I do a quick rendering by clicking on the teapot on the far right of the main toolbar, see that it looks nice and smooth in the rendering. It lends itself very well to these forms of industrial objects, hard surface models that don't deform. And in fact, many of the gadgets and objects that we use in our daily lives were designed using NURBS. Not really suited to character and creature modeling so much. If you want to create a person or an animal, you do that using subdivision surfaces. Let's dive into NURBS modeling. Start from curves. To make that cocktail table, in fact, we're going to use standard Bezier spline curves and convert them to NURBS. I do want to show you how to create NURBS curves from scratch. Maximize the top view with my Alt-W hotkey. Create panel and shapes. One of the items within that pull-down list is NURBS curves. You'll see there are 2 types of NURBS curves available, point curve and CV curve. This is a distinction that usually doesn't exist in most NURBS modeling applications. If you are using Maya or Alias Studio or one of those other programs, there will be one type of NURBS curve. 3ds Max, there are in fact 2 different types. All the point curve. If you click in the view, you'll create points that exist on the curve. Just making them, you can right-click. Right-click again to exit the tool. You want to change the shape, Modify panel. And I activate the Modify panel and I have a NURBS object selected. You'll see I get this NURBS toolbox showing up. I'm actually going to be using that because for the text buttons over here. I'll close that NURBS toolbox. This has a couple different types of sub-objects. First of all, there's the curve sub-object, which is just the entire curve. More importantly is the point sub-object and points that we created. I'll grab the Move tool and move these around. As I move this, it's having an influence not just on these sections here. In fact, it's having an influence way all the way over here. In fact, that's sort of the Achilles heel of the point curve. For that reason, I don't use it very much. It's difficult to control. I'm going to delete that with the Delete key. I'll go back to the Create panel and show you how to create a CV curve. This was a little bit more intuitive. I'll click a few times to create some points. Click to complete the object. Again to exit the tool. Go back to the Modify panel. In the subject types, you will see Curve CV. C stands for Control Vertex. And the more intuitive of the two types of NURBS curves. A little bit different than what you might be used to from Bezier splines, that we have the armature or hull that surrounds the curve. And it's basically a set of lines that join the CVs or control vertices. That's a bit of getting used to. But it is much easier to control because, as you can see, it doesn't have an undue influence over the entire shape. That's the introduction to NURBS curves and how to create them from scratch. How in the exercise, we'll be creating Bezier splines and converting them to NURBS. And that we'll do in the next movie. Full tool set of 3ds Max, I'm going to combine a Bezier spline workflow with a NURBS workflow. Start by creating Bezier splines and then convert them to NURBS curves. Then, to make things a little bit easier on myself, I'm going to make sure that when I create objects, they'll be assigned random colors. I'll go here to the Create panel and click in the Name and Color rollout. Assign random colors is turned on. That way, when I make multiple spline curves, they'll be in different colors and I can see the difference between them. So I want to set up the units of measurement. This is in metric. Go up Customize, Setup. Set the display unit scale to metric. This is fine. Click. Need to set the grid. Go up to any one of the magnet icons and right-click on that. When I'm snapping to grid points and not vertices, so I'll make sure that grid point is the only thing active. I'll go to the Home Grid section and set a grid spacing. A minor grid line every 10 centimeters, and then a major grid line every 10 times 10, or every 1 meters. The view grid extent, make that a value of 20. What it'll do is it'll make the stage here 10 centimeters times 20, or 200 centimeters from center to edge. Press key, and that value will be accepted. A little bit in the top view. I want to make a reference box just to make sure that when I build something, it's the size that I think it is. Box, and then I'll set its size to be 100 centimeters in each dimension. That's cubic meter. A sanity check to make sure that when I build something, it's at the right scale. I'll do that later. Move to the side. I'll maximize the top view with Alt-W. Go ahead and create curves for the top of the coffee table. Go to the Create panel, lines, and I'll reform line. And it'll be about a little more than a meter in length. It's 120 centimeters there. Clicked, I didn't click and drag because I need those to be corner points or straight lines. I points and then I'll right-click to exit. A couple of arcs on either side. Click arc, click end of that line, mouse button down, move down a bit, let's give it out 50 centimeters there. Mouse, and then drag out to set the radius of the arc. That look there? You can see in the lower right-hand corner there, my radius is currently 30 centimeters. Click again to complete that arc. I'll make another one over here too. Let me zoom in a little bit with the mouse wheel. Really close on that. Make another arc over here. Hold the mouse to make the first point. Down, release the mouse, and then to set the radius. To finish the arc, and then right-click, complete the arc tool. Now one more line to join these two parts. Go to the line tool, click, and slice, and right-click to exit that line, and right-click to exit the tool. So I have 4 lines in here. I need to combine them all together and clean them up before I convert them to NURBS. The spline objects here. What I need is actually a single NURBS curve. To combine all of these to a single object and then convert to NURBS. I've set snaps turned on. Let me turn those off. You can do that with the shortcut key, which is S for snap. On the Modify panel and select one of these lines. Lines are editable spline objects, which an attach button included in them. Here we go. The geometry rollout, you'll see attach. I'll click that and just click on each one of these other objects in turn. When finished, I'll right-click to complete the attach. One single object. I'll load the line subobject types. However, if I go to the spline subobject, that they're disconnected splines, sort of like elements on a mesh object or a polygon object. Is one single continuous spline here. That's important, in fact, because if I have several spline subobjects within this line, once converted to NURBS, it'll still maintain that break. And then when we create surfaces from this line, it won't just be one surface. In fact, it'll be 4 surfaces that are sort of just parked next to each other. Be continuous. That we'll need to weld the vertices and make sure we've converted them to the type Bezier vertex. Go to Vertex subobject and selection rectangle around those 2 vertices. There are 2 points there, not just one. There are 2 coincident points. And find the weld button. I'll have to go down a little bit in that geometry rollout to the weld button. Click that, and something happened because now I see 2 tangent handles instead of just one. Go next one, and weld. In fact, I can do more than one at a time. Got now 4 vertices selected. And as long as we have a non-zero weld threshold here, we will to combine these 2 vertices and these 2 vertices. Click on weld. Now we check in on these and make sure that if they are Bezier vertices, not Bezier corner, not smooth, but Bezier vertices. I select one of those vertices and then right-click in the viewport. I'll get the quad menu. And you'll see it says Bezier corner. That's going to work. If it were a Bezier corner, then when we convert to NURBS, once again, we would get 4 separate surfaces. These are all Bezier vertices. I can convert more than one of these at a time. I can just go and select that, hold Control key and select these as well. Click and choose Bezier. To clean up here to straighten up this line. Good, I just want to make sure that these are all Bezier points. Bezier corners, anything else, that they're all Bezier. And check boxes there, it's fine. All that remains is for us to convert this Bezier spline to NURBS. I'll exit out of subobject mode, and the curve selected, simply right-click and convert to NURBS. There you go, converted it to a NURBS object. Next we'll actually start editing that object and making several different curves that we can join into a surface. Curve in this NURBS object. Select it and go to the Modify panel and open up the subobject types. You will see Curve CV and Curve. Don't turn off by the fact that it says NURBS surface up here. I don't actually have a surface yet. only one type of NURBS object in 3ds Max and could contain curves and or surfaces, and it'd be named NURBS surface or it could be named NURBS curve. It doesn't matter what that name is. Again, there's only one type of NURBS object in 3ds Max. I'll hit Alt-W, go out to my 4-viewport layout. Reference box anymore, so I'll just delete that. I need to create a couple more curves in order to build a surface. Get a bit closer on that. There are ways that I could do this. I could scale the curve, or I could make an offset. Scaling is quite simple. All I need to do is select the curve, click, and then use the scale tool and hold down Shift. And with that, I'm making a clone of that sub-object. When I release the mouse, I get a pop-up dialog that asks, do I want an independent copy or transform object? Independent copy, as the name implies, has a connection back to the original curve. If it were a transform object, then it would be sort of locked in place, as is. If I made changes to the original curve, it would also change this duplicate curve. What I want here is independent copy. Okay. I need the ability now to move that around and position it. I've cloned a sub-object curve within this NURBS object. Of creating curves within this NURBS object. Select the object and under the curve sub-object type. In fact, I just want to scale this down a little bit more. Position it, center it a little bit better. And I want to create something called an offset curve. What's the difference between an offset curve and simple scaling? Zoom in on that with Alt-W. And then I can use the scale tool to create a duplicate curve with the Shift key. I release the mouse and create an independent copy. I can go around to show you that with this scale technique, it's not possible for me to maintain a consistent distance between the two curves. To do that, I need something called an offset curve. In fact, delete the one that I just made. I just created that as an illustration. So the software is that in order to create a new curve, I cannot actually be in curve sub-object mode. I need to exit out of sub-object mode, and I need to be in object mode now. A lot of rollouts here in the Modify panel. Let me open some of these up here, especially this one that says Create Curves. That's the one I really need. I could use the NURBS toolbox, by the way. I prefer to use that because these icons are not really that obvious to me. I prefer the text buttons. Here we go. Offset. Activate that button and click and drag. Create the offset curve. And see, it's maintaining a consistent distance from the original curve. And when I want more or less, I'll release the mouse and offset curve. And I can right-click to exit that tool. You'll know now that the offset curve is in bright green. That's an indicator that it's a dependent curve. It's dependent on some other curve in the object. I'll go by 4-viewport layout with Alt-W. I don't need these selection brackets in the shaded view, so I'll press the J key to hide those. Go into curve sub-object mode and select this. I actually cannot move it independently of the original source curve. There's a connection between those two. What I need to do in order to position them separately is to make this offset curve independent. I'll go into the Curve Common Rollout, find the button that says Make Independent. With that now, I've broken the relationship between the two and to move them separately. That's another curve. We only got 3 curve sub-objects. We're ready to generate a surface. Object, and go to the Modify panel, and I'll go Create Surfaces Rollout. And U-Loft. Loft in NURBS is a little bit different from a standard loft compound object in 3ds Max. A loft does not require a path. It'll join these shapes together. I'll click and then click on each one of these curves in turn, either from top to bottom or bottom to top. Next, I'll right-click to complete the loft, and right-click again to exit the tool. Orbit around in there a little bit. fact, I'll turn my display mode back to shaded just to simplify things a bit. Okay, let's quick render of that with the teapot on the far right of the main toolbar. And it doesn't look quite right. It's a little bit brighter just so we can see it a bit better. Bright color. Again. And you can see that it doesn't look anything like what we see in the viewport. The issue here is that depending upon what order you select the curves, the surface might be turned inside out. To put it in technical terms, the normals might be reversed or flipped. That's exactly what has happened here. You need to make sure that those normals are facing the right way. To that, I'll go to Surface Subobject Mode and then select that surface. I can press F4 so we can see the edged faces, and then I know that surface is actually currently selected. And here in the Surface Common rollout, you will see some options for normals. If I turn Display Normals on, see little blue lines stick out. And this line here, that is showing the orientation of the surface. It's pointed towards the interior. I want that line to point outward so that this surface will be renderable on the outside rather than the inside. I'll fix this to choose Flip Normals. And that line is pointed out instead of in. To do a rendering of this, it looks perfectly fine. It selected the curves in the opposite order if I had gone from bottom to top, and the surface would have been oriented in this manner instead of inside out. You'll know in advance whether those normals are going to be pointed in or out. You need to go in here after you've made each surface and verify that it's in the right direction. Necessary to click the Flip Normals button. I mentioned that you don't want to use the normal modifier. There's a separate modifier that you could add to the stack which reverse all of the normals on the object. Good, because in fact we will need to adjust the orientation of the normals on each individual surface within the NURBS object. If the modifier, it would flip all of the surfaces. And if I do it this way, I can choose which ones need to be flipped. Structure of the model. I'm ready to go in and adjust the form. Do that by changing the shape or the transforms the original curves. I'll curve subobject mode. And you can see that if I click on any one of these curves, it'll be highlighted in red, indicating that it's selected. Selected, I can move it and adjust the shape of the object. However, as you see, I move that around, my surface temporarily disappears until I release the mouse. Actually, an intentional design choice in 3ds Max. The NURBS toolset was created some time ago when computers were a lot slower, and that was necessary in order to maintain performance. Well, now computers are a lot faster, so we can go ahead and turn that option off. That will be found at the top level in the Modify panel. I'll need to exit out of subobject mode. And looking for in the general rollout is this switch that says Transform Degrade. That means that when I transform part of the object, it's going to degrade the display. I'll turn it off. Then back down into Curve subobject and do what I'm doing as I work. That's more effective. All the standard tools like Scale. Select another curve and scale that too. Maybe this bottom curve and scale that up. I want to have a little bit of a lip at the bottom here. Then I'm going to create an extrude surface that just goes straight down. To do that, I'll move this bottom curve up just a little bit. Go to the ortho views with Alt-W. In the front viewport. Grab tool. Move this up a little bit, maybe a couple of centimeters. I get the bottom of my screen how far I'm moving it. Put that at about 2 centimeters up. I get a lot more time editing this if I needed to. I could go into Curve CV mode and I edit these individual curve points. For example, this one. Move that around and try to shade up a little bit. A lot of time to do that in the lesson. Illustrate to you that you have the ability to change the surface by moving the curves or moving the curve control points. of thickness here at the bottom of the base of the cocktail table. And I can do it very simply using an extrude surface. And to create a surface, I need to be in object mode and not in any sub-object mode. And you'll see in the Create Surfaces rollout, I've got Extrude. Very similar to extrusion with polygons. All I do is click on one of these curves and drag up or down to create the extrude surface. I'll release the mouse and then click to exit the tool. These surfaces have parameters. What I need to do if I want to change the height of the extrude is go to the Surface Subobject mode, select the surface, and you can see here in a wireframe view that it's highlighted in red. And the extrude surface has got some parameters here, specifically the amount. I'll set to -2 centimeters. Press Enter. Of the two surfaces in this object, what remains for me to do is to set the surface approximation or the level of detail of the NURBS surfaces. With NURBS object, the last step is to define the surface approximation parameters. It's also known as tessellation, which is tiling. A surface is actually a mathematically perfect, idealized vector surface. And theoretically, we could zoom in infinitely on that surface to any level of detail we want. 3ds Max does not have a NURBS renderer. It's a polygon-based renderer. In order for the NURBS surface to be displayed on the screen or rendered to disk, it needs to be sliced and diced up into polygons. And the surface approximation rollout is all about. Let's open that up in the Fight panel. Surface approximation. See here that there are two radio buttons at the top, one for the viewports and for renderer. That by default they have different settings down here. And we see one level of detail in the viewport and another level of detail in the renderer. It's much smoother here than it is in the viewport. A good feature of NURBS, the fact that we can set different levels of detail for the viewport and the renderer. We can have fast performance in the viewport, but really smooth curves in the renderer. I'll maximize that with Alt-W. You'll only be able to see changes if you make adjustments in the viewports section here. If I click on these presets, for example, you'll see that it's adapting the level of detail in the viewports. If I do the same thing with the renderer option chosen, I won't see anything happen in the viewports. And this is a bit unfortunate. I'm essentially flying blind here, and I don't know what I will get. One thing that you do to work around this issue, you use the viewport settings and choose an option. And once you have everything you want down here, then you'll plug those same values into the renderer section. In case I can just use this high preset, and that's an easy way to do this. Also, there's this switch here that says lock. Is not a way to lock the render and the viewport settings. What the button does, in fact, is allow you to control all of the surfaces in the current object at once. If you want to, you can turn this lock off and then adjust each surface separately by selecting it. I'm going to leave it on, and I just show you how these parameters work. Spline curvature is the default tessellation method. Lower numbers here will result in more detail. Once I release the mouse here, you'll see that low numbers are going to give me a better curvature. I can different ways of doing that. The spatial method, which is really only testing the length of an individual edge. Large numbers will give me longer edges. The curve method is detecting the angle of the curve on the surface. Play around with the angle value, and again, lower values are going to give us better approximation of curvature. There's a distance factor here. Lower values are going to increase the level of detail. Finally, the default method, which is using all three of these. Them to, let's say, 5, 5, and 5. Now, at this, you may notice that some areas have higher detail than others. And that's because in this area here, I've got control vertices that are closer together. Is where there are fewer control vertices on the original source curves, I'll get larger polygons in my tessellation. If I needed to, I could go in and refine those curves and add more points there. Another way to tessellate, up here at the top, you'll see regular and parametric. Let's try regular. I'll turn that on. And you'll see with the default U and V steps of 2, we're getting very poor approximation. Regular method, then these U steps and V steps are going to need to be increased quite a lot. And that produces a fairly uniform tessellation. The method can be dangerous if you're not careful. Just clicked on parametric right now, there's a very good chance that I would crash my machine. The parametric method is based upon the number of CVs on the curve. These U and V steps need to be set down to an extremely low value. In fact, a value of 1 is really the best value to start with. And you need to set those U and V steps values down before you click this parametric button. Otherwise, you will most certainly overload your computer. U and V steps values back down to 1 and choose the parametric method. And you can see even with values of 1, it's still a fairly dense mesh. I prefer the regular method. That's my favorite option here, so I will choose that and set these up to create a more consistent level of detail across the surface. This is only for the viewport, and the renderer is a completely separate consideration. If I want this to be what I get in the renderer, I need to go over and choose the renderer radio button, then pick my tessellation method and plug in the same numbers. And under that will correspond exactly to what I had here. You can see that I get a little bit of splitting here and some issues with the tessellation. It's pretty common. You'll see that quite a lot, and you'll need to do a lot of test renders to make sure that things look clean and you don't get these splits in between surfaces. Actually, a lot of times the high preset will be fine. In this case, that's actually the optimal setting. That's a quick introduction to NURBS modeling in 3ds Max. Spend a lot of time in this, and in fact, it's a very deep tool set, and it's got quite a lot of options. Modeling for motion graphics. And see, I've got this lovely text logo here, 3D text, that's got a nice beveled edge on it. After we'll look at creating text from scratch in 3ds Max, we'll also look at how to import artwork from Adobe Illustrator. I'll reset the program and all my units of measurement. I think that because it's only motion graphics that we really don't care about the size of objects. In other words, we're not making architecture here, and all we care about is screen space. However, in fact, because of the way the tools work in 3ds Max, it is important that we build things to the right scale. That way we'll have more accuracy, and it'll just be easier to work with. The thing I'll do is go into the unit setup, customize unit setup, and be working in US standard with my default units as inches. Next, go into the Grid Maps dialog by right-clicking on any of these magnet icons. Go to Home Grid. I'm going to set this up for imperial units. I'll say grid spacing to line every 12 inches, major grid line every 12 times 10 or 10 feet, and the perspective view grid extent that to 50. My unit setup. There's one other thing that I want to do before we begin, and that is with custom font for this. You don't have to use the custom font, but it is included. If you're a premium subscriber, you have access to the exercise files. I've got here on my desktop, exercise files, fonts, open up, and you'll see timepiece.ttf. I'll just select it and right-click and install. Set up our scene and ready to begin creating text in 3ds Max. Max is quite simple. What to do is go to the Create panel and the Shapes panel. And Splines category, you'll see text. Click on that. Just click in the front viewport to create the text with default parameters. When I created it, I'll right-click to exit the text tool. Now directly to the Modify panel and change up those parameters. Forgot the font, Arial by default. I'll click that, and I just want to scroll down and lower timepiece. This is set to about 5 feet. Enter, and then I'll type in text. I'll enter to start a new line. To the text. Also play around with the kerning and leading. Space between letters. The less space between lines, if I give it a negative leading, I can move those closer together. Notice, by the way, this is a cool feature of 3ds Max that when I click and drag on those spinners, they're infinite. You'll notice that my cursor is wrapping around from the bottom to the top of the screen. Useful. Oh, so I've got some text now. If I want to edit these individual letters, I don't have that ability here. I'll have to convert to editable spline in order to do that. I'll click anywhere in the viewport and convert to editable spline. Once I've done that, then I can select individual letters. Customize that front view with Alt-W. And I've got spline subobject mode. And I click on one of these and move it around to customize. Letters, of course, are built out of more than one spline. If I needed to move this P, for example, I'd need to select both of those splines and move them together. That's creation in 3ds Max, and as you see, it's quite simple. Here for the text, if we wish to render, it'll need to be made into a surface. One way to do that is to simply extrude it. I can select it and go to the Modify panel and Extrude modifier from the pull-down list. And give it some amount to the extrusion. I'll extrude that back by about 2 feet. See that this is not terribly interesting. Got a precise 90-degree angle here, and there's no bevel on the edge to catch the light. In graphics, it's really important that we have that. Extrude modifier is not really good enough. I'll go ahead and trash that by clicking on the trash can icon. The bevel modifier instead. Here, bevel. To do this, you'll see that it's perfectly flat. I'll reduce this level 1 height to a negative value to extrude it backwards into the scene. I'll give the value of, let's say, 24 inches or 2 feet. I have a bevel modifier. Now it looks just the same as if we had used the extrude modifier. In the next movie, we'll adjust the bevel parameters to make it more beautiful. With that, I'll go into the bevel values rollout here and adjust some of these numerical values. Most importantly, I've got the outline values. What outline does is it makes the original spline larger or smaller. And you'll see this if I adjust the start outline. Let's say I give that a negative value. And see, it's causing the outline to become larger or smaller. Now, be careful with this, of course, as you can see that if I, make this too large or too small, then we'll have issues with the text. It'll be a very small value in this case. Let's give it a value of -1 inch. That'd be cumulative with the outline values below it. I've got level 1 outline, and I increase that. And you see that we're able to get an interesting 3D effect there. Okay, well, what I want here, in fact, is a 45-degree angle here. To achieve that, I'll set the height to be equal to the start outline. Height to -1 inch. And the outline value here, at +1 inch. And values now, what I've got is a start outline that's 1 inch smaller than the original curve. And this level 1 extrusion is 1 inch larger than above it. These outline values are cumulative. The start outline of -1 plus a level 1 outline of +1, taking me back to an outline value of 0 here. I want to extrude this back further. I want to extrude this backward to give it some thickness. To do that, I'll need to enable level 2 and then reduce this height to a negative value of, let's say, 24 inches. I want that to be a consistent thickness throughout. Then this outline will be 0. I don't want this to have any non-zero value. Set back to 0. That'd be good. If I want to see a bevel on the back, I also need to enable level 3. And once again, I'll give it a height of -1 inch, outline of -1 inch, and got a bevel on the back. That's a quick introduction to creating an angled bevel. for a text object as it is. However, if I wanted to deform it, I need to pay special attention to its level of detail. Select it and press the F4 key so I can see the edged faces. I need to see those selection brackets right now, so I'll press the J key to hide those. As you see here, on the front faces here, there are no edges. And that means that if I tried to bend this or twist it or do anything to it, it would not deform very well, and I would have some pretty serious issues. I'd like to now enable an option so that I can see the full information about the level of detail. For each object, there are object properties. And one of the object properties is whether we want to see all the triangle edges or not. The ways to get to that object properties dialog would be to go to Edit, Object Properties. You could select the object and right-click a quad menu, just choose Object Properties. Now dialog open. The important parameter here is edges only. When enabled, the triangle edges of this polygon object will be hidden. If I disable that option and click OK, now I'm able to see all of the triangles. And you can see these are looking a bit strange. It wouldn't work very well if I tried to deform it with a bend or whatever. But I control the behavior of the tessellation of the bevel through this cap type option here in the modifier. If I choose grid, then I get a much more uniform structure to triangulation or tessellation. That helps a lot if we want to deform the object with enough polygon structure there that it can bend properly. However, it's only the caps. What about the rest here? I've also got the number of segments here, and I can increase that. See that that's increasing the number of polygons within each one of these levels in the bevel values section. So that's pretty good. However, you'll notice that in these straight areas here, I'm not really getting any detail there. I've got polygons for this entire surface here. What I want to do is increase the number of polygon edges in straight line areas. That is actually controlled through the spline interpolation parameters, not the bevel itself. I'll go back down the stack to the editable spline object, and I'll turn on Show End Results so that we can see what we're doing. This interpolation section is quite important. Let me open that up. It lets me control the level of detail of a spline object. You see that the default values are 6 with Optimize enabled. What Optimize does is, there's a straight line segment, this Max is going to discard any detail on the spline in that area. If disable Optimize, then what I'll get between 2 points on the original spline curve is the number of steps that I've determined here. And increase that, we get greater detail. And you think that that's a little bit heavy in terms of a model, but if I needed to bend this or deform it, this is the level of detail I would need. Finally, there's also an adaptive option. I don't recommend that in this case, because what that's going to do is attempt to add steps to spline where they're needed to maintain a smooth curvature. And when adaptive is on, Optimize is always enabled. I recommend the adaptive option in this case. I'll turn both Optimize and Adaptive off, and then the number of steps to 8. And that's a pretty good level of detail for the object. And next I'll just play around with deforming it in the next movie. Appropriate level of detail on this beveled text object, we can apply any parametric deformer to change its shape. For example, I'll select it and go to the Modify panel. In Modify List, I'll choose Ripple Deformer. Pretty interesting. And increase this amplitude. And you see we're getting this sort of watery ripple effect. So you can see that a little bit better off the edged faces with F4. It's not perfect. It's got a few little glitches here and there. It's pretty good. If I had not set the level of detail, then it would look pretty terrible. To illustrate that, I'll go back down to the bevel modifier. and I'll switch the cap type to morph, which is the default. And immediately things start to get kind of not a desirable outcome. And I'll change this ripple amplitude, I can make it worse. Important that you have a good level of detail to your text before you try to deform it in any way. Back to the bevel, set back to grid, and it's looking more or less the way that I need it to. That's an illustration of the importance of having a proper level of detail for deforming objects such as a beveled text. Most commonly, we'll need to take an Adobe Illustrator document and make it 3D and then animate it. I want to show you just quickly how that Illustrator document must be formatted in order to load it into 3ds Max. New document. There's a letter size template, that's fine. And text. Make that text larger. Let's say 72 points. To make it a little bit more interesting, I will put an ellipse around that text. Here to the rectangle tool, and I'll choose ellipse. That out. And I don't need a fill there, I just want a stroke. Go over here and on this button to give me a default fill and stroke, and I don't need a fill, so I can click the None button, and I've got a stroke there. 3ds Max can only recognize the paths in Illustrator document. It will not understand fills, and it will not understand text objects. Since you'll need to convert the text to paths. That text object, I go to the Type menu and choose Create Outlines. It's been converted from a text object into pure Bezier curves. Now I'm ready to save this. I'll go to File, Save As. For convenience sake, I'm going to place the document to the current 3ds Max import folder, because that's where 3ds Max is going to look when I import the AI file. Go into my current project import, and I'll give it a name. I'll call it My Logo. I need it as a .ai file. When I save, Illustrator will ask me what version of AI file I want. And very important because 3ds Max cannot understand anything later than a version 8 file. Go up to the version and choose Illustrator 8. And click OK, I'll get an additional warning that says, you lose some features. Fine, we don't care. The file has been saved out properly so that 3ds Max can open it. To bring into 3ds Max, I want the import function. I'll go to the Application menu and choose Import. And it took me directly to my current project, which is called Exercise Files, and Import folder, and the AI document. Select that and click dialog asking if I want to merge into the current scene or replace the current scene. Doesn't matter which I choose now because it's an empty scene. I'll click OK. And an additional dialog that asks whether I want to bring this in as a single object or multiple objects. It doesn't matter which in this case, so I'll just choose single object. Click OK. And now I've got the logo in 3ds Max, and it's placed on the XY plane, so it's sitting flat on the ground. You'll note it's very small. In fact, the Illustrator document has a size of 8.5 by 11 inches. And that's the size of the imported 3ds Max Bezier curves now. If I wanted to put a bevel modifier on this, I would need to make the object quite a lot larger. I'll to scale this up to make it much, much larger than it was. Ready to add a bevel. To simplify things, I'm just going to add an extrude modifier. We can see the effect really quickly. Extrude. Give it an amount. You can see that conveniently 3ds Max has recognized that I had nested curves. I have the text inside an ellipse, and that then has resulted in this thing reversed out text. Pretty cool. Of course, I would probably want to adjust the level of detail on this too because it's looking a little bit blocky. And when that would be done by going into the editable spline interpolation settings. On the show end result, turn off optimize, increase the number of steps until it looks smooth. It's perfect. You might get issues. So you might need to play around with these in order to get those problems. You can also go in and edit the spline directly. For example, like by spline and things like I can make adjustments to change the look of the logo. Concludes our chapter on 3D modeling for motion graphics. Of the material editor in 3ds Max. A material is a shader definition that do with the surface properties of a model. What color? Does it have a texture? Is it shiny? Does it have a pattern or image applied to it? The properties of a material. What we'll have by the end of this chapter, it's a simple material that's got some refractions here to this transparent logo. Here's a scene. Got a text object and a backdrop. I'll be opening up the material editor. I can do it in a couple different ways. Either clicking on this button on the main toolbar or by pressing the M key on the keyboard. The type of material editor is called the slate material editor. With materials, I can switch to the compact material editor by going up to this menu in the material editor and choosing Modes Compact Material Editor. And not the compact interface. And this will be simpler and easier to work with. The main area up here is devoted to so-called sample slots. A slot is a staging area where you can create, preview, and edit materials, whether or not they're assigned to objects in the scene. A slot is not necessarily applied to an object. There's a direct relationship between the two. I can have material that's present in the scene and not in a sample slot, or vice versa. All these sample slots here, and I'd like to show to you a few of these icons on the right-hand side of the compact material editor. For example, I can choose to display a background, or turn the backlighting on or off. I can choose a different object for the sample. There's a sphere, but I can also use a cylinder or a cube. Additionally, I can middle mouse click in the sample slot and rotate the object. I'll call it logo material. I'd like to put the word material in the name of the material. That way I'll be able to tell whether I'm working with a top-level material or a subordinate map. Up is a texture or a pattern that's applied onto some property or parameter of a material, such as its color. Just know that I'm working with a material, I'll put the word material in the name. In the main panel, you'll see there are lots of rollouts, such as shader basic parameters or maps. I can open and close these at will in order to see different aspects of the material. Before I start editing the material, I'd like to assign it an object. There are a couple ways to do that. One would be simply drag the sample slot onto an object, release the mouse. I assign that logo material onto that object. I could use a button to do that. Let's make another material here, and I'll call this one backdrop material. And I can select the backdrop object, viewport. With the backdrop material selected, click a button that says Assign Material to Selection. And material has been assigned to the backdrop. You'll notice that a material that is present in the scene will have little brackets around the sample slot. Open bracket indicates that the material exists in the scene, but the object is not selected. A bracket indicates that the material is present in the scene and the object is selected. Okay, let's play around with some basic material parameters, such as color. I'll go back to that logo material sample slot and change the color. I can go with this diffuse swatch here. I'll click on that. This color is the main color of a material. It's the color of an object where it's directly illuminated. See, as I adjust the controls in this color selector, the color updating in the viewport in real time. That's how you can check to see what materials are actually in the scene. It's possible that you might have filled up all of the sample slots. There are 24 sample slots available in the material editor. And after a while, these will all fill up. And you'll need to recycle these and reuse them. And you don't want to erase the work that you've done that's already in the scene. I'll say empty sample slot. Go over here and click on the button that says Get Material. With that, I get a new window launching called the Material Map Browser. It allows me to do quite a lot. In fact, I can create a new material by clicking on one of these. I can scroll down. At the bottom of that dialog, I'll see two sections. One that says Scene Materials and another that says Sample Slots. And in fact, there's another scroll bar here. I've actually got nested rollouts here. In other words, I've got a big window that I can scroll, and then within this rollout, I've got another scroll bar. Okay, so this is telling me that currently in my scene, I have two materials, a backdrop and a logo. If I were to load that scene material in, I could just double-click on one of these. In fact, I've loaded that material into a new sample slot. And notice now that this one that's currently hot, or the one that is currently in the scene. And over here, although it's called the same name, it's not in the scene. I can here and change that color to something else, and you can see that it didn't change the look of the object in the viewport. A helpful trick that you can use: have two materials of the same name. You can globally replace all of the materials of that name in your scene. For example, go over here and click on this version of logo material and click on the button that says Put Material to Scene. Now that's the one that's hot. I'm going to switch it back. I can go over here and I can click Put Material to Scene. Filled up all of the sample slots. Don't worry, because you can always reuse the sample slots. For example, I can click here at Get Material and back up to the top to create a new material in that sample slot. And these are the material types here. I'm just going to choose Standard. That's the one that you'll use most of the time. I'll click on that, and now I've wiped out that sample slot, and I've got a brand new material in there. See that I did not change the status of the scene material. If I run out of sample slots, I can just recycle them. That will not affect the scene materials. One more thing here, which is very convenient for selecting materials from the scene, and that's simply the eyedropper. Material from object. Select the eyedropper, then click on an object, and now that material has been loaded into the current sample slot. There's many different types of materials. So we've only seen the standard material, but there are others. I can load a new material into a sample slot and use a different material type, or I can convert an existing sample to a different material type. For example, if I select this backdrop material, you see there's a button here that says Standard, readout of the current material type. If I click on that, I'll get the Material Map Browser. And these are the different types of materials. Two that I use most often are Standard and Architectural. I'll double-click on Architectural. What that does is convert the existing material to a new material type. And now it's reading Architectural here. Architectural materials are simpler to use. It's a stripped-down interface that should save you some time. The way you would use an architectural material is you would go up to the templates here and choose one of these templates. You'll need to do that first. I can choose a stone template, and that'll just change all these attributes here, all these parameters, so that we'll get a stone look. Or I can switch it up to, say, masonry or glass. We need the glass here unless we turn on the background. And that's glass material. Back down to the templates and choose ceramic. And you see that that's got a little bit of a reflection on there with some glazed look. And I can adjust up these values here, like shininess and so on, to affect the look. I can switch back to a standard material But here again, we'll click on Standard. And you'll notice that when I do that, it wipes out a lot of the information, so I don't have any shininess here any longer. Next thing, let's look at the shader type. Material type in this case is standard. Within the standard material, I've got a lot of different shaders. These are shading algorithms. And these has a slightly different look, usually named after their inventors. For example, we've got Oren-Nayer blend, and that's useful for rough surface like terracotta. I can change the diffuse color so you can see there's a kind of finished ceramic look to it. Each one of these shader algorithms has a slightly different look and has different attributes or parameters to it. Most time you'll be using the blend shader type because that's the most general purpose. Properties of a material is its specular highlights. Specular highlights are the hot spots on a material, the shiny parts. I'll go ahead and select the logo material here, and it'll be easier to see the specular highlights if I go back to sphere as my sample object. Near the bottom of the blend basic parameters rollout, you'll see specular highlights. I can increase the specular level, and see I've got a nice big broad highlight there. If I increase the glossiness, it'll make that highlight smaller. Actually counterintuitive for a lot of people. As you polish a surface and make it more smooth, the highlight will actually become smaller. High glossiness will result in a very small highlight. A metal look to this, I might have a very high specular level. I might turn this up really high. It can actually go up to 999. Then a high glossiness as well. In the case of this motion graphic logo, I might want to cheat this a little bit and not have so high of a specular level. Maybe I'll bring that back down to somewhere around 100, then give it a little bit less glossiness. It'll give me some very strong highlights, which will look good when finally have lighting in this scene. Max viewports are quite accurate. They're not quite what you will see when you do a full rendering. Do a test here. I'll highlight the perspective view, the main toolbar, and on the extreme right-hand corner, I'll click the teapot that says Render Production. This is a full render. This is what I'll actually get when I output my animation. See, it's close, but it's not quite the same as the viewport. We get a better approximation of what the final renderer will look like in the viewport by using something called Active Shade. It's an interactive production renderer. In other words, I can make changes to the material and the viewport will render in real time and show us a very good approximation of what it will look like in final rendering. Activate Active Shade. Click the name of the viewport, in this case, Perspective. Then to Extended Viewports and choose Active Shade. Take a second to think about it. Now I've got a fairly accurate representation of what this will look like when it renders, and I can go back to my material or lighting and I can make changes and that'll update right away. Just a moment to think about it, in like a second or so. This is very useful because I don't have to keep clicking the render button every time. I can get a pretty good preview of what my final rendering will look like. The shade window will not update if I, for example, move objects in the scene. For example, if I go over here and get closer on this, move the logo over, Activate doesn't update. If I needed to update, I would have to reinitialize. I'll go here and right-click in the viewport and use Initialize. And now see, it's responded to the fact that I've moved the logo over. Let's move it back. Right-click and choose Initialize once again. Finished with the Active Shade window, I can simply right-click here and choose Close, and now I'm back to the standard viewport rendering. Under basic parameters in a material is its opacity. Go Material Active here, and we'll see opacity here. I can set down to, let's say, 50%. And now you see I can actually see through object. Active Shade rendering of that so we can get a little bit better understanding of what this is really going to look like. See, it's not a very convincing transparency. We're seeing the bending of light as it moves through the object. A transparent object actually bends light. That's called refraction. To get that effect, I can't do it by just adjusting the opacity. Down to 10, you see, it's just basically making it see-through in a kind of a 2D fashion. Okay, I'll let the opacity back up to 100%. I want refractions. I need to go into the Maps rollout down here. I'll open it up. In Maps rollout, you'll see a list of all of the material parameters that could potentially be mapped. In other words, that could be varied, modulated by some other factor, like, for example, an image. In this case, I'm concerned with the refraction channel. All the things that say none here are actually buttons. And if I click on the button that says none, I'll get Material Map Browser up again. What I'm looking for here is a map called Ray Trace. It's under Maps, Race, and I'll double click on that. It takes a moment to think about it, but now you can see that I'm getting related refraction in my viewport. There are some parameters here in the material editor. I don't really need to adjust any of those. In fact, it's doing everything sort of automatically. It's automatically applying a refraction here. However, if I try to get back to my main material parameters, you'll see that I can't see them here. And the reason is now we've drilled down inside a map, these map parameters. I need to get back up to the top level of the material. One way for me to do that is to click this button here that says Go to Parent. That'll take me up one level. Now back up at the material parameters. If I want the color to show through here, I can reduce the refraction amount. Let's say I knock that down to 50%. And now see I'm getting a tinted glass effect. If the refraction is not at 100%, then the diffuse color will blend. See, I've got a diffuse color orange here. The opacity is usually left at 100% when you're using a refraction map. The basic introduction to using the material editor in 3ds Max, and in the next chapter we'll look at using maps. This is an introduction to using maps within a material. So far we've only applied flat colors to diffuse channel. Now use a map to vary a color. I'll go to the backdrop material and I'll add something into this diffuse color slot. I can do that in a couple of ways. I can up the Maps rollout, see diffuse color here. Click on this big None button. However, I can also do that from up here because the identical button here, this shortcut. It's a little easier for me to get to. If on that, I get the Material Map Browser window open. These are possible maps that I could apply to the diffuse color channel. These, with the exception of bitmap, are so-called procedural maps. A map is a file on disk, like a TIFF file or a JPEG file. The rest of these are all generated internally by 3ds Max. For example, I could choose the cellular procedural map. Double-click on that. And now I've got a pattern here. Now, see it on the actual object yet, even though the material is assigned to the object. You see the map on the surface of the object in the viewport. I click this button here that says Show Shaded Material Viewport. And this here, I'm doing at the level of the cellular map. Now I've got a pattern in the viewport. Let's look at this in active shade so we can see it a little bit more precisely. I'll use perspective, extended ports, active. Take a little bit longer to think about it. But now see, I've got a pretty good representation here. That the scale of the dots is different. What the viewport renderer by default is necessarily an accurate representation. The actual renderer or the active shade renderer will show you what you're really going to get. Procedural map has different parameters. For this cellular map, I, for example, change the size. Maybe I'll make that a size of 10. And the active shade takes a moment to think about it, and now it updates. You have a lot of fun with procedural maps, and they're very useful because they're resolution independent. dependent upon a pixel-based image. And it means that you can zoom in very close to a procedural map and it won't break up into a mosaic of pixels. Let's try another procedural map. See up here the diffuse color has got a cellular map in it. Click on this button that says Cellular, Material Map Browser up again. Choose a different type of map. Noise. The one that you use most commonly. I'll double that. A dialog asking me, do I want to discard the old map, or do I want to put this new one as a sub-map inside the current map? Well, usually you don't want to make a sub-map. You don't want to have nested maps unless you specifically choose that. In this case, I'll choose Discard. Click OK. And the noise map is showing up on the backdrop instead of the cellular map. And play around with parameters such as size. Maybe I'll set this down to a value of maybe 15. There's lots of other fun things I can do, like I can change these thresholds to increase the contrast. Set the high threshold to 0.5, low threshold to 0.5. Now I've got a much more contrasty look. Play around with fractal noise and so on. Cool. I could add more complexity to this if I wanted to, because you can see that within the procedural map, I've got color swatches. In fact, each one of these color swatches has a map channel too. And could actually add another map inside this existing map, and that's what's meant by a submap. In this case, I'm just going to leave well enough alone. It's a really basic introduction to procedural maps in the material editor. In the editor, we only see the parameters for one shading node at a time. In other words, we can see the parameters for a map, but we can't see the material parameters at the same time. We go up one level out of this map and go up to the top level by clicking on Go to Parent here. And now back up at the material level. There's a way that I can do this, which is very useful, especially if you've got a complex network of shading nodes. That's a shader tree. Navigate through the shading network, clicking on a button over here, Map Navigator. Open that. You can see up here that backdrop material is highlighted, and indicates that we're currently viewing the parameters of the material node. Click here. Now you can view the parameters for that map. And that's a really convenient way of both visualizing the structure of your material and also navigating through the material and accessing its various parameters. Pretty useful in some cases because you can just quickly place a pattern onto a surface, and that pattern's resolution independent. You can get up really close to it and it won't break up into pixels. However, you can't use a procedural map to, for example, place a photograph on a surface. For that, you need a bitmap or image file. If you're working with image files, then you've got to make sure that the links between the scene and the image files are preserved. You follow this procedure in order to make sure that that will actually work. First of all, you'll need to go to the Customize menu, in the Preferences, use the Files tab, and make sure that the Convert Low File Paths to Relative is enabled. It means that when you create a link to a file, that link will be recorded relative to the current project folder, not be recorded relative to a volume name or a drive letter or a civic computer. This is important because a relative path means that you can take your project and move it to a different machine or to a different folder, and all the links that are internal to that project structure will be preserved. This is off by default. It's very important that it be enabled. And you have to actually have a project folder. At the beginning of the course, you can either create a new project folder or set to an existing one. We have the exercise files here. Then we just want to make sure that we're pointing at the exercise files folder. If premium subscriber, you've got the exercise files. If you're not a premium subscriber, then you've already made your own project folder. Up caption bar is a button that allows us to point to an existing project folder or make a new one. If I click on that, it will take me to the current project folder. Right now you'll see that exercise files is highlighted, and that's exactly what I want. I want to select anything inside there because if I do, I'll be creating a nested project folder inside the current one. I just make sure that that is currently selected. Okay, step 2. I've now got a project defined. Step 3 is I need to actually place the image files in the appropriate location within the project. Minimize 3ds Max for a moment and go out to the desktop. Exercise Files folder. We need to place our image files in a very specific location, and we need to do this before we build the material. And that location is Scene Assets, Images. And you'll see I've got some files in there now. Once you'll need to place the images into this special folder before you create the material. And there now. I'll go back to 3ds Max. I'll open up the material editor with the M key. A duplicate of this backdrop material. All I need to do that is just drag it onto another sample slot. And now another one with the same name, back material. I want to bitmap into the diffuse slot. And click on this button here and that will take me to the map parameters. This is a noise map, but instead I want a bitmap. Button that says noise, and you'll see bitmap here. Double click on that. Get a dialog box that lets me browse for a bitmap image. This, very importantly, has taken me to that precise location, my project, Scene Assets, Images. And my files need to already be here. If they're not here now, I need to stop what I'm doing, come out of this, and copy the files into the correct location. The worst thing you can do here at this point is start browsing to some other location on your hard drive or on the network. An almost guaranteed situation where you're going to have broken links to your textures. And no one wants that. You don't want to open up a scene and get an error message that says your texture files are not being found. Okay, click on this one, galactic2k.png, and then click Open. And now I've got that bitmap applied to the diffuse channel of material. And to assign it, I can drag and drop it because it's got the same name as the existing material. I can just click the button that says Put Material to Scene. Finally, I'll need to turn on Show Map in Viewport here, or Show Shaded Material in Viewport, and now it's refreshed. That's the all-important workflow for managing source images or texture maps. You have to follow this religiously, and if you misstep at any stage along that process, there's very high probability that you'll get broken links to your textures. Again, of course, that's not a desirable outcome. As you follow this procedure, then you will probably be fine. As shown in the last movie, then you shouldn't have any problems with missing files. However, if anything went wrong in that process, or if you didn't observe that process, then there's a very good chance that you're going to have problems. What I've done here is I've made a scene in which the links are intentionally broken, and I'll show you how you can fix the links. I'll go there and open the scene. It's called number 4, Tracking Scene Assets.max. Open it, I get a dialog that says Missing External Files. That Galactic2k PNG that we added in the last movie is not being found. Again, because I deliberately moved it out of its proper location to demonstrate the problem. In dialog, you've got 2 buttons at the bottom, Browse and Continue. The very worst thing you could do here would be to click Browse. Please do not click Browse, because what will happen if you do that is you will get another dialog that's called the Missing External Files dialog. In that dialog, you can use a path to your image files. But that's going to do, in fact, is to add a new entry into the user paths that would customize the current installation of 3ds Max. That's what you want. Again, that's the worst possible thing you could do. That's a Band-Aid short-term solution, and it won't change the recorded path to the file. It'll just tell 3ds Max to look in a new and different location other than the standard Scene Assets images where things are supposed to be. I know this is all very confusing. Sorry that there's so much, problem around this. There's not much we can do about it except to, observe those proper procedures from the beginning. If you run into this kind of trouble, you can then use the asset tracker to relocate the paths. In clicking Browse, I need to click Continue. Then I can go into another dialog here, called Asset Tracking dialog. Found under References, Asset Tracking. Click on that. What I see here is list of all the maps that this is referencing. And here it says Galactic 2K is supposed to be in Scene Assets Images, but the file is missing. Path is correct, but they're not there. Oh, I'm going to go ahead and place the file in there. Here, Galactic 2K. It's actually on my desktop. I'm going to go ahead and put it in here. To 3ds Max. And if I go back into that asset tracking, I just want to point out to you, References, Asset Tracking, that's still saying it's missing. In order for it to be found, I'm actually going to have to reset the program. You do here to Application menu, Reset, and reopen file. And being found, because the file is actually in that location. Another situation that might happen is if you've linked to a file that's not in the Scene Assets folder. Let me do that. I'll go back to the Material Editor, and I'll make another duplicate material of that backdrop. Go into the map here, the diffuse map, and point it to a different location. You'll see here it says bitmap on that. I'm going to do what I told you not to do before, which is I'm going to browse. I'm going to go into the desktop. I've got some files here. If I had linked to a file on my desktop instead of in that proper location, now you'll see here it's got a path that's got a couple of dots, and that means go up one level. All right, so I'll assign this. I'll replace material. You can see it showing up there, and that's fine. Now save this out. Tracking Scene Assets 2. I'll hit the program and move that file out of where Max thinks it is and into the correct location. It's in the correct location. I'll go back into 3ds Max, go back to opening that, and when I get the Missing External Files dialog, once again, I'll click Continue, not Browse. And I'll go back into References, Asset Tracking. And see here, we've got a path. It's a relative path, but it's taking us up one level from our current project folder. If the path does not say Scene Assets Images, then you can just type it in. Select that and go to Paths, Path, or just right-click, use Path. Type it in here. Assets, backslash. Also browse for it, but I know what that path needs to be. I'll just type it in directly. Click OK, and now it's been repathed, and so the file is there. It's now being found, and now it's finally applied onto that surface. Again, apologies that this is so complicated. As long as you follow the proper procedures from the beginning, then you won't need to worry about asset tracking in the first place. But it does happen to the best of us. We all make mistakes. Even experts have problems with file pathing in 3ds Max. If you have the issue, then all you need to do is make sure that you've placed all of your maps into Scene Assets Images, and then go into the Asset Tracking dialog and set the path appropriately.
To place surface, you can do it by adjusting the map parameters or by adding a modifier called UVW map. It depends upon whether you want the changes to affect all of the objects that have that map, or if you want the changes to be on a per object basis. If you want to affect all the objects that have that map applied, you would do it through the Material Editor. Open up Material Editor, select that material, and I'll drill down into its diffuse map in this case. And there are parameters here in the coordinates rollout, such as tiling. Set those tiling values to 4 and 4. That's causing the map to repeat 4 times across the surface, horizontally and vertically. I could use offset values here to place map, although that's not terribly intuitive. Okay, set these tiling values back to 1 and 1 in both U and V. Look at placing a map on a per object basis. I'll select my backdrop object and go to the Modify panel. I'd like to point out to you that there's a switch down here that's labeled Generate Mapping Coordinates, and on by default. When you create a primitive in 3ds Max, default UV coordinates will be created and assigned to that object. Essentially, it has implicit UVs. If you want to place the map somewhere else on that surface, then you'll need to add a modifier called UVW map. I'll go to the modifier list and scroll down looking for UVW map. You'll see that there are a bunch of other variations on it. You just want the basic UVW map modifier. The thing to pay attention to is the mapping type. We've got planar map, cylindrical, spherical, and so on. Depend upon what type of object you have. Obviously, if you've got a cylinder, then cylindrical mapping would be appropriate. In this case, of course, it's a flat plane, and so planar mapping is appropriate. A bit further, you'll see that there are length and width attributes. These parameters here are the absolute size of the tile in world units. So set this to 40 feet and 40 feet. Then that map is tiling to be exactly 40 feet wide and 40 feet tall. To position the map, you'll open up the sub-object modes in the modifier. You'll see Gizmo. Click Gizmo, and then use the Move tool to position the map. You'll notice that if I move the gizmo in the world y-axis in this case, that doesn't actually affect the mapping. The distance here does change the mapping placement. And the reason for that is that you can imagine that this plane is projecting pixels onto this surface, and it's doing that in an orthogonal fashion or orthographic fashion. Let me go to my 4 viewports for just a moment and back out in the top view. It's projecting pixels perpendicular to the gizmo here. So moving the gizmo forward and back is not going to affect the pixel. It's not going to affect how that texture pixel or texel is being placed on the surface. In this case, it's only the X and Z axes that are relevant. You can also rotate the gizmo. Intuitive. I do recommend that you scale the gizmo, however, because if you scale it, then these numbers are no longer valid. If I scaled this up, it was larger than 40 feet, but the readout here still says 40 feet, so that's a bit confusing. So I don't recommend scaling the gizmo. I'll undo that. A little bit further, you'll see that there are a couple more useful options, such as the alignment, align X, or Y, or Z. 3ds Max usually gets this right the first time. Sort of detects how your object is oriented and chooses an alignment to fit the object. So a couple other really useful buttons down here, such as this Fit button, and if you click that, then it will stretch the gizmo to the available area of the object. There's a bitmap fit, which is kind of useful because if you've got a non-square bitmap, you click on this and navigate to your bitmap, and it would automatically change the gizmo's aspect ratio to match your bitmap. This was just a very quick introduction to the UVW map modifier in 3ds Max. Of course, map placement can be a much more involved process. Here, we're just barely scratching the surface to show you how to position and scale a map on an individual object.
Very useful feature for scaling the UVW map, and called real-world map size. You'll find it down in the parameters of the UVW map modifier. You can tick that on. Well, that's only half of it. Once I've turned that on, I also need to turn on the corresponding switch in the material editor. Open up that material editor, go to the material, and need to go to the map, and it is currently shown here. And in the coordinates rollout for that map, I'll enable real-world scale, and then it's some size. Let's say 20 feet by feet. Once I've done that now, each one of these tiles is exactly 20 feet. Don't be distracted by the fact that this is reading out as 19 feet and 12 inches. That's just a little bit of a quirk of the program. This is a very, very useful technique because especially for architectural scenes, it might be useful for me to have a sample that's, a piece of masonry that's maybe 3 feet on a side or something like that. And if I enable real-world scale here and real-world map size here, then I just type in the value. Really close on this, by the way, you'll notice that the gizmo is tiny. This is the only real issue with this, is that gizmo is itty-bitty. Where is it? There it is. It's a byproduct of the process. It doesn't show the gizmo at 20 feet by 20 feet. It's at a tiny size of an inch, you can see here. There's a lot I can do about that. I don't want to scale the gizmo for the reasons I mentioned in the last movie. Just leave it as it is. If you need to move it around, you'll just have to get in really close on that. So that gizmo. And position is needed. Very helpful feature. Real-world map size. We want it to be sparkly and reflective. Currently, it's still refracting. It's a transparent logo. If I do a quick review of that, you can see we've got refractions. I'm going to choose reflections. That window. And the material editor. And logo material. Down into the maps rollout, and you'll see I've got a ray trace map in the refraction channel. Get rid of that. The way to get rid of a map is take one of these other buttons that say none and just drag and drop it onto that map. And release the mouse. Now that one has nothing in it as well. Okay, now for the reflection channel, I want to add a ray trace map there. I'll click on the button that says none, and Material Map Browser opens. Double-click on Ray Trace to add the ray trace map. Tracing is a global illumination technique that automatically calculates reflections or refractions. You don't need to do anything in the ray tracer parameters, it's all fine as is. I'll back up to the top level here and do an active shade rendering so we can get a preview. Perspective label and choose Extended Viewports, Active Shade. See that the reflections are looking kind of hot. It's a bit too bright. I can reduce the reflection amount here. Set down to, let's say, 50%. I want a gold look here. I'm going to play around with some of these colors. Maybe I'll go into this diffuse color and set this down. Maybe set the saturation to 25, fully saturated. And value I'll set down to, let's say, 190. The specular highlights, that will affect this as well. I'll set the specular level to about 100. And harshness to, let's say, about 50 or so. And you can see this is looking a little bit better. See, in my active shade, it's still not quite convincing. Uniformly reflective across all surfaces. And it would look better if we could have it be a little bit dimmer in certain areas. We can use reflection dimming to achieve that. Close the active shade window, right-click and use close, and just get in closer here so we can see it better. And I'll turn active shade back on again. What I want to achieve here is that in these curved areas here where there's not as much light, we want the reflection to be dimmer there. Do that in the material by going to the Extended Parameters rollout. I'll open it up. And within here, we've got reflection dimming. As soon as I do that, we get some effect here, and you can see it in the sample slot as well. It'll be more dramatic if I turn the backlight off. With reflection dim level here of 0, there's no direct illumination. The reflection is going to be completely black. What I want some amount of reflection there. Dim level is really the black level. Set that to, let's say, 0.4. The reflection level here is the white level. And the value of 3 is usually a bit too high, especially when I've got specular highlights as well. I'll set the reflection level down to, let's say, 1.5. And finally, maybe I'll turn the reflection amount up a little bit to, let's say, 75%. And you can see it's looking considerably better than we had a moment ago. Close that, do another rendering. Out a little bit. And I'll render. And pretty good, especially around the sides here where it's actually reflecting this background. You'll notice that there's no reflection on the front here. On the surface of our logo, it's not showing any pattern or any image. The reason for that is that there's nothing there for it to reflect. If I get my scene, thing out here, it's blackness. Nothing for it to reflect. We create some sort of fake environment for it to reflect. And we'll do that in the next movie by creating a sky dome around the scene. To create reflection on the text object, I want to create an environment. Now I could do this through the environment and effects dialog in 3ds Max, and that would create reflections and it would actually show up as a background too in my rendering. However, I don't have any ability to intuitively adjust the placement of the texture using that method. Instead, I would advise that you create a illuminated material and apply that to a primitive, such as a sphere. Meaning they use boxes usually. It's called skybox. In this case, I'm going to use a sphere. That's more convenient for me. Go ahead and go to the Create panel and create a sphere. Dial back in my top view and drag the sphere out, make that nice and big, and right-click. I'll go to Modify panel. I'll set that radius for the sphere to, let's say, 400 feet. And just position it at the center of the world with the Move tool, giving X, Y, and Z values of 0. Dolly back in the perspective view, you'll see that when I'm outside the sphere, I can't see my logo. I'll click here. That'll make it so that you can always see the interior of the sphere, even if you're outside it. Two-part process. First, I want to select the sphere and right-click, go to its object properties, and turn on the switch that says Backface Cull. That means that if the surface is pointed away from the camera, it will not be rendered. Back cull on. Now, if I'm inside the sphere, I cannot see it. Dolly back and go outside it, then I can see it. The second part of this is I just want to invert the surface of the sphere, or flip its surface normals. Very easy to do that. I'll just select the sphere, go to the Modify panel, and from the modifier list, I'll choose a modifier called Normal. And Normals is turned on by default. This is really useful because I can be inside or outside the sphere, and I'll always see the interior. Okay. Now I want to create a self-illuminated material and apply it. I'll go to the Material Editor. I'll grab a new blank sample slot. And call this one Sky Dome Material. I'll add a diffuse map, color, and click on the button here. Opens up Material Map Browser, and double-click on Bitmap. Use this sky image. Open. Now I've got the image applied to the diffuse channel. I'll go ahead and drag and drop that material on sphere, and enable Show Material in Viewport. I didn't see it. Okay, we can play around a little bit with the tiling here and maybe make this look a little bit better. The U and V tiling values over here to 2, and press Tab and 2. And change the offset as well. This V offset to 0.25, it'll move up by 25%. And now we see that it's pretty well onto this sphere, except now I'm getting this seam here. Well, I'll mitigate that by enabling mirroring for the axis. So I'll just turn on mirror. That looks pretty good. Finally, I need to make this fully self-illuminated. No matter what the lighting is in the scene, this will be completely 100% brightness. The pixel brightness on the rendered image will be the same as the pixel brightness of the original source map. Go up to the top level of my material and see self-illumination here. I'll just turn that up to 100%. And now that is fully bright. So I'll go back into the scene and get in close on my logo and do a quick render of that. And you can see now that we're getting nice strong reflections on the front surface of the logo. And create a self-illuminated environment. We'll interest to our material by using a bump map. A bump map is a way of deviating the surface of the model. Now it's actually changing the shape of the model. It's just changing the way that the lighting and rendering works. I'll go to my current material here. Here's the logo material. And I've got my maps roll out, and you'll see there's a bump channel here. I'll click on the button that says None. Could add a procedural map here or a bitmap. Let's do a procedural map. Do a simple noise map. Double click on that. And to see this most effectively, let's do an active shade rendering. Go into the perspective view, click on perspective, extended viewports, active shade. You can see that the cloud pattern on the reflections is starting to deviate. It's getting a little bit swirled there. If I change the noise parameters, we'll see this more dramatically. I'll set the noise size down to only 5. Press enter. And now you see very clearly that we're getting a bump effect on the surface of our logo. It's not affecting the profile. It's not affecting the actual model in any way. It's just affecting the material. Play around with this. I could do fractal and, getting a nice rough effect there. But that might be too strong. And in fact, the default bump amount is usually too much. I'll back up to the top level of my material. I'll just reduce the bump amount to 10 and 30. And now it's not quite as extreme, and it's a little bit more believable. Technique that'll allow you to visualize a map independently of the material to which it is applied. All I need is an empty sample slot to do it. I've got logo material active, and I'll just go down here and click on this bump map button and drag it up to that empty sample slot. When I release the mouse button, I get a pop-up dialog asking, do you want an instance or a copy? And we saw earlier in the course, an instance is when something is in more than one place at a time. And that's exactly what I want here. That way, I can make changes to the map in this slot, and it will also affect the material. Here's what I want. Click OK. Now I'm seeing a 2D representation of a noise map. If something like this, that means you're working on a map and not a material. In fact, you cannot assign a map directly to a model. You can assign materials to models. So I can't actually drag this onto anything and expect that to work. However, I can select it and go in these parameters and adjust them. I'll set the size back up to 25 and press enter, and you'll see that that is reflected in the material instantly. This is helpful because you can break down a complex material into multiple sample slots and work on them independently without having to navigate back and forth, up and down through the shader tree. This has been a basic introduction to mapping in Material Editor. We've only scratched the surface here, and there's quite a lot to be learned. This Max interface is pretty intuitive, and so you'll have a lot of fun in building materials and applying them to objects in your own scenes. Camera is an essential part of any production. I have a very simple scene here, but nevertheless, it's an idea for me to put things onto layers so that I can hide things or freeze them to make them untouchable. For example, I might want to animate the logo, but not move the backdrop objects. Let's look at display layers. Open up the Manage Layers dialog either by going to the Tools menu and choosing Manage Layers, or go over to the main toolbar and click on the button Manage Layers. Now, a window here, and I have one layer currently, the default layer, and it's currently active, as indicated by this little checkbox here. What I do is to create a new layer for the backdrop objects. What is I'll highlight these two, the sphere and the plane, and they're not actually selected in the viewport. They're just highlighted in this panel here, in this window. I need to select them, clicking this button. Highlighted objects and layers. Now actually selected. Then click this button here that says Create New Layer Containing Selected Objects. And do that, a new layer is built, and the two objects are placed within it. Rename it. I'll call this one Backdrop Layer. When a layer is built, it's made active by default. This is the current layer. I can hide everything on that layer by just clicking the Hide column here. I can also freeze everything on that layer. It's frozen. By default, it'll be displayed in gray. Turn it back off again. If I need to move things from one layer to another, I can do that through a sort of cumbersome process. I can't just drag and drop from one layer to another and really effectively cut and paste because I can only cut and paste one object at a time. Obviously, for a heavy scene with thousands of objects, that's really not practical. What I'll need to do if I want to move objects from one layer to another is highlight them in the window here layer and then select them. Then I'll highlight the name of the destination layer and press this plus sign. Add selected objects to highlighted layer. Moved into the other layer. Let's move those back. The target layer name and the plus sign. Move back. About hiding, if I hide a layer, then the objects won't be displayed. There's a thing about 3ds Max here that can kind of trip you up, which is that the active layer, or the one that has a checkbox, is the one in which new objects will be placed. If I create a new object now, then it'll be placed into this backdrop layer. But the layer is hidden. If I go and create a primitive like a sphere here, they won't see it because it's being placed into a hidden layer. And if I unhide that layer, now I can see the sphere. The solution to this is immediately after you make a new layer, then you want to click on the default layer and make that one active. And that way, new objects will not be hidden. Delete that. Now talk about freezing. Freeze a layer. It's untouchable. I select it and therefore I can't move it. That's very helpful, especially for these backdrop objects. However, by default, frozen objects and frozen layers are displayed in gray, and I can see the texture on the object. I'll unfreeze it. What I'll do is I'll change an option so that frozen objects will not be displayed in gray. Set that on a per object or a per layer basis. I set it on a per layer basis in this case. I'll click on the layer and choose Layer Properties. On the left-hand side of this dialog, you'll see Display Properties. And there's an option here that says Show Frozen in Gray. Turn that off. And when I click OK, I would expect that if I freeze this layer, then I would still see the texture on my backdrop. It's not the case because the default installation of 3ds Max gives priority to object properties. Using 3ds Max Design, or if you've chosen one of the design templates in the Customize UI and Defaults switcher, then you will get their properties taking priority. But again, the default 3ds Max install gives priority to object properties. But which is that? I want to select these two objects and actually fully select them, and then right-click anywhere and go to Object Properties. And for each one of these sections here, you'll see a button here that says By Object. Then is displaying the current state. In other words, it's telling me that the display properties are giving objects priority. Click on that button. Then for the currently selected objects, their priority will be by layer. With having been done, now if I click Freeze, the objects are still displayed in their normal color and their normal texture, but they're now untouchable and I can't actually mess up my scene accidentally. If you change this behavior, give priority to layer properties, you can do that from the Customize Preferences dialog. And go to the Layer Defaults and found in the General tab. Defaults. Default to by layer for new nodes. That is an object. That switches on, then all new objects will have their display properties priority set to by layer. And I won't need to go in there and change each one of those each time. That's a real brief introduction to managing layers in 3ds Max. It's important that you place objects of the same type onto display layers so that you can hide or freeze them all at once. Create a camera. I have perspective view here, and I actually could render the perspective view, but that's not a good practice. You really do need to have an actual camera in the scene. Think camera as being the camera on a live action set. And think of the perspective view as the point of view of the director on set. The director is not looking through the camera lens. The camera operator is looking through the lens. And the director is standing off to the side, directing the talent, and can see the entire set and the camera itself. I don't use the perspective view to render. Create an actual camera. I'll go Create Panel, and go to the section labeled Cameras. There are two types of camera, target and free. I'll go free camera this time. Click button. I'll click in the front viewport to create my camera. That's because when I create a free camera, it'll be pointing into the current viewport. I'll click in front. Now let me back out a little bit in the perspective view and see that that camera is correctly oriented. If I clicked in the top view, then the camera would be pointed down. Out a little bit so you can see that. Here's my second camera that I made. I don't want to click in the top view. Usually use the front view. So click to exit camera creation and then just delete that second one. I will load the camera into a viewport. And I'll do that just by sacrificing one of the existing views here. Probably want to keep the left view, but I need the front view anymore. I'll load the camera into that front viewport. I'll go up here to front viewport, click on that front label, and then choose Cameras, Camera 1. Not a free camera. I'm looking through that camera lens, and the next movie will use the viewport controls to frame the shot. You have two ways of doing it. You can do it in a third-person point of view or in a first-person point of view. To adjust the camera in a third-person method, all you have to do is select the camera in a non-camera viewport and then move and rotate it. Select this and pull it back, and you can see that my camera view is updating. Maybe I'll go over to left view and the camera up. I can rotate the camera as well. I can down. And I can rotate it. I can click in the top view and pan. Third-person method. I also do it in a first-person method by highlighting the camera viewport and then down to the viewport controls in the lower right-hand corner. And slightly different than you would see in a perspective view. For example, I've now got a dolly button here, and I can click on that and drag in the viewport to move forward and back. We've got a hand button here. Allows me to truck the camera left and right and pedestal up and down. And finally, we've also got an orbit camera button here. And when I do this in a free camera, it's not really panning. And we see this here if we get in a little bit closer. It's actually really panning. You can see that that camera is swiveling and orbiting around. What I like is for the camera to stay in one place. If I back down here and I click and hold this button, I fly out. And there's a really important button hidden underneath there, and that's Pan Camera. This is probably the most important button that's hidden inside of 3ds Max. And now you can see in the top viewport that the camera is panning and tilting, but it's not changing position. Very, very helpful. In-person camera viewport, your hotkeys are limited. You really only got the ability to use the middle mouse button to track left, right, and pedestal up and down. Otherwise, if you want to dolly forward, back, or to pan, they want to use the viewport controls in the lower right-hand corner. It offers a target camera, which camera that's always constrained to look at a target or its aim point. I've got a camera in here now. I'll just go ahead and select that and press the delete key. And I'll back out in the top viewport to create my target camera. I recommend that you always create the target camera in the top view. If you create it in a different view, it might be pointing down or in some other weird direction. I'll create panel, canvas, and click target. Click and hold the mouse button down to create the target and the camera. The time I click, I'm creating the position of the camera. I'll drag out, and when I release the mouse, I'm setting the position of the target. When I'm finished, I'll right-click to exit that tool. Use the Move tool to select either the target or the camera and to change its position. To see what I'm doing, I want to load the camera into a viewport. I'll go over here to the perspective view and click on that perspective label, choose Cameras, Camera 01. So now, as you see, if I move the target, the camera's panning. If I move the camera, then it's orbiting around its target. Very similarly to a free camera. And to change its framing, then you would want to use the viewport controls in the lower right-hand corner. For example, the dolly tool. But there's an important difference from a free camera. If I dolly forward and back, the camera is going to move, but the target isn't. An implication of that is that when the camera moves forward enough, it'll actually flip around backwards because the target is not moving. We change that behavior. All to do is go down to the viewport controls and click on the dolly button and hold it down. I see a flyout. What you want is the one that has a red arrow and a red cross. And one is dolly, camera, and target. And now dolly forward and back, you will see that it won't flip around. That's a basic introduction to using a target camera in 3ds Max. One properties of a camera is its field of view. It's known as angle of view or focal length or simply zoom. We control the zoom on a 3ds Max camera in a couple of different ways. One would be through the Modify panel. If I select the camera, go to the Modify panel, you'll see an FOV parameter, and simply zooming in and out. And if I have a wide angle, I'll see a high number to field of view. Then I've got 141 degrees currently. If I have a low number, then that means I'm going to be zoomed in really tight. Also see that if the camera is selected, there's a handy pyramid structure here that shows what's within the camera's field of view. That's very useful. It's typically called a frustum. In 3ds Max here, it's called the cone. And I want to see that cone even if the camera is not selected. I can enable this switch here that says Show Cone. Now, if the camera is not selected, I can still see its frustum or cone. I can also adjust the field of view interactively in a first-person viewport. Click on the camera view, then down in the camera viewport controls, I click on Field of View, and zoom in or out. Basic and very important, you'll need to set field of view for each shot in your movie. Max makes it quite easy for you to do so. Consideration of the camera is its aspect ratio. It is the proportion of the width to the height. For example, HDTV has an aspect of 16 by 9. Higher definition television has an aspect of 4:3. We know what the aspect ratio is going to be in order to properly compose a shot. And if we're not careful, we may end up with problems like things that weren't supposed to be in the shot or in the shot or were not supposed to be there and they are. Let me show you an example of what could happen. Resize this camera view so that I've got a different aspect ratio. This is a more or less square aspect. I'm going to use the middle mouse button just to reposition the camera so that my logo is near the top of the frame. And then I'll do a quick test render by selecting that camera view and clicking the Render Production button up here on the extreme far right-hand side of the toolbar. And as I do that, you'll see that there's something quite different here. This word of my logo is being completely cropped off here, as I'm able to see it in the viewport. The problem here is that the aspect ratio of the renderer and the aspect ratio of the viewport are two different things. What I do is I need to enable an option in camera viewport called Show Safe Frames. I need to crop that viewport to the aspect ratio of the renderer so that I'll have a what you see is what you get situation. To turn on safe frames, one way that you can enable safe frames is with a hotkey, which is just Shift F. You can see that it's cropping the top and bottoms of the viewport to correspond to the renderer aspect ratio. I'll enable safe frames by clicking on the viewport label, in this case camera 01, and I can toggle it on and off from here. That's important. That's the only way I'll be able to know what's in the frame and what's not in the frame. You always need to have safe frames enabled for a camera. There's never a case when it's okay to not enable it. It must always be enabled. Otherwise, you'll have no idea what you're going to get when you render. So really critical. If you change the aspect ratio of the camera, it's actually not a property of the camera itself, it's a property of the renderer. I'll go into the Render Settings dialog. Render Setup, a little teapot that has a dialog next to it. This dialog, I choose the size that I want to render to. See here, output size. And the default is 640 by 480 with square pixels. We have square pixels, that means that the image aspect is going to be divided by the height. Here, 640 divided by 480 is 1.333. Just to demonstrate how I can change the aspect ratio, I'll use one of the other output size presets, such as an HDTV preset, 1920 by 1080, or let's say 1280 by 720. You reset the viewport panels here. I'll right-click in the center here and choose Reset. And you hear now that getting a good screen aspect and viewports being cropped, tops and bottoms, to show me the framing in the renderer. I can compose my shot, and what I see is what I get in the viewport. Ollie back a little bit and do test rendering. That's how we can set the aspect ratio and turn on save frames in order to make sure that we get what we want in the final rendering. Introduction to basic CG lighting. And we will be using the flying logo scene, but first I'd like to take a few moments to talk about the basics of CG lighting, how it's different from the real world, and this primitive scene will be a better illustration of that. We can begin to put lights into the scene. I need to take a moment to talk about just the interface and how to change the display modes in the viewports. You see the default display mode is realistic. That means that it's going to use a default lighting, a shoulder light, attached to the current perspective camera, and that shadows will be enabled, and something called ambient occlusion is also enabled. Ambient occlusion is another word for contact shadows. If I use the middle mouse and position my perspective view a little bit, you'll see that graininess, and it will sort of refine. That's the ambient occlusion, and it's turned on by default. Ironically, when you render a scene like this, there's no ambient occlusion in the rendering. Therefore, it seems a little bit strange that we will have ambient occlusion in the viewport, but it is enabled by default. Let's go look at the options here. If I click here where it says realistic or wherever it lists the shading mode, I have realistic and shaded and so on. And then under lighting and shadows, I can play around with these different options. First of all, the default behavior is to illuminate with default lights, and that's an over-the-shoulder light. If it's on, then if I create actual lights in the viewport, we'll not see any illumination. It's very important that the first thing we must do is turn on the switch that says illuminate with scene lights. We don't see any change here now, but it's important that we do that. And if we create a light and that switch is set to illuminate with default lights, then we won't see any true lighting in the viewport. That's just a bit of a strange default. I'll go back into the shading modes and also, once again, go back to lighting and shadows, and it's going to disable ambient occlusion. That'll improve the performance, and once again, ambient occlusion doesn't show up in an actual rendering. If it's on in the viewport, that might give me a kind of inaccurate idea of what I'm going to get in the final render. Another thing I want to mention is that if you go into standard shaded mode, realistic option, and if you back into lighting and shadows, all of that stuff is grayed out. In this standard shaded mode, we can't change any of these options. This is a very strange quirk in the interface. All I have to do here in order to adjust these options is I have to go back to realistic and then go into these options and change it up to whatever I want. Then finally switch it over to the behavior of the program as of 2013. What I want is realistic without ambient occlusion. So now we set up the interface and talk about the difference between CG lighting and real-world lighting. To illustrate this, I'll go to the Create panel, and I'll create an omnidirectional light. You got the Lights panel selected, And with that panel, I've got a pull-down list that currently reads photometric. Well, of course, we're going to be using standard lights. Standard lighting is essentially cartoon lighting. It doesn't have any relationship to measurements of illumination in the real world. If you learn about photometric lighting, another course for that, Max Lighting and Rendering with Mental Ray. In this course, we'll be looking at the standard lights. We're going to create an omni light. That's just like a point light or a light bulb that shines equally in all directions. I'll click the Omni button and click in the viewport, and light is created. And if I did not change my display options to illuminate with scene lights, then I would not see any change at this point. If I was using the default lights, then nothing would change on the screen. I'll click to exit Omni Light creation. Let's take a look at this. I'll orbit around, and you'll see something kind of unusual here, which is that everything seems black and dark. That is that the light has an elevation of 0. Its position is exactly at a Z value of 0. I'll need to move it up in order to see light in my scene. The thing that's kind of counterintuitive about CG lighting is that as you move a light closer to a surface, paradoxically, that surface will become darker. And that is the opposite of what you would expect. You'd expect that as you move the light closer, things get brighter. But in CG lighting, it doesn't work that way because the lighting model is very simple. What really matters in a standard CG lighting scenario is the surface pointed towards the light or not? Well, with this sphere, you see that this side of the sphere is illuminated, and that's simply because it's facing towards the light. The other side of the sphere is not illuminated because its faces are pointed away from the light. Standard CG lighting model is only based upon face angle. Polygon faces or surface is pointed towards the light, it will receive illumination, and that's it. The implication of that is that as a light moves farther away from a planar surface, such as my ground plane here, more and more of that surface will be pointed towards the light. If I move the light back down again, less and less of that surface will be pointed towards the light. This area here is really pointed towards it. This area, the angle is far too shallow to receive any illumination. So one of the first things that's going to be a little bit different from what you're used to from lighting in the real world. The next thing that's kind of different from the real world, as you will see, is shadows don't come for free in CG lighting. I don't see any cast shadows on the surface of the ground plane. In CG, shadows actually have to be calculated. And in fact, they're disabled by default. You can turn shadows on a per light basis. Finally, the other thing that's quite different from the real world is that by default, you won't have any decay in intensity over distance. To that, I'm going to move this light down close to this sphere here. And look at this. I've got two spheres, one here and one here, and equally bright. That they're equally bright is because their faces are pointed towards the light. And there is no decay in intensity over distance by default in CG lighting. In the real world, for a radiant light source such as this point light, the intensity will decay with the inverse of the square of the distance. That's called the inverse square law. It can be enabled in CG, but it's turned off by default for performance reasons. The differences between CG lighting and lighting in the real world. You've been working in photography or cinematography to light real scenes, you're going to have to sort of relearn some of what you already know in order to leverage your knowledge in CG environment. Logo scene with a camera and backdrop already in place. In my camera view, we're looking at a wireframe view. If I up here and choose realistic, then you'll see that my scene goes almost completely black. What's happening is because despite the fact that I have no lights in the scene, the sphere from my sky dome is in fact casting a shadow onto everything else. That's default behavior of the viewports. Even if there are no lights, we'll still get shadows. I could disable shadows from the viewport menu, but I'm going to need shadows later. What I'll do is I'll disable shadow casting from the backdrop object. The object, this sky dome, is currently on a frozen layer. I want to go into the Manage Layers window and select this sphere and right-click and go into its object properties. In the rendering controls section, simply want to turn off these two switches that say Receive Shadows and Cast Shadows. And click OK now. You'll see I am getting shadows projected onto this backdrop object. I'm not getting shadows cast from the sky dome. Light. In the language of cinematography and photography, the key light is the dominant source of illumination. The one's the brightest, and then it's casting shadows. Usually, in a studio lighting setup such as this, you would use a spotlight as your key light. If it were an outdoor shot, then you would probably use a directional light. The difference between the two is a spotlight has a pattern of distribution that's in a cone shape. Rays of light will move outward from the light source in a cone pattern. Where directional light has parallel rays. That would be more appropriate for an outdoor shot. I'm going to go to my Create panel, choose the standard lights, and two flavors of spotlight, target spot and free spot. Typically like the difference between a target camera and a free camera. The target camera or target spot has an aim point. That's usually used because it's easier to work with. Click on Target Spot. Top view, I'll click to define the location of the light, hold down the mouse and drag, and I find the location I want for the target. I'll release the mouse and click to create the target spot creation. I won't see anything in the shaded views unless I turn on scene lights. It might be difficult to select the viewport menus. You need to sort of click on here until you get the label visible. And I'm in realistic mode. I want to go down into lighting and shadows and turn on illuminate with scene lights. And I want to go back down into lighting and shadows and disable ambient occlusion just for performance reasons. But I want shadows to remain on. Now I've got a pretty good approximation of what this lighting will look like. If I go to my top view or any other view and use the Move tool, I can position the light or its target in order to change the lighting. Sometimes it might be difficult for you to select the target or the light, accidentally select a piece of geometry. Up here on the main toolbar is a selection mask or selection filter. And click on that, you can choose to select only lights or cameras or different object types. Lights. And I can't accidentally select a camera or anything else other than lights and light targets. So I'll go into my perspective view and maybe move that up a little bit. And that the spotlight has a conical shape, shaped like a cone, and that outside of that cone, there's no illumination. Now, spotlight in the shot, and I can go and change the spotlight parameters to whatever look I'm trying to achieve. The brightness and color of a spotlight. I'll select the light and open up the Modify panel. And there's a rollout here that's labeled Intensity Color Attenuation. And I'll open that rollout. Important attributes of the light are its multiplier, which is its intensity, and the swatch here. And if I change the multiplier value, let's say I knock it down to 0.5, well, in this case, a dimmer illumination, or set it to a value of 2, it'll actually be so bright that it's kind of distorting the color here. It's back down to a value of 1. For lights, the intensity here is an arbitrary value, not connected to any type of metric such as the number of lumens put out by a light bulb. If you need photometrics, then you'll need to create a photometric light. And that's covered in the title, 3ds Max Lighting and Rendering with Mental Ray. So a color swatch here, and I can click that and adjust the color. I can create a red light or an green light. I'm going to use a slightly orange light here. Let's do something like that, and it'll give a warm color to the illumination. There we go. We've just adjusted the basic parameters of intensity and color for the spotlight. The other standard lights work exactly the same way. One of my features of 3ds Max lighting is the ability to adjust the contrast of the light and the look of the highlights on object surfaces. I've reverted back to this simple primitive scene because that's a better illustration than the flying logo. To see this in the viewports, we'll need to use Active Shade. To the Perspective Viewport label, click on that and choose Extended Viewports, Active Shade. You see what it looks like with no adjustments to the contrast. This OmniLight, go to the Modify panel, open up the rollout that says Advanced Effects. If I increase this contrast value up to the maximum of 100, you'll see a very dramatic change. We're blasting out the scene. It's extremely contrasty, so contrasty that it even looks like it's a cartoon-type shader. You set that contrast to something more reasonable, like let's say 50%. Below, you'll see Soften Diffuse Edge, and the name implies it's going to soften the gradient from the brightest part to the darkest part of the surface, and that up to, let's say, 50 as well. And that softened up the look. Additionally, within here, you can do things like disable specular highlights for the light completely. That's sometimes useful when you're just using a fill light that's just supposed to fill some of the shadows. That's the introduction to using the advanced effects to control the contrast of a shot. Properties of a spotlight is the softness of the edge, sometimes called the penumbra. To adjust the softness of the edge, I'll want to select the spotlight and go to the Modify panel and open up the Spotlight Parameters rollout. With Spotlight Parameters, you'll see Hotspot and Fall Off. They correspond to the two cones that you see in the viewport. Spot is the inner cone. And if I reduce that angle, you'll see I'm getting a softer edge to the spot. I've got the fall off value, and increase or reduce that as well. The difference is between the hotspot and fall off values, the softer the look will be. I reduce this fall off value down until it gets close to the hotspot value. If it's to go below the hotspot value will actually be adjusted automatically. And Max is set up to maintain a difference of 2 degrees between these two. If you want a super sharp spotlight edge, then you can go into the preferences and change that. Increase this. Okay, that's pretty cool. But something that's even cooler, I can look through the light as if it were a camera, and give me the ability to adjust this hotspot and fall off interactively, as well as change the position and orientation of the light. I need viewport to do this. I'm not using the left view right now, so I can sacrifice that one. I'll click the viewport label and to Lights, Spot 01. I'm looking through Spotlight. I'll go up here and change some of the display options. I'll switch it over to a realistic view. And scene lights. I'll actually need to click on realistic and go to lighting and shadows and enable scene lights. Now I can see what the light is actually illuminating. I can move the light around with middle mouse button. Go down to the viewport controls and use the orbit tool to orbit the light around its target. And additionally, I can adjust the hotspot and fall off values in viewport. You'll see here that there are a couple of buttons here. Hotspot and fall off. I can click on that and adjust it directly in the viewport. It's easier to see if the light is actually selected. Select Object tool and then select the light, and now I can actually see the circles here. Right-click in the Spotlight viewport so that I don't lose the selection. Back to adjusting the hotspot and fall-off values. I can use a first-person method to adjust the light position and orientation, also its hotspot and fall-off values. In a shot, we need a key light to project shadows. It's disabled for each light by default. I'll select the light and go to the Modify panel. enable shadows in the general parameters rollout. I'll go ahead and tick this switch to turn it on, and you'll see I'm getting shadows projected onto that backdrop. Let's talk about the different types of shadows and which one you would choose in different situations. The default is called a shadow map, and that's a pixel-based shadow. That it's actually projecting a pixel-based image onto the backdrop. And that's the cheapest, it's the most efficient and fastest of all the shadow types. And that's why it's the default. As we'll see in a later movie, if you use shadow maps, you're going to have to adjust the pixel values in order to get good results. The disadvantage of shadow maps is that they don't respect transparency, and we will not get a variable softness to the shadow based upon distance. Shadow map is just equally soft or equally hard throughout, and it doesn't respect transparency. If I have a glass object, it'll cast an absolutely black shadow if I'm using a shadow map. What other options? If I click on this pull-down list, you will see a few other options. Specifically, we've got ray trace shadows. And select that, you will see that in my viewport now I'm getting a little bit harder edge shadows. As ray trace shadows are vector-based. And by default, ray trace shadows will give you very hard edges, and they do respect transparency. So a glass object would cast a very light shadow if you use ray trace shadows. We've got area shadows. Shadows are useful because you can get a really soft effect, and it's vector-based, which means you don't have to worry about mosaicing or pixelation in the rendering. But area shadows do not respect transparency, and if, again, I have a glass object, I'll get perfectly black shadows if I use area shadows. Finally, advanced ray trace. Advanced ray trace shadows are the best option because they do respect transparency, and softness of the shadow does respect distance. However, they're the slowest to render because they're the most computationally expensive. Look at shadow maps first. In the movie. The most efficient type because they calculate fastest. However, in order to get good results, you need to understand how to adjust their settings. I'll select the spotlight and the modify panel, and I'm looking for the shadow map parameters rollout. The two important parameters here are sample range and size. Range is the amount of blur, and size is the resolution of the shadow. I'll set sample range down to 0, press enter, and you can see in my camera viewport I'm getting sort of jagged edges here. Reduce the size or resolution down, let's say 128, then we can very clearly see the mosaic structure of the shadow map. It's out of pixels. To get a nice clean result, I'll need to have a larger size or a higher resolution. Let's say I set that up to 1024. Press enter. Now I'm getting a cleaner edge. Size works best if it's set to a power of 2 value. It's 512 or 1024 or 2048. Useful range of values is usually somewhere between 512 and 8192, which is an 8K value. There are other factors that also influence the quality of a shadow map. The size of the spotlight's fall off, the distance of the light to the shadow receiving surface can also affect the quality. Let's set the size back down to 128 and adjust the spotlight's fall off value. I'll open the spotlight parameters and increase the fall off. Now watch what happens in my camera view. As I increase the fall off, it starts to look even more blocky. If you reduce the fall off and have a very narrow angle to that, then you can see that the shadow map is looking better and better. What's happening here is that this is a pixel-based image of only 128 pixels on the side, and that's being stretched across this fall-off radius. I've only got 128 pixels this way and 128 pixels that way. That a greater fall-off amount is usually going to result in a blockier shadow. The of the light to the shadow receiving surface is also going to influence the shadow quality. on this spotlight viewport, and I can dolly back using the viewport controls down here. Pull the light back, you can see that is also affecting the shadow quality because that pixel-based shadow is being stretched over a larger area. Good results with shadow maps, you'll need to adjust the light parameters as well as its position. Let's do a pretty good value. I'll select the light and back to a size of 24 with a sample range of, let's say, 5, which will give me a little bit of blur, and adjust fall off amount to make this a little bit larger. Then I'll just click in the camera viewport and click Render Production to do a preview render. Basics of setting shadow map parameters. Or a more realistic alternative to shadow maps. Don't respect transparency, but area shadows do respect distance. A slightly modified version of my logo here, in which you can see part of the logo is very close to the backdrop and part of it is pretty far away from the backdrop. Let's do a rendering of this with just default shadow maps. Click Render. And although I've got a little bit of a soft edge to the shadow, it's a consistently soft edge across the entire surface here. To be more convincing, what we want is a sharp shadow here and a softer shadow over here. I can do that using advanced ray trace shadows, and I can also use area shadows, which are a little bit faster to calculate. Also light, the modify panel, and I want to choose area shadows as my shadow type. Click on that. I'll go up here and re-render this view. Default area shadow. You can see that it's sharper here and softer over here. The quality isn't that good, but we will change that up. I'd like to show you how to use region render so that you can render just part of a frame and not have to wait for the entire thing to render each time. Go up here and make sure that I've chosen the camera view and I'll lock that view so that that's the only thing that will render, regardless of what I have selected in the viewport. I'll go here to Area to Render, choose Region. And now a red box around my rendering, and I can resize that box to enclose just the area that I need to render. I'll click Render button, you'll see that's the only part that renders. Now go back to my light parameters, start adjusting the area shadow parameters. I'll let the area shadows roll out, and you'll see the basic options here. Rectangle light. The light itself is a point source, but purposes of shadow calculation, it's considered to have some area, and we can choose different shapes for that area, rectangle, disc, and so on. And size is controlled by these dimensions here. The larger the area light dimensions are, the softer the shadows will be overall. If I set this to a value of, let's say, 24 inches, press Tab key and 24 inches, render over here and it'll just render that region again. Now you can see I'm getting a much softer result. For the quality, I'll have to go up here to the anti-aliasing options. The integrity is essentially the accuracy of the shadow. I'll set integrity up to, let's say, a value of 5. And click Render to render that region again. And you see that although it's looking kind of grainy, it's more accurate. To improve the graininess, I'll go over here to Shadow Quality and set it to a value of, let's say, 10. You can see it takes longer to render. The shot that you do is going to need to be tuned. The shadows are going to be slightly different in each situation, and so it means you'll need to go in here and adjust these values. Set the area shadow parameters to get good results. Control the color of a shadow independently of the color of a light. That's not a very good way to lighten up dark shadows. Instead, you do what's done in the real world, which is to add fill lights. A fill light is one that just simply fills in dark shadows in the shot. An option for that is an omni light or an omnidirectional light. I'll go to the Create panel, and in the Lights panel, I'll choose Standard and Omni. On that, and then click in the top view to create that omni light. Then right-click to finish OmniLight creation. See in the top view that my key light, the spotlight here, is on one side of the camera, and my Omni fill light is on the other side of the camera. A traditional way of filling in dark shadows. You'll also see in the shaded views that my shot is now overlit. It's too bright. I'm going to go into that OmniLight's Mod panel and knock its intensity down a little bit. I'll open up that intensity color attenuation and knock the multiplier down to a value of, let's say, 0.5. While I'm here, I'll also take the opportunity to change the color of the fill light. An artistic technique is to use a complementary color fill light. A warm color for the spotlight for my key. I use a cool color for the OmniLight, which is fill. I've gone color, and I'll just change that hue to a blue and have it be very, very desaturated. It does not need to have much saturation to it. If it had too much saturation, it would start to look kind of strange. Bring it back down a little bit. Let's say an active shade. I'll click on the camera viewport label and choose extended viewports, activate. And you hear that it's still overlit, even with a value of 0.5. I'll select that OmniLight and reduce that multiplier down even lower to, let's say, 0.2, 0.3. And that's maybe the sweet spot in terms of the shadows, but now my logo itself is overlit. To get results with lighting, you'll need to adjust the brightness of all of the lights in your shot. I'll go back to my key light and reduce its intensity. Open intensity and knock the multiplier down to, let's say, 0.8. Now I'm not getting the highlights blasting out on my logo. A good rule of thumb for standard lighting in 3ds Max is you don't want all the lights in your scene to have a cumulative multiplier value beyond, let's say, 2. In this case, I've got a cumulative value of only 1. It's plus 0.3 or 1.1. Finally, I probably want to use a backlight or a rim light to highlight some of the edges. I can make a clone or a copy of this OmniLight by just holding down the Shift key with the Move tool active. And drag this over and place that behind the logo. Clone options dialog pops up. I want to use copy as the object type. Might need this rim light to have different parameters than the fill light. Okay. And now a little bit more highlighting on the edges. We see that as we move this around. Also that it's illuminating the backdrop itself. If I don't want that, then I can change the behavior of that, and we'll do it in the next movie. Or backlight over here. And it's illuminating my logo edges pretty well, but I'm getting much light on the backdrop here. Go back to active shade. See that better. Again, light is lighting up the sides and back of the logo, but it's also lighting up this backdrop panel here. What I want to do is exclude the object from illumination from the light. Select that light. Then right here in the general parameters is a button that says exclude. I'll clone that. And what I hear is a dialog with two sides. On the left are all of the objects in the scene. Right are any objects that I want to exclude from either illumination or shadow casting or both. Since I'm not casting shadows from the rim light, it doesn't matter whether I choose illumination or both. I'll just hit both. Here's a shop object. It's called Plane 01. And I'll click this arrow to move it over into the exclude section. Okay. Let's see the result right away in active shade, and we might need to reinitialize. Right click, use initialize. You'll see that I'm getting highlights on the rim of the logo, but I'm not getting any illumination on the backdrop. This is an extremely useful technique. It's very easy to exclude objects from lights in CG. This is something that live action cinematographers and photographers have to work very hard to do in the real world. But here in CG, it's super easy breezy. On basic lighting, let's look at the light lister, the panel that lists all of the lights in the scene and gives us easy access to their most common parameters. It's found in the Tools menu. Tools, Light, and its window, you'll see all of the lights in the scene listed. And do all sorts of things, like, for example, turn them on and off, or their intensity. It's back down. I can turn their shadows on and off, change color, and so on. Not all the light parameters are listed here, but I need to get to the more obscure parameters in the Modify panel. All I have to do is click this little button over here on the extreme left, and that actually selects the light, and I can open the Modify panel and get at those parameters. Light Lister is a super useful window in 3ds Max, and I use it all the time. The more lights you have in a scene, the more valuable the light lister will become. And that concludes our chapter on basic lighting. Of all computer animation, whether it be 2D or 3D. Here's an example of a flying logo that spins around in front of the camera. Select that logo. In the timeline here, you'll see these little ticks, and those are keyframes. The idea of keyframing is simple. The artist sets a value for some parameter, such as the position of an object, at a certain point in time. And sets another value for that same parameter at a different point in time. And the computer fills in all the blanks. And that's called keyframe interpolation. What here is a keyframe at frame 0, another at frame 60. No data in here except for what the computer has filled in. And that's keyframe interpolation. Animating, you'll probably want to go in and change the preferences for how you're displaying time in the timeline here. For how many frames you're seeing and whether they're listed as frame numbers or time code. Before that, let's just make sure that you can actually see the track bar here, which is a little slider. You turn that off in an earlier movie. I'm going to customize Show UI and make sure that track bar is checked on. That means it's visible. Go to the time configuration dialog, which is down here in the lower right-hand corner of the interface. I'll click on time configuration, and you can change the frame rate. The is 30 frames per second, NTC, which is the US standard frame rate, approximately 30 frames per second. We'll leave it at 30 for now. We got the ability to display either frame numbers or time code. Switch this to SMPTE or time code. SMPTE stands for Society of Motion Picture and Television Engineers. And now the track bar is displaying minutes, seconds, and frames. Animation area here, we can set the total length of the visible area of the timeline. Currently set to 3 seconds, 10 frames. I'll increase that to 6 seconds, 0 frames. Also, there's a helpful switch here, active viewport only. If on, then we'll only see playback in the current selected viewport. I'm going to switch that off. That way we can see playback in all viewports simultaneously. Okay. Now you'll see I've got 6 seconds worth of time in my timeline, and it's being displayed as SMPTE time code. It has 2 methods for creating keyframes, and you'll see them on these 2 buttons here. Set key and auto key mode. Let's set key mode first. Before we create any keyframes with set key, we'll want to choose which types of keyframes we want to create. In other words, do we want to create keyframes for position or rotation and so on? Control that behavior through the key filters. I'll click this button here, key filters. I get a pop-up dialog and can choose which parameters I want to keyframe in set key mode. For this pass at our animation, I'll create position keyframes. So turn off everything except for position. It is sticky and it will be remembered in the current scene. We'll actually create keyframes in set key mode. frames in set key mode, the first thing you'll do is activate set key mode. Click the button that's labeled set key. As you do that, you'll notice that you get a big red indicator in the track bar. That means that we're actually in set key mode currently. So the currently selected viewport is outlined in red. I'll flying logo, and on frame 0, I'll move it off screen in the x-axis. And I have frames enabled in my camera view that will know exactly whether the object is in the frame or not. Position the object, and I'm ready to create the keyframe. All I have to do is click the big skeleton key button, and immediately a keyframe is created. You can see now that we got a little red keyframe indicator here on the timeline. The timeline will only display keyframes for the currently selected object. If I deselect my logo, my keyframe will not be displayed. Reelected. We'll go down to about 3 seconds in. Move the back bar down to 3 seconds, 0 frames. I'll select the low end, position it in the center of the camera viewport, and click the skeleton key button again. Keyframe is created. To view animation, I'll go down to the transport controls here and click rewind, and created a very simple animation. There are 2 keyframes. The only parameter that is animated is position. Creating keyframes, you will click the set key button again to turn set key mode off. For editing keyframes is directly in the timeline. I'll logo and play the animation, and it takes 3 seconds for it to get to its destination. If to move more quickly, all you do is click and drag on a keyframe and move it to your point in time. Rewind and playback. And now it's taking about 1 second to get to its destination. I can click that keyframe and move it down to a later point in time, which means the object will move more slowly. Now taking a full 6 seconds to the center of the screen. I'll keyframe back to 3 seconds, paying attention to the numbers at the bottom of the screen. Moving keys from 6 seconds to 3 seconds, 0 frames, and really mouse, and back where I was. Additionally, I can change the value of a keyframe. I can position the track bar directly on top of the keyframe and change the parameters such as position and create a keyframe on top of the existing one. I'll activate set key mode, grab move tool, logo out of frame, click the skeleton key button again, and overwritten the existing keyframe. I'll rewind and test that, and that 3 seconds in, it's completely left the frame. When, of course, I'll want to turn set key back off again. There's a feature of 3ds Max that lets skip the track bar to exactly the time of a keyframe. And to do is go down to the transport controls here and activate this button that's called key mode. And when that's on, these 2 buttons here will let me go to the next key or the previous key. That's very helpful, especially if you're editing existing keyframes. You don't want to accidentally create another keyframe that's right next to an existing keyframe. Create keyframes in 3ds Max. It's called auto key mode. I'll go ahead and turn that on. As I do that, once again, the track bar is highlighted in red and the currently active viewport is also highlighted in red. Auto key is a very useful function, but if you're not careful, it could get you into trouble. Because when this is on, literally almost anything that you do in the program will create keyframes. For example, if I go into the material editor and change the color of a material, in fact, I'll be creating keyframes for that color. You just need to make sure that you're paying attention when you use auto key mode. One of the tricks of auto key is that it will create a keyframe at frame 0 by default if you're parked on frame 0. In other words, if If I grab my logo and move it, and on frame 0, no frame is being created. However, if you position this on frame 0, let's say right out of the frame, go to a different point in time, let's say at 3 seconds in. Now, when I move the object, I will create keyframes at frame 0 and at 3 seconds in. If I do that, you'll notice I got 2 keyframes, one here at frame 0 and one at 3 seconds. Behavior can be changed in the preferences, but this is the default. Once you're on frame 0 and you manipulate something in auto key mode, by default nothing will happen. But if you're on any other time other than frame 0, you use auto key, 3ds Max will create 2 keyframes, one at frame 0 and one at the current time. I'm going to play that back, and you see I've got 2 keyframes. Finished, I'll want to turn auto key back off again. Position keys for the logo. To show that, I'll select it, and you'll see I've got position keys down here. When I press play, the logo moves through the scene. Now to add another passive animation, I'll click rotation keys to make the logo spin. The easiest way to do that is by using set key mode with the key filters set to rotation only. Click on key filters and disable everything except for rotation. And activate set key mode. I'll go to 0. Click the big skeleton key button. Now notice that this first keyframe has 2 colors, red and green. The indicator that there's a position key and a rotation key at that point in time. In 3ds Max, red is a position key and green is a rotation key. Now down to 3 seconds in, grab the rotate tool, and I'll spin this around exactly 360 degrees. The way to do that is to use angle snaps. On the main toolbar, I can click on angle snaps. You can also use the keyboard shortcut, which is A. Rotate the object exactly 360 degrees. I see the numeric value at the bottom of the screen in the transform type in area. And with 360, I'll release the mouse and click the big skeleton key button. When I turn set key mode off, then I'll find and admire my work. You'll see that it's spinning around exactly 360 degrees over the course of 3 seconds. Position and rotation keys of this object separately from one another. Select it, you'll see in the timeline, however, that both the position and the rotation keys are at the same point in time. Therefore, for me to select only position or only rotation in the timeline in this case. To do that, I can use another window called the dope sheet. Dope sheet, or exposure sheet, is a term from traditional animation. It's a spreadsheet that lists every frame in the animation and instructions on what should happen on that frame. So dope sheet in 3ds Max, I'll go up to the menu labeled Editors. I see Track View Curve Editor and Track View Dope Sheet. This will show you keyframes for the currently selected object. If I deselect my logo, I won't see anything in the dope sheet. I'll go ahead and select it again. One has got several keyframes on it. What I need to have happen here is I need to edit those keyframes independently. To do that, I'll open up the Text01 hierarchy. And you'll see Transform. Open Transform up. And now, finally, I have separate keyframes for position and rotation. I can zoom in on that. Controls over here on the right-hand side. Zoom region. And then draw a box around that region. And let's zoom in on that area. My time is indicated here by this blue line. If to move keyframes around, then I'll use the Move Keys tool here. On that. Let's say I want the rotation to happen more slowly. I can click on the rotation key and then drag it down to a later point in time. And you can see as I do so, the dope will scroll. And move it down to 6 seconds. And release the mouse. Minimize that. Find in my transport controls and play back and see what I'm getting. The position settles down at 3 seconds, but the rotation takes a full 6 seconds to complete. Go back to the dope sheet, which is minimized down here. I'll give you a little bit more clarity about what these boxes represent. I can also click here to frame the entire keyframe range, and we can see all of them. So these rows here are not actually keyframeable channels. For example, here, text 01, no animation channel or track called text 01. However, there are actual real keyframes here in position and rotation. What are these white boxes here? Well, they're just methods for you to select keyframes. It's hierarchical selection method. I click up here at the top, and all of the keyframes at that position in time will be selected and move them around or do whatever I need to. Open up some of these, you will see that in fact, position has got several keyframes within it. There's X, Y, and Z position keys here. And to move just one of those, I could click on it. Now that's the only one selected. To move all of the position keys, I could click up here in the position row, and that will select all of the position keys. And these rows here are methods of hierarchically selecting keyframes. This is a little bit of getting used to, but we're familiar with the idea that these are not actual keyframes. You'll be able to use them to great advantage. It's not a keyframe, that's just a method for selecting keyframes that are hierarchically below that level. And only 3ds Max calls these fake keys because it's not actually a keyframe. Essential for adjusting animation timing. Eventually, you're going to need finer control. To do that, you can use another window called the Curve Editor. On the animated object, the Graph Editor's menu, and choose Track View Curve Editor. Here are function curves. The animation data is being visualized as a curve. The horizontal dimension here is time, and the vertical dimension is the value of the particular track or animation channel. If the curve is steep, that means the value is changing quickly. If the curve is shallower, then the value is changing more slowly. And if the curve is completely flat, the value is not changing at all. And in this case, only 2 out of the 6 function curves are changing in value. Clean up my view here, I can delete some of this other stuff. Select Y position, Z position, rotation, and Y rotation. And they're all just flat, static channels. I'll install those keyframes. And that's the delete key on the keyboard. I'm going to work on X position and Z rotation. Hold down Control to select both of those. The timing of the animation in the Curve Editor, I move these keyframes around. The Keys tool is active by default. I'll draw a selection window around these two, and I only want to move them in time. I don't want to move their values. I'll hold down the Control key and drag, and I'm moving only in time. Timing. Bring that down to 6 seconds. And if I rewind and play back my animation, you'll see that it's taking 6 seconds to reach the final destination there. Go to the Track View Curve Editor. The way I can adjust the timing, with selected keyframes, I can type in their frame value up here. Currently, they're at 0 minutes, 6 seconds. Just highlight that 6 and type in a 3 and press Enter, and they're at 3 seconds in. A very important aspect of a function curve is its shape, and that determines the interpolation. These have default auto key interpolation. We're going to give us an ease out and ease in. I wanted a straight line interpolation. That would be a linear interpolation. It would be a very sudden stop. Select all these keyframes. And appear to this toolbar and click on the button labeled Set Tangents to Linear. The tangent handles, which we saw a moment ago, are hidden, but we've got a linear curve now. View, line and play back. And what we'll hear is that the logo comes to a very sudden stop at the end there. And play that again for you. Linear interpolation. Go back to the track view. Them again. And I switch it back to auto tangents. A default auto interpolation or default ease in, ease out. If to change the behavior of this ease in, ease out, I can directly edit the tangent handles. I can click on one of these and move it around, and you can see I'm changing the shape of the curve. Let me do that with Control Z. To make that the curve doesn't overshoot the mark, I'll hold on the Control key to change the length of that handle horizontally without moving it vertically. Holding down Control, and I'll do it the same for the second keyframe. This is going to be as a very slow ease in to the resting position. Rewind and play that back. It's a very slow and graceful transition into that resting position. One thing that you need to do in animation is to create cycles and loops. We could do this by copying and pasting keyframes, but 3ds Max provides an easier way to do this. What you need to do is select the object and go into the Curve Editor, Graph Editors, Track View Curve Editor. And clicking on Rotation, I want the logo to spin infinitely. Select that curve, all its keyframes, and to get a clean loop, I want to use linear interpolation. I'll click here once again to set those tangents to linear. Notice before and after the keyframed area, we're seeing a dashed line. Max calls this the out of range time. Before the first keyframe or after the last keyframe is known as out of range. To cycle, we can choose a different out of range type. We'll just go up to the Edit menu inside the Curve Editor and go to a menu item that's Controller. Controller is a program module that creates motion or animation. Inside that controller item, I'll choose Out of Range Types. Another pop-up dialog. These are all the different possibilities. It is constant, which means that before the first keyframe and after the last keyframe, hold a constant value. Let's try loop and click OK. And now what you see here is a sawtooth wave indicating the duration of time. With loop out of range type, you'll see that the last keyframe immediately jumps to the value of the first keyframe. I'll rewind my animation and play it back. Actually working just fine. It's rating infinitely. And if I could change my time configuration and make this 10 minutes long, and it would keep spinning forever. What if I want to change the rate here? What if I want it to spin faster or slower? Or what if this second keyframe were not at exactly 360 degrees? There's an alternate method I can use to determine the out of range value. Back to the Curve Editor, and back into the Edit menu, Controller, Out of Range Types. In this case, the optimal one to use is linear. I'll click that and click OK. And linear out of range interpolation. In fact, what we're really doing is extrapolating the curve. I'll use the mouse button to move around in the track view here, and you can see that after the last keyframe, that value is being extrapolated or being continued onward on that path. And it will look the same when I play it back. This is going to give me more freedom, because now using this method, the second keyframe does not have to have a value of exactly 360 degrees. I can go back to that Curve Editor. As long as the curve is a linear interpolation, I can make these keys whatever I want. I can just click on that, and I move it wherever. I make it go faster or slower by changing the slope. Rewind and play that back, and you'll see it spinning a lot faster and spinning infinitely. Range types are a really useful way of creating loops and cycles and or extrapolating existing animation. This concludes our chapter on keyframe animation. Of course, we've just barely scratched the surface here. 3ds Max has a very deep and a very powerful tool set for creating animation. Animation is not just the movement of a single object, but rather the movement of an entire linked chain or hierarchy of objects. For example, this robot arm. The rotate tool and select one of these objects and turn it, see that the other objects turn as well. This object, see that we've got a relationship between these. This is called an animation hierarchy, or sometimes called linking or parenting. Those basically mean the same thing. There are three main principles around animation hierarchies. First of all, children inherit transforms of their parent. If I select this turntable object and rotate it, then all of its children will rotate as well. Second, a child may have exactly one parent, no more, like in biology where a child has two parents. And finally, a parent may have multiple children. For example, this wrist object down here has got two children, these two claws. And I manipulate this wrist by, let's say, for example, moving it, that those two claws move as well. Basic principles of hierarchies. Children inherit transforms of their parent. A child may have exactly one parent, but a parent may have more than one child. Working in a 3D program such as 3ds Max, you need to understand how reference coordinate systems work. When you transform an object, move, rotate, or scale it, you can use different points of reference around which that transform will happen. In 3ds Max, the reference coordinate system is chosen from this pull-down list here, and sticky for each of the three transforms. In other words, 3ds Max will remember your choice for each of the three transforms. I've got the Move tool active, and I choose a different reference coordinate system. Let's do world coordinate system because that's the most easy to understand. When I activate that, when I move something, it will be moved according to the world coordinates, or along the three axes of the grid. If I select an object such as the base of my robot, you'll note that the Move gizmo is aligned with the world coordinates. In the lower left-hand corner of the viewport, you will see an axis tripod that indicates the current orientation of the world coordinates. When I've chosen world coordinates as my reference coordinate system, then the transform gizmo is always aligned with the world grid. Simple and very straightforward. The default reference coordinate system, however, is not world, view. In view coordinates, when you transform something, you're transforming it relative to the viewport itself. In the top view, it just so happens that the coordinate system is identical to the world coordinate system. See that my transform gizmo shows X pointing to the right and Y pointing up. And axis tripod also shows X pointing to the right and Y pointing up. However, if I choose a different viewport, such as this left view, the transform gizmo is still aligned X to the right and Y going up, but world coordinates are some other orientation. And the view coordinate system operates in screen space. Transform gizmo is aligned with the current viewport. The exception to that is the perspective view or a camera view. I'll click over here so I don't lose my selection. Notice that in this case, the transform gizmo is not aligned with the viewport, but rather with the world. The coordinate system operates in screen space, except for in a perspective view or camera view. In that case, the view coordinate system defaults to the world coordinates. Animated rotations for an articulated hierarchy such as this can be challenging if you're not familiar with the way that reference coordinate systems work. To illustrate this, I'll grab the Rotate tool and the default view coordinate system. I'll turn this robot turntable about 45 degrees. What I want to do here is I want to turn the elbow down. Select that with the Rotate tool in View Coordinate System. You see that the Rotate gizmo is not aligned with the object. I'll get a little bit closer on that. And if I try to rotate this in any direction, I'm not able to turn it so it rotates directly down. Then I can achieve that result in view coordinate system. And because the rotation axes are currently locked to the world, I have other options, however. The one that most people use is local coordinates. Up to the reference coordinate system and choose local. I can actually turn the object in the direction that I want because local coordinates are a temporary reference coordinate system that's locked to the object. And that's okay at first, but local coordinates can be problematic. For one thing, I can't see the absolute rotation value when I'm in local mode. You'll see that as I turn it, I'm getting a numerical readout on the transform gizmo that's telling me the offset value that I've rotated it away from its starting position. There's no way for me to find the absolute rotation value in local mode. What I have to do to see a rotation value is go into parent mode. Now what I'm going to see is rotation values relative to the object's parent. And you'll see down here in the transform type in dialog, I've got an X rotation of 89. I can also right-click on any one of the transform tools and open up a transform type in dialog. And this is a little bit more convenient for me. Type in 90 degrees exactly, 90 degrees of rotation relative to the object's parent, which in this case is this robot shoulder object. I think that parent rotation is what you want, but still not quite right. To look at this, I'll rotate this wrist object a little bit. That I'm not able to actually rotate it around its own coordinate system. If I turn this, it's sort of weaseling around and spinning around. That then in this case, we should just switch back to local mode, and that would probably work. Like that. Back to local coordinate systems, and you'll see now the rotate gizmo is aligned with the object. And okay, so far so good. However, it's not okay, because as soon as I try to keyframe this, I'm going to have problems. And this is where people really get tripped up in 3D. This is one of the most common problems that people have when trying to animate a character or other articulated hierarchy. I'll go here to my key tools and turn on auto key and go to, let's say, frame 30. In local mode, I'll spin this around to be 200 and something degrees. I'll turn off auto key, rewind and play this back, and you'll see that I get this very strange result. It's spinning around the axis that I wanted it to. It looked okay when I was in the viewport and turning it, but as soon as I try to animate this, I've got problems. This is not a bug. This is the way that all 3D software is designed. If you're not careful, you'll run into this problem. If I go back to parent mode, this might be a clear explanation of why this is happening. If I rotate in just one axis in parent mode, I can see rotation values. Notice, although I'm rotating only in X, all three of these values are changing over here. That's the problem, is that we can't use local mode because interpolations will get messed up, and we can't use parent mode because we can't actually rotate it in the direction that we want here. The solution is we need to use another mode, which is called gimbal. Up here to reference coordinate system and choose gimbal. Now when I rotate in gimbal mode, it's only rotating in one axis at a time. That's really good because now if I animate this, it's only going to rotate in one axis, the one that I've chosen, and I won't get that strange behavior that we saw a moment ago. Delete these keyframes down here and start over. I'll just select those keyframes and press the delete key on the keyboard. It's in gimbal mode, and so far so good as far as I'm only getting one axis of rotation at a time. I'm not able to rotate it in the direction that I need to. And the linchpin to this whole problem is I need to change the rotation order. 3ds Max, like most 3D programs, calculates the rotations in linear sequence. It's calculating the X rotations, then the Y rotations, and finally Z rotations. What I do is I want to give priority to the Z axis here. To change the rotation order, I'll select the object and go to the motion panel up here. PRS parameters section, I want to choose rotation. Got the Euler parameters here. And I want to change the axis order to give priority to the z-axis. Pull down list, I'll choose ZXY. And although my object has turned in a different direction now, I've actually got exactly what I need now because I can spin it around Z. You'll see only Z is updating. And if I do it this way, then I can keyframe this exactly the way I need to. I'll auto key back on, frame 30, and turn the object, and now you'll see it's spinning in the direction that I need it to. Gimbal mode is essential for controlling rotations. Gimbal mode alone is not good enough. You also need to, in many cases, change the order of rotations to give priority to the most important rotation axis. That bit of obscure information, that's something that's not quite obvious in the interface, and it may not really be covered very well in most training materials. This is really life or death for creating convincing animation that doesn't spin around in uncontrollable ways. Another consideration for hierarchies is the position and orientation of the pivot point of each object. In this version of the robot arm, some of the pivot points are correct and some are not. For example, this shoulder object has a pivot point exactly in the center of this ball joint. I'll use the rotate tool and turn it so you can see. This, however, doesn't have its pivot point in the correct location. I'll do that. Move or rotate the pivot point, select the object, and go to the Hierarchy panel. And the Pivot subpanel is active by default. Move or rotate the pivot, click on Affect Pivot Only. See a new axis tripod that indicates the position and orientation of the pivot point. Don't confuse the pivot point with the transform gizmo because they're two different things. The pivot point is a property of the object itself, and the transform gizmo is merely a manipulator that you can use to move things around and rotate them. Sometimes the transform gizmo is at the same location as the pivot point, but not always. For example, the gizmo could be located at the origin of the world. I want to move this pivot point down so it's at the center of this ball joint here. I'll choose the Move tool, and I'll just move it straight down. To ensure that it's exactly where I want it to be, I'll hit Alt-W and get in very close in the front viewport. Make sure that that's positioned exactly in the center of that sphere. I'll exit, select Pivot Only, grab the Rotate tool, and turn the object and make sure that it's turning in the direction that I need it to. And OK, so I'll hit Control-Z to undo that. Next, I want to look at the pivot point orientation. I've got these two claw objects up here. What I want here is I want to be able to select both of those claws and rotate them in opposite directions at once. Currently, if I select them both and try to rotate them, they'll rotate in the same direction. But I can change the pivot point orientation to get the result that I need. Again, I'll select the object and go to Affect Pivot Only. And what to have happen here is I want the y-axis to be pointing in opposite directions for each one of these. You can see here the y-axis here is pointing in the world positive y, and well, it's pointing in the world positive y. I want this to point in the world negative y. With Affect but only active, the Rotate tool active, angle snaps turned on, I'll rotate the pivot point exactly 180 degrees. I'll disable Affect Pivot Only, make sure I'm in gimbal mode, use Pivot Point Center. Then grab the two objects and rotate in Y, and you'll see I can rotate them both symmetrically. So now I've set the position and orientation of each pivot point on my object. And I'm going to lock some of the transforms so that I can't accidentally move or rotate them in undesired directions. Ready to link all my objects together. One thing I can do just to protect myself from accident is to lock some of the transforms. I can do that from the Hierarchy panel. An object, go to Hierarchy panel, and choose Link Info. And here you'll see locks. I'm not going to be moving this object, and I'm not going to be scaling it at all. And on the locks for position X, Y, and Z and scale X, Y, and Z. For rotations, I'm really only going to rotate this one in one direction. I'll choose the rotate tool so I can figure out which direction I need. Looks like it's the X-axis that I'll be rotating in. Lock the Y-axis and the Z-axis. Now if I try to rotate it in any direction, I can really only rotate it in X. If I click on Y or Z, it's still going to turn in X. That's in gimbal mode. If we switch over to local mode, you see actually that the other axes are currently grayed out. That's optional. I do prefer to work in gimbal mode. If you link all your objects together, I do recommend that you check in on all of these things. You check in on the rotation order, the bit point position and orientation, and optionally lock some of the transforms so that you don't get into trouble later. All your objects, as described in the previous few movies, then you're ready to link them together. The way to do that is in the viewport using the Select and Link button on the extreme left-hand side of the main toolbar. Select that icon. Click on the object that you want to be the child and drag to the object that you want to be the parent. For example, click on this robot elbow, hold down the mouse, and drag it down to robot shoulder and release the mouse. The parent object will flash just for a moment. You'll see that selection bracket just flash for a moment, and that indicates that the link has been made. Of course, you have to have selection brackets visible in order to see that. And remember, the shortcut is J. You'll want to work from the outer extremities inward, because the outer parts are usually the children. And I continue that process. I can click on the shoulder, hold down the mouse, and just by the way, as I move my cursor around, different cursor icons. This icon with a little X, that means that's not a legal object. I can't actually link something to itself. Go down here, I get an icon that indicates it's okay to make the object the parent. I'll release the mouse button, and the parent will flash for just a moment. Once again, I'll click on this one, hold the mouse, and drag to the object that I want to be the parent. You can test all of this by using the Move tool or any one of the transform tools. Just make sure I don't try to rotate or move it in a locked transform. Base here does not have locked positions. I've locked the positions of these ones here, so I can't actually move those. But I can rotate them to test to see if my links are working. Up here at the top, I'm going to this wrist, link wrist here. So, and finally, I have two claws that I want to link to the wrist. And in fact, I can do those both at once. Drag a selection rectangle to select both of those, and then click and hold and drag down to the object that I want to be the parent. And you'll see I get two dashed lines this time. I release the mouse. Those two objects are now linked to the parent wrist. And again, you can test this by selecting that parent and rotating and making sure that the children are actually following along. To test the entire hierarchy, I'll go back to the Move tool and move root and make everything else is following along. If I need to break links, I can simply select the object and click the Unlink button. And now this is no longer a child, a shoulder. And I'll test that by selecting the base and moving it, and you'll see the arrow is not following along. Do that and go ahead and link it back up again. There's a very helpful window called the schematic view, which lets you visualize the structure of your hierarchy and also make or break links in a node-based editor. Schematic view can be opened in a couple of different ways. One would be from Graph Editor's New Schematic View, or from the main toolbar, there's a button that says Schematic View Open. I'll click on that. See here two windows. I've got this little child window here called Display. I can use this to visualize other types of relationships but from parent-child links. Right now I don't need that, so I'll close it. The window is showing me parent-child links, and I can navigate in that window using the keyboard shortcuts, the mouse button, Control-Alt middle mouse to zoom in, or mouse wheel. Root, or the first parent, is shown at the top here, and children is shown below it. If I need to make or break links, I can do that within the schematic view as well. You'll see I've got a select and link button here that's labeled connect. And I've also got an unlink button. If I unlink everything, I can just select it all and then click on unlink. And to link things back up again, I'll do the link tool, connect. I'll link the turntable to the base, shoulder to the turntable, low to the shoulder, to the low, and I can select the left and right claws and link them just. This is very helpful for you because you can, again, visualize the structure of the hierarchy. On hierarchies, I have to show you a common problem that many users have that has to do with non-uniform scale in animated hierarchy. In all objects in a hierarchy should have scale values of 100, 100, 100%. And if that's not the case, then you will probably have issues when you rotate child objects. Here's a simplified version of a robot arm that's a good illustration of the problem. I've got all the parts except for the bottom parts here. Just to illustrate that, you can see if I rotate this, all these others are rotating as well. I've got a box down here, and that's going to be the base of my robot arm, but it's not tall enough. If I didn't know any better, I would just stretch it up by scaling. And it gives a problem. Go ahead and grab the scale tool, and here at the transform type in area, watch these numbers. I'll split up in Z to make it taller. And X is 100, Y is 100, and I'll set Z to be about 400. It's about 4 times its original size. And I release the mouse. And that's okay, it looks fine. Now go ahead and link the rest of the hierarchy to this scaled box. I'll hit the select and link button and link this shoulder object to the box. And then test this. I'll box and rotate it around, and that looks okay. I'll select this elbow object and rotate, and that seems okay. Select this shoulder and try to rotate that, and oh my goodness, that is not okay. That's an issue. We're this very strange and bizarre scaling artifact. This is happening is because of 3ds Max's internal order of transform operations. The position is calculated, then rotation, and then the scale. And these forms are calculated relative to the object's parent. And what that means for us is that these child objects are being rotated and then scaled relative to the parent. And additionally, 3ds Max has sort of gone behind my back here, and it has applied inverse scale to this child so that when the rotation value is 0, it looks okay, but deceptive. If that child object selected and go to the scale tool and right-click on it, you'll see that the absolute Y scale is set to 25% or so. That's the inverse of the scale of its parent. In other words, the parent was scaled up to 4 times its original size in Y, and the child was scaled down to 1/4 original scale in order to compensate. If they had a value of 100, then all of the children would stretch out. This is clearly not what we want. Avoid this situation. I'll Control Z a few times and back to where I was originally. I'll put the link here as well. Just go ahead and click on Unlink Selection. And as soon as I did that, the scale reverted back to 100%, and that's good. To avoid the problem, don't non-uniformly scale anything. Or do, you'll have to take steps to correct it. The thing to do here is to leave the scale at 100% in all axes and simply change the height parameter of the box. I can set that height to be 4 times as high, or 50 times 4 is 200. And it's going to be just fine. I haven't scaled it at all. An optimal solution. However, if it's not a procedural primitive object, then you can't just adjust its parameters. What if it's editable poly or something like that doesn't have those parameters? Back down to 50. Convert it to editable poly. Click Convert to editable poly. In this case now I don't have any parameters to adjust. Instead what I'll do is I'll just go into polygon face selection mode, that top face, and move it up. It's not going to affect the transform scale at all. If I go back to object level, you see the scale values are all still at 100, 100, 100. Then solution. Undo that. A solution would be to scale all the polygons at the subobject level. If you've got a complex shape and you need to stretch it in some way, you can't select one polygon and move it. You'll need to select all the polygons, box around that. You can scale up here at subobject level. Looking at the bottom of my screen, and the Z scale value is about 400 now. And I'll raise the mouse. And I'll need to position it up as well. But having done it this way, I have not changed the scale values at the level of the object. Instead, I've changed the shape of the object at sub-object level using the scale tool. No, that's not a very obvious distinction because I've clicked on the same button to do it. The difference is whether I'm in sub-object mode or object mode. And if I do a scale operation at sub-object mode, I'm affecting the shape of the object without changing the transform values. And to prove that, I'll go back up to the scale tool, and you'll see that I got scale values of 100 in all axes. I simply create my link, test rotation, and it's fine. If you accidentally scaled the object at object level, or maybe you got a scene from someone else that had been non-uniformly scaled, what would you do in that situation? Open this scene file to get what we can do in case we get into trouble. Let's say I select the object and then scale it up. Got a non-uniform scale of about 400 in Z. I set this back to 100 and preserve the existing shape. I'll go into the hierarchy panel. And in the Adjust Transform Rollout, there's a button that says Reset Scale. I'll click on that, and now all 3 of the X, Y, and Z axes have a scale of 100. And now this is safe to link up. Go ahead and link it. Do a test rotation. Everything's fine. And that concludes our chapter on hierarchies, practices for transform coordinate systems, pivot points, linking, scaling. 3ds Max. A controller is a program module that can vary some parameter, such as animation track. Controllers can create procedural animation. It's an alternate way of making things move instead of the traditional keyframing. To this, I'll make a bouncing ball using a waveform float controller. I'll create a small sphere in my world and make it a little bit easier to see on the screen. I'm going to go into my time configuration. I want to use a custom frame rate of 15 frames a second because that's the capture rate that this movie is being delivered at. And also, I'm going to turn off the active viewport only option. That way I'll be able to see the motion in all the viewports. Okay, I'm ready to assign a controller. One way to do that is through the curve editor. The ball selected, I'll go up to Graph Editors, Track View Curve Editor. The in or vertical position of the ball is the Z position. Select the Z position track, and you'll see currently it's flat. It's in value of 0. To assign a controller, I'll go up to the Edit menu, and Controller, Assign. Now, a list of all the possible controllers that could be assigned to this track. The one with the little caret in front of it is the currently assigned controller. Float is the default controller for all transforms, and in fact for most tracks in 3ds Max. In this case, I'm going to choose Waveform Float. OK. Now child window popping up gives me control over the waveform properties, such as its period and so on. Minimize the curve editor for a moment and play back my animation so you can see that, in fact, now I've got a procedural animation. It's oscillating back and forth. Stat, go back to the curve editor. Changes, like for example, instead of a sine wave, as you see here, I'll do a half sine. As it'll bounce up and down, and it won't oscillate in that same way. It'll look a little bit more realistic. I'll choose the period, with length of the cycle. Let's get 20 frames. And let's see what that looks like. I'll minimize, rewind and play back. Wow, a pretty cool bouncing ball effect for free. However, that it's going through the floor, I go back into those parameters, and I want to position my time on frame 0 so I can see what it looks like at the very bottom of that curve. And I've got a manual bias here I can adjust. Just drag this spinner out until the ball is right on the floor at frame 0. Max view, and play it back. And the ball is bouncing up and down, and it'll actually bounce up and down infinitely because the waveform controller is now taking full control over the z-axis. A basic example of how you can use a controller to produce procedural animation. A special type of controller in which one object drives another. A common application of constraints is a constraint to a path. We can attach an object to a spline curve and it will travel down the path, moving and rotating according to the shape of the path. What we could do with that is to create a turntable animation in which a camera is spinning around an object so we can show off our model. For constraint, I'll need a constrained object and an object to which it will be constrained. So the constrained object in this case will be a target camera. I'll go to Create Panel, Canvas, Target. Click to define the camera position, hold the mouse and drag out and release to define the target position. Right-click to complete that camera. Next, an object to constrain it to, and simply be a circle. Go to the Create panel and Shapes, Circle. That out at the origin, a circle. I'll right-click to complete that and move it up a little bit. Perspective view and move up. And to constrain the camera to the circle. Let's make it bigger with Alt-W. I'll need to select the camera first. Go up to the Animation menu and choose Constraints, Path Constraint. Now 3ds Max is expecting me to click on a spline curve. Click on that circle. Now the camera is attached to the circle. I play the animation, you'll see the camera is spinning around. See what that looks like in the camera viewport. I'll view to go back to my 4 viewport layout. And I'll choose one of these viewports that I'm not using, like the front view, and choose Cameras, Camera 01. F3 to see the shaded mode. I'll use the Shift F hotkey to turn on safe frames. And when I press play, I can see the turntable animation. Wow, cool. To get closer to this, I can change the size of the circle. Like that circle, go to 5 panel, and reduce its radius. I want it to be up a little bit higher, I'll just move it up. The target is not constrained to anything. I can go to these other views and select that target. It might be a little tricky to do so. You might need to get in really close. Open that target and move it up to my model better. And I'll give focus to that camera viewport and press play. Basic turntable animation. If I want to change the speed of this, then I'll select the camera, which is the constrained object, and you'll see I've got keyframes here. Got a keyframe at 0 and a keyframe at 10 seconds. If I want to go faster, I can select this keyframe and move it to an earlier point in time. Frames represent the distance along the path. And by default, 3ds Max sets the first keyframe to a position of 0 on the path, a second keyframe to a position of 100% along the path, and stretch those keyframes across the currently visible timeline. Now it's moving faster. And give focus to the camera view once again. That's just a very basic introduction to how you can use a path constraint to create a turntable animation. Common and extremely useful type of constraint is a link constraint. This will allow you to link an object to more than one parent. The most common application of this is to transfer a linkage over time. An example with a robot arm. I want a robot arm to reach down and pick up that cylinder and bring it over here and drop it. Constraint is perfect for this. You'll notice that I've completed the animation first. It's not an absolute requirement, but it is going to make things easier. So I do recommend that you complete your animation first before you bother trying to make the link constraint. So back at frame 0, what I'm going to do is assign a link constraint to this cylinder. And at first it's going to be constrained to the room, and the robot's supposed to pick it up, then constrain it to the wrist of the robot arm. Assign controllers and constraints in multiple ways. The easiest way to do this now is through the animation menu. I've got the cylinder selected. I'll go to Animation Constraints, Link Constraint. And now 3ds Max is expecting me to click on something. I want to link it to the room first. On the room. The 3ds Max has also automatically opened up the motion panel. And you see here a whole bunch of parameters available. Specifically, I've got a rollout that's labeled Link Params. In this little window here is a list of all of the link targets. Currently, there's just one. This is telling me that at frame 0, the cylinder is linked to the room. I'll add another linked target to transfer the pairing to the robot arm's wrist. I'll move my trackbar down to the time at which I want the link to be transferred. It'll be sometime right before the robot arm lifts up. Set that to, say, 2 seconds, 25 frames. Then I'll go up to the motion panel and click Add Link, and then click on the robot arm's wrist. And a new link has been created. After that point in time, now the cylinder is linked to the robot arm's wrist. Well, that's pretty cool. And I just want it to drop, let's say, seconds, 0 frames. I'll link the cylinder back down to the floor. With the selected motion panel, you'll see that the Add Link button is still active. All to do now is click on the room, and now the object is linked back to the room at frame 150. It's dropped by itself. I'll have to animate that in the next movie. When I'm finished, I want to turn Add Link back off again. 3ds Max have quite a lot of flexibility. In programs like Maya, when you assign a constraint to a transform channel, that's it. You can't animate the object in the traditional way. But in 3ds Max, you can, because there's a system of layering to the controllers and constraints. It kind of happens for you by default. It's very convenient. Now, I do any animation on cylinder proper. I've just got some link constraints. And I animate that cylinder dropping. And then position that at about 5 seconds in. That cylinder, and I'll keyframe it. Use these keyframes here now. Those are the link keyframes that correspond to motion panel targets here. I want to frame the position and rotation for the cylinder at this point in time at 5 seconds in. My key filters and turn on position and rotation. I'll set key, click skeleton key, and got position and rotation keyframes at that point in time. Then let's go a little bit later, maybe 15 frames later or so. Move tool and position the cylinder, and maybe I'll rotate it too a little bit. and the skeleton key again. You can see, even constrained to the floor at that point in time, I'm also able to animate it as well. Maybe that keyframe a little bit earlier to speed that up. Pretty cool. And that all happens because 3ds Max has something called a list controller added by default. Set key. I'll go up to the motion panel to assign controller, and you can see that the link controller in effect, but I open that up, there's also position and rotation controllers inside that. So I've got nested controllers there. It's a useful feature of 3ds Max, and it makes so you don't have to actually build a separate hierarchy in order to animate constrained objects. Basic introduction to controllers and constraints in 3ds Max. Again, it's a very powerful set of tools that you can use to animate objects. The modeling, materials, camera and scene layout, lighting, and animation for a shot, your final result will be rendered to a series of images on disk. The chapter is about is rendering. Render in production, you always render to an image sequence, a series of individually numbered still frames. And that's what you see here in my exercise files folder. Render output logo animation. Just page through this these frames one at a time. Do this. Why just render directly to a movie? Well, there are a lot of reasons why. For one, if you render directly to a movie file, then there's a good chance that if your machine crashes or it goes wrong, the entire movie will be lost. Or if you render to individual still frames, then if something goes wrong, you can just pick up the rendering on the next frame. And this is really important, especially if you're taking a really long time. It's not unusual in feature film production for a frame to take at least a half hour to render just one frame. But it might take months to render your entire movie. Another reason why you would render to an image sequence is because if you render to a movie file can end up being very, very large. In fact, just at standard definition video, a minute of uncompressed footage is going to be almost 2 gigabytes in size. And that can get very unwieldy. If you've got a large image size or a long sequence, it can add up to be sometimes tens of gigabytes, and you can actually exceed the capabilities of your computer or file system or archive media. And reasons, you always want to render your final production to a series of numbered stills, as in here, and you can take it into some other program like QuickTime or After Effects or Final Cut or Premiere or whatever. Take that image sequence into an editing or compositing program and use that program to compress it to a movie file. Got a little flying logo animation here. I need to render this out to an image sequence. I'll go to the Render Setup dialog here and play around with some of the properties of the renderer. First thing is, of course, whether we want to render out to a single frame or to a sequence of images. And the active time segment, the full 180 frames of my timeline. I could use an alternate range if I wanted to. This time segment is what I want this time. I need to set the output size here, the pixel resolution of the image. Now it's at the default of 640 by 480. And then fine. If it's something else, I could go to this output size pull down and choose something else like HDTV. And of course, as you note, if I change the resolution, that's going to change the aspect ratio in my camera view. And I'll only be able to see that if I have safe frames enabled in camera viewport and are enabled currently. Just switch this back to the default of 640 by 480. Scroll down a little bit. I also have a choice of renderers. Here at the very bottom of the Common tab, you will see Assign Renderer. And you open that rollout and assign different renderers to the Production Renderer or the Active Shade Renderer. Right, both set to the default Scanline Renderer. If I want something else, I would click here on this little Browse button. A pop-up dialog here. Out of scope for this training title for us to talk about all the different possibilities of the different renderers, but you see we have a lot of choices here. I'm going to leave it at the default, which is the scanline renderer. The most basic options, but need to set the file output, and we'll do that in the next movie. To disk, I have to specify a file output, a location, and also an image file type. Right now I haven't done that. And if I click the render button now, I'll actually get a warning message that says, "You're rendering a sequence with no assigned file. Frames may be lost. Do you want to continue?" Well, it should say, "Frames will be lost." It's not a question of if, it's absolute. If you render without specifying a file output, what will happen is 3ds Max will draw the images onto the screen, but then nothing will get saved on the disk. No, I don't want to continue. I'll bomb out of there. I'll down in the render setup window and for render output. And currently, no file has been assigned. I'll click on the Files button here, and here's where I get to define where I'm going to save to and in what format. You see that it's taken me directly to my current project, which is exercise files, and the render output folder. I recommend that you create a subfolder within this. It's a good idea to make a folder for each and every image sequence that you create. If you're doing a movie, you might have a project that has 100 different shots in it, and you dump those all into the same render output folder, it's going to be very confusing because you'll have thousands and thousands of files there. I recommend that you create a subfolder and call this low animation. Then I'll double click on that to go into that folder. And now I need to give a file name. And all this one. And I'll put an underscore after that, just convenience sake. 3ds Max is going to append a number to the end of every frame, and it's just a little bit easier to read if I put in an underscore. I also need to define a format. That there are a bunch of options here in the Save As Type pull-down list. What's here? Well, I'll tell you what's not good, JPEG. You never want to render directly to a JPEG file unless it's just for preview purposes, like if you're doing dailies, something that's going to be reviewed, and you don't really care if it's in full production quality. A JPEG file is always lossy compressed. And it becomes a real problem if you take a JPEG file into a compositing program and then to change its contrast or color or something like that. You want to save your renders to an uncompressed or a losslessly compressed format. It is actually PNG or Portable Network Graphics. Not yet set the options for the PNG format. Click the Save button, the configuration dialog pops up. I've already played around with this a little bit, and so it's actually not at the default values. The default is in fact RGB 48 with an alpha channel. 48-bit file is a high dynamic range image, and programs won't be able to read that. I recommend that you choose RGB 24-bit. The alpha channel is the transparency. If I was going to layer this with any other images, then I might need an alpha channel to do that. But this one already has a background in it. The alpha channel off. Okay, both of those dialogues close. I need to go back in there and change those. I can click on the Files button again. And if I need to change my file format options, I can go here and click on Setup. Don't be dismayed or confused that it's grayed out. That's actually a minor bug in the program. It doesn't matter that it's grayed out. I can go ahead and click on that. I might need to do it more than once, and then I can get back into that configuration dialog. So all of the options for my rendering, I've got file location, I've got render size, and I've got a duration of 180 frames. Good idea to save your scene at this point, and then click Render. 3ds Max draws the frames to the screen as we go. And that's very convenient because we can see what's happening as rendering. It's also giving us some really helpful feedback here about how long it might take to render. At forward, you'll see that each frame is taking longer to render, because 3ds Max is calculating these ray traced reflections on the logo. In tests with this, it took about 20 minutes to render on my machine here at lynda.com, but it's a pretty fast machine, so your mileage may vary. Is an extremely powerful, yet relatively easy to use program. I hope that what you've learned here will inspire you to go on to create incredible things: movies, animations, games, visualizations of interior designs, and so on. We've got lots of other great titles on 3ds Max here at lynda.com, so please explore the rest of the online training library and go out there and do incredible things with this powerful software. I'm Aaron F. Ross. I'd like to thank you for listening and say goodbye.